As companies increasingly shift workloads to the public cloud, cloud computing has moved from a nice to have to a core competency in the corporate world. According to the studies, 60% of corporate data is already over the cloud, and major service providers who hold an abundance of this data are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. However, AWS is recognized as an industry leader in this field of cloud computing. This is not at all a vague statement. The tycoon research organization such as Gartner believes in the same. They consider AWS as a thought leader and point of reference for all cloud computing competition. And owing to the facts such as overwhelming growth in the cloud sector and AWS being the top cloud service provider, the demand for AWS cloud computing certificates is exponentially higher. By listening to these facts, if you wish to get into this lucrative cloud industry, then we are here to give you a head start. We bring you an exclusive session on AWS where we cover all the fundamental tools AWS as a cloud provider has to offer. But before we begin with that, please make sure that you enable both the subscribe button and bell icon so that you never miss out on any update from Intellipaat YouTube channel. We'll start this session on a friendly note by covering what is AWS. Then we'll discuss about how to get an AWS job as a fresher. Next, we'll cover volume and snapshots in EC2 instance, Windows EC2 instance with only C drive, and creating additional volume for user data. After that, we'll cover what is dedicated host, how IP addressing works, basics of networks, etc. Once we are clear with all the basics, we'll dive into AWS Networking, VPC NAT Instance, Internet Gateway and Route Table on AWS. Moving further, we'll cover NACL versus security groups and VPC Peering. And finally, we'll cover AWS interview questions and answers. I hope I have made myself clear with the agenda. So without further ado, let's dive into the session.
AWS was introduced in 2006, and since then, they have been the largest player in the public cloud market. According to Forbes, AWS grew $4.3 billion revenue just in the second quarter of 2021. The top 3 companies who offer cloud services in terms of market share are Amazon Web Services, Microsoft Azure, and Google Cloud Platform. AWS by itself covers 32% of the public cloud market share. So what exactly is AWS? Amazon Web Services or AWS is a cloud service provider owned by Amazon. It offers cloud services in compute, storage, database, content delivery, networking, and other domains. Most of the offerings from AWS are infrastructure as a service offerings, but it also offers PaaS service such as Elastic Beanstalk and Lambda, which are popular and highly used services. AWS offers you all the necessary tools you would need to set up your IT infrastructure without paying any upfront. For example, Netflix, the world's biggest premium video streaming service, is completely hosted on AWS for its application needs. The world's largest e-commerce company, Amazon, is also hosted on the AWS infrastructure itself. When you see such big players in the respective fields rely on AWS for their infrastructure needs, you as an individual user can trust and be inclined towards AWS for your cloud needs. AWS offers a wide range of services that can be categorized into the following. We have compute and network services, storage and content delivery services, security and identity services, database services, analytics services, application services, and management tools. Now we have few applications of AWS. What are they? Let's look into it. The first one we have is storage and backup. That's Amazon's cloud storage is an easily accessible and useful services for business. Next we have enterprise IT. That's Amazon Cloud Services offer the ideal solution to enterprise IT's time-consuming pace. Mobile, web, and social applications. AWS can launch and scale various applications like mobile applications and SaaS applications. Big data. AWS and big data work well with each other to come up with the power, and infrastructure necessary to meet the needs of high-end intelligent software. Websites can be hosted on AWS Cloud. It is also good for hosting CDNs and DNS and domains. In gaming, AWS makes gaming applications easily available to the worldwide gaming network and provides gamers the best experience in online gaming across the globe. Now, how much salary does an AWS engineer earns? In India, it earns on an average basis 7 to 13 lakhs per annum, while in USA on an average basis, he or she can earn $137,000. The reason why Amazon is so huge is because of AWS along with its retail arm. The cloud service has a very high revenue and is growing rapidly. Now, did you know that AWS IaaS Cloud is 10 times greater than the 14 competitors of AWS combined? Now, this speaks volumes about the strong capabilities that this service possesses.
Just a quick info, guys. Intellipaat offers advanced certification in DevOps and cloud computing in collaboration with IIT Pravartak, a technology innovation hub of IIT Madras. This online advanced certification in DevOps and cloud computing by IIT Pravartak will help you gain expertise in DevOps, access management, DevSecOps, Terraform, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel. The link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take your first step towards career growth in the field of cloud and DevOps.
Why make a career in AWS? Technical people with AWS abilities have a variety of career options based on AWS positions or particular cloud services to choose from. For instance, one may specialize in areas like machine learning and storage management to become an AWS cloud practitioner or solutions architect. A career in AWS would include taking unexpected turns and adopting new viewpoints. One would have to think creatively all the time and be continually challenged. This is due to AWS's commitment to ongoing evolution and desire to alter the face of technology. AWS Certified Solutions Architect, DevOps Engineer, SysOps Administrators, and Certified Developers are a few of the highest paying AWS positions based on certifications. Let's move on to our next agenda, which is the skill set required to make a career in AWS. AWS is a secure and dependable cloud computing platform. It boasts millions of customers, including startups, major corporations, and top government agencies, and provides over 200 fully featured services from data centers all around the world. Users can utilize managed databases like MySQL, Oracle, or SQL Server to store information, transmit mass communications and content to clients, and securely store all files on the cloud for convenient access. First skill is communication. The ability to communicate clearly both orally and in writing is necessary for working as an AWS professional. The collaborative process is the key to building effective systems. To do that, experts from many departments must collaborate closely and communication is essential. Consider someone who wants to become an AWS cloud architect. In that situation, having excellent design skills will be useless if they're unable to communicate their visions to managers, software engineers, and other architects. They must be able to effectively communicate their thoughts in emails, documents, and presentations. Next up, we have programming languages. The most popular programming languages among AWS experts are Python and Java. Although coding is not a must for all AWS job pathways, it is generally vital for an AWS expert to understand programming in order to provide practical, sensible solutions that would function as intended. Since they are development-related occupations, certain roles like developer and DevOps engineer demand in-depth coding skills, whereas solutions architects or SysOps administrators don't. However, given that application development is a significant use case for the company's cloud architecture, a fundamental understanding of programming languages is definitely advised for anyone interested in pursuing an AWS career path. Next up, we'll talk about networks. It can be difficult to develop a secure cloud-based solution without knowing how networks work. This is why certain positions require knowledge of a few networking concepts such as domain name system, that is DNS, transmission control protocol, internet protocol, that is TCP/IP, hypertext transfer protocol, that is HTTP, content delivery network CDN, and virtual private network, that is VPN. Utilizing public and private subnets, the internet, and VPC peering, one should be able to build cloud networking blueprints using AWS CloudFront, AWS Virtual Private Cloud, that is VPC, and services like AWS Route 53. Now the fourth skill is called problem solving. Working with AWS requires critical thinking and analysis. This entails gathering data as well as seeing basic trends and patterns in simple to somewhat complicated data. For instance, a solutions architect's job entails a significant portion of generating technical solutions, pre-sales deliverables, and solutions to fulfill the needs of customers and company objectives. The AWS platform is built on the idea of continuous improvisation, which calls for a focus on finding solutions. Next up, we have cloud security. Enterprises have historically exercised caution when it comes to hosting their data in the cloud. However, cloud security has considerably improved over time, fostering greater user confidence. AWS employees with security expertise are in more demand as a result of this obligation falling on cloud security experts. People who are interested in a profession in AWS cloud security may find it financially rewarding. After this, we'll talk about DevOps. One of the top skills to possess for someone looking to work for AWS is DevOps. Automation is the key to operational excellence, and DevOps engineers are involved in the process. When transferring code from development to production, DevOps automates tasks including monitoring, testing, integration, and deployment. Software as a service applications benefit from DevOps' emphasis on continuous development, integration, and deployment since SaaS applications flourish on the cloud. This model is revolutionary and has helped organizations innovate, making it a useful AWS expertise. Up next, we will talk about multi-cloud environments and cloud migration. According to the Multi-Cloud Management Survey, which was carried out in August 2019 by the market research firm IDC, 93% of respondents used various infrastructure clouds for their business operations. Organizations frequently have heterogeneous environments that are challenging to adopt, maintain, and optimize, even inside multi-cloud. According to the survey, 81% of respondents utilize a combination of private and public clouds. 11% rely on numerous private clouds, and 5% combine public and private clouds. However, these businesses frequently struggle to find full-time workers who can support their cloud migration initiatives. For those with experience in cloud migration, this presents a fantastic opportunity. The next skill is to have a knowledge about containers. A popular method for combining your application's code, configurations, and dependencies into a single object is to use containers. In order to ensure quick, dependable, and consistent deployments, regardless of the environment, containers run as resource-isolated processes that share an operating system installed on the server. Container knowledge is one of the most important skills for AWS employees to possess. It is highly valued to have knowledge and experience with Docker, Jenkins, and Kubernetes. Because they make it possible for businesses to develop hybrid apps, package batch processing tasks, and scale machine learning models, containers are becoming more and more popular. Amazon E2 is one of the most widely utilized containerization enablers on the market, and AWS's container services are actually extremely widely used. Up next, we'll talk about serverless architecture. The ability to migrate serverless apps from one cloud provider to another is made possible by the industry standard technologies and programming languages of today. Due to the simplicity of scaling up and making modifications to these services, serverless applications development has grown into its own niche. Many businesses are increasingly giving it priority since it offers much more than just better server abstraction. Client demand for products like AWS Lambda has increased over the past few years. Therefore, AWS staff members need to be knowledgeable about serverless architecture. Lastly, we'll talk about infrastructure as code. Infrastructure as code, which enables technical experts to optimize IT systems using software code, alters infrastructure management. Instead of employing physical control systems or manual labor, one can deploy machine-readable configuration files that remotely and automatically alter the IT infrastructure. Users can supply infrastructure using declarative and automated methods thanks to IAC, that is, infrastructure as code. It makes it possible to utilize the same tools like Git and procedures like code review for your infrastructure as you do for your code. The CloudFormation service, which uses the understanding of resource provisioning using JSON or YAML languages, has been used to implement IAC on AWS. Let's take a look at different career opportunities. Firstly, we'll talk about cloud developer. The annual wage is typically around $132,000. An AWS developer creates enterprise-level software services and applications. To get and succeed at an AWS cloud developer job, you typically need prior experience working as a software developer and working understanding of the most popular cloud orchestration technologies. Up next, we have cloud data architect, and the salary range is around $130,000 to $140,000. Cloud database administrators or data analytics experts who understand how to use AWS database resources, technologies, and services to unlock the value of enterprise data may be cloud data architects or cloud data engineers. After this, we'll talk about cloud DevOps engineer, and the average or the annual wage is around $118,000 to $138,000. AWS DevOps engineers create AWS cloud solutions that influence and enhance the company's operations. Additionally, they maintain servers and apply any necessary patches or bug fixes. Next up, we have cloud architect, and the annual wage is in the range of $148,000 to $158,000. Highly available, economical, and scalable AWS cloud environments are designed, built, and maintained by AWS architects, AWS cloud architects, and AWS solutions architects. They stay current on developments in cloud computing and offer advice on AWS toolkits. Professional AWS cloud architects drive implementation activities, deliver technical architectures, and ensure that new technologies are successfully incorporated into client settings. This position interacts with client-side stakeholders while also offering technical leadership and working closely with engineers and customers. On number 5th, we have cloud network engineer, and the salary range is around $107,000 to $127,000, including cloud network professionals, engineers, and architects assist enterprises in successfully designing, constructing, and maintaining cloud-native and hybrid networking infrastructures. Moving further, we have cloud systems administrator, and the annual pay range lies within $97,000 to $107,000. A successful provisioning, installation or configuration, operation, and maintenance of virtual systems, software, and related infrastructures are the duties of an AWS SysOps administrator, also known as a cloud systems administrator. They create reporting dashboards and maintain analytics tools. Up next, we'll talk about cloud consultant, and the annual wage lies within the range of $104,000 to $124,000. Cloud consultants offer technical know-how and strategy to enterprises for creating and implementing AWS cloud solutions or for consulting on particular problems like performance, security, or data migration. And lastly, we'll talk about cloud security engineer, and the annual pay on average lies within the range of $132,000 to $152,000. By designing and implementing security measures in accordance with the most recent security best practices, cloud security engineers maintain regulatory compliance, offer security for AWS systems, and safeguard sensitive and secret data. Let's take a look at our next agenda, which is the benefits for opting a career in AWS. Firstly, we have more respectability. Obtaining an AWS certification or an AWS career will not only broaden your understanding of cloud services, but also raise your credibility. Having credentials will provide you access to more options. The second benefit is more employment options. There are many work prospects in AWS-related projects, if you are an AWS certified professional or a recent graduate. Next comes enhanced abilities. AWS certification aids in skill development and risk mitigation when implementing AWS projects. Next up, we have increased pay. The most lucrative certification in the US is AWS. Not every AWS certified individual earns a high salary though. High skill levels are rewarded with higher compensation. The fifth benefit is increased consumer demand. Being the most sought after certification today, AWS will put you in high demand in the IT industry, open up new options for you, and improve your chances of landing a job. And lastly, we have current knowledge. You often stay current when working on credentials or keeping up with the industry. Due to the fact that you must participate in 2 yearly checkpoints, you must also maintain your certification. If you feel the need to advance further, you can always meet the requirements for another certification and become one of the most selected few AWS certified professionals.
Just a quick info, guys. Intellipaat offers advanced certification in DevOps and cloud computing in collaboration with IIT Pravartak, a technology innovation hub of IIT Madras. This online advanced certification in DevOps and cloud computing by IIT Pravartak will help you gain expertise in DevOps, access management, DevSecOps, Terraform, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel. The link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take your first step towards career growth in the field of cloud and DevOps.
So guys, what we'll do is, see, volumes you all know in EC2, volumes are like hard disk where you can store your data, correct? Like with your laptop, you have the volumes, you have C drive, D drive, which contains the data. So it is the secondary storage, okay? The volumes are, and snapshot is nothing but a point in time image of your volume. Okay, guys, so snapshot is nothing but a point in time image of your volume. So today here, first, what we will do is we will do the backup and restore of our data. We will do a lab on backup and recovery of the volume data of EC2 volume data, correct? Right. So step by steps, guys, I have written the steps here. So we'll create, what we'll do is, the first step is, I'll just write down the steps here. And then we'll go and do the lab with those steps. So guys, first of all, we'll go and create an EC2 instance. That's a Windows EC2 instance, correct? With only C drive. Okay. First, we'll create a Windows EC2 instance with only C drive, guys. That is root EBS volume. Okay. And then what we will do is we will create, first we will create this EC2 instance with just the root volume, guys. And then what we'll do is, step number 2 is we will create the additional volume for the user data. That is, we will create a D drive. Okay. The additional volume for the user data once the EC2 instance is created. So here, since you're already aware about the console and stuff, so let's go and create an EC2 instance first. And we'll go and create a Windows EC2 instance, guys, here. Okay, so let's go and create a Windows EC2 instance. So let's do it. I'll say launch instances. Okay, and then I'll give the instance name here. So I can give any name. Let's say I give it a name, VM1. Then here it is telling you AMI stands for Amazon Machine Image. Here you can select the operating system that you want, whether Linux or Windows, or even now AWS has a support for Mac OS. Previously, it was not there few months back. Okay, so whichever OS you want to select, you can select through AMI, Amazon Machine Image, plus the architecture is decided with the AMI. So we'll go with Windows OS, and we'll go with the version as Windows Server 2012 R2 base. Why? Because our size will be T2 micro. So to run it a bit faster with that, because it's not a very good size, right? So that's why I'll not go with Windows 22, but Windows 2012 R2. So Windows 2012 R2 selected. Then guys, instance type. since you have studied about EC2, so you all must be knowing about the different families of instances, correct? So there are many families available here, like you have T family, M family, and so on, guys. And every family has a different use case, correct? You can compare these families as well. You have T family, M family, C family, and so on. So like T and M family are for general purpose usage. Some are for memory optimized use cases, correct? So different families with different use cases, and in every family you have different sizes again. Like in T family, you have T1 micro, T2 nano, T2 micro, and so on. So T2 micro like has 1 vCPU and 1 GIB of RAM capacity. T2 small has 1 vCPU and 2 GIB of RAM capacity, and so on, guys. Correct? Okay. So that's how it goes. Fine. So let's go with T2 micro because that is free tier eligible. You will not be charged for creating this instance because we are creating it in the free limits. Okay, so you have 1 year for free. Use when we are using Mac. So of course in Mac also you can go with the size that is free tier eligible. Okay, but rather go with Windows here. So T2 micro C, it's not free tier eligible. The architecture of AMI is not supported by this instance type. So you'll have to go with the paid type then in Mac OS. And you'll have to pay for it. So, right. So you can see if in Mac you get something for free. Otherwise, anyways, here you just need to go with Windows. And why we are going with T2 micro, how you will be able to know or select. So you can see it is free tier eligible. That's why. Which will give you 1 vCPU and 1 GIB of RAM capacity, memory capacity, mean memory capacity. Then key pair, guys. So now see, to connect to your Windows machine, you'll always need a username and a password. Correct. So the point is that to get a password, you need a key pair. Okay. Yeah, Windows 2012 R2. Let's select that. Thank you. Anyways, Windows 22 base would have worked, but my machine would have ran slower then. Right. So that's why I'll go with Windows 2012 R2 because with T2 micro, the configuration is less and that's why. Yeah, you can reuse the key pair that you have created before, or you can go and create a new key pair as well. Okay. So fine. So you can just go and say, create a new key pair. Let me create a new key pair and I'll say my KKP, let's say 25 today's date. Fine. And now you all must be knowing about the PEM key and PPK key rule. If not, let me just put it here. So guys, the point is that, let me write it here, that if your laptop, that is if your base machine or if your physical machine, that is your laptop is, let's say, has Windows OS, which OS? Windows OS. And your virtual machine, the virtual machine that you are creating in AWS, let's say, if that has what? That has, again, Windows OS, then to connect to that virtual machine, you will need a PEM key pair. Which key pair? Both are private key pairs, PEM and PPK. So, but then if your laptop is having Windows OS and your virtual machine is also having Windows OS, then you need a PEM key pair to connect to that virtual machine. Correct. Similarly, if your physical machine is Windows, but if your virtual machine is having Linux OS, so you will need what? You will need a PPK key pair, guys. So you will need what? You will need a PPK key pair, okay, to connect to that virtual machine. And then if your physical machine is, let's say, Linux, and your virtual machine is, let's say, Windows, then you will again need a PEM key pair. Okay. So this is the thumb rule. Okay.
Let's have a quick quiz question, guys. And the question is, which AWS service provides a fully managed container orchestration platform for running microservices at scale? And your options are AWS Lambda, Amazon Elastic Container Service, Amazon Elastic Kubernetes Service, Amazon Simple Queue Service. Please mention your answers in the comment section below.
That you need to follow. And if your physical machine is Linux and your virtual machine is also Linux, so then you will need a PEM key pair again to connect. So yeah, so that is what it is there. Correct. So this is the thumb rule. So if your laptop is having Windows OS and your virtual machine is also having Windows OS, then you need a PEM key pair to connect to that virtual machine. But if your base machine is Windows and virtual machine is Linux, then you'll need a PPK key pair. If base machine is Linux, virtual machine Windows, then PEM key pair, and base machine Linux and virtual machine again Linux, so again PEM key pair. So there's only one combination where you have to go with PPK key pair. That is when your virtual machine is Linux and your base machine is Windows. In rest, all the combinations, you have to go with a PEM key pair only, right? Okay, so that is the point. Yeah, and what if your physical machine is Mac OS or your virtual machine is Mac OS? So whatever the rules applies for Linux OS, you can have it applied for the Mac OS as well here, right? Correct. So that is the case. So this is the thumb rule, guys. Thumb rule that you have to follow, correct? Yeah. You don't have option to T2. Of course, you can change the region. You can go with North Virginia, maybe in the region where you are. It may not be supporting T2 micro. That may not be available right now. From where you need to change the region. So, of course, from here, North Virginia, you can change the region. Okay, click on some other region. Or if you don't have North Virginia, click on North Virginia. So PEM can be converted to PPK and then you can connect to your Linux virtual machine. It is PPK key you need to connect to your Linux VM from your Windows VM. So either you can create a PPK key pair only, or you can create a PEM key pair and then convert it to PPK key pair. Okay, so you can do that with putty key generator. So you can convert PEM key to PPK key as well, and then you can connect to your Linux VM from the Windows physical machine, or you can create a PPK key pair itself and directly connect to your Linux VM from your physical Windows VM. Yeah, so both ways are okay. Can we create PEM key now? For Mac, both will work, but you need install Microsoft Remote. Yeah, okay. Okay, so here you need to go and see, this is the key pair I'm giving name. I'm creating a PEM key pair since my laptop is having Windows OS and the virtual machine I'm creating is again Windows OS. Fine, guys, this is done. Then go to network settings. Now see, every virtual machine that you create has to be created inside a network. Has to be created inside a network, that is a VPC, virtual private cloud. Now you can go and have your own VPC and you can create the VM inside that VPC, or otherwise you can go with the default VPC as well. So let's go with default VPC and I go with that. So I'll go with default VPC, guys, and then I'll go with the subnet preference, again default, right? So now I don't know whether this was told to you or not in the EC2 session, but since I am taking it up for you here now, so I'll tell you this thing, guys. So tell me one good thing. When actually there was a famous politician who once said that cloud, it resides in the sky, and whenever it rains, the data in that gets wet. Okay, so of course this is all not correct. So where cloud resides, guys, structurally, where it is, guys, it's nothing but in your data centers, correct? So it's a collection of your data centers, correct? So now this is something that you may be knowing about it, but still I want to take this up because how would I know that you know it? And if you don't know it, then I want you to know it. Okay, so let's get it known. Okay, so here you can see, so this is your data center, image of a data center. Now inside a data center, you have multiple racks, and on each rack you have multiple slots, and in each slot there is a physical server, and on top of every physical server, you can create and run multiple virtual machines with the help of a hypervisor, correct? So now the point is that all these physical servers along with the VMs are connected with each other in a data center that are in different racks. Plus this complete data center is connected with another data center in the same region. Plus in another regions also, all these data centers are connected, guys. And that forms your cloud. And that is basically cloud for you. Structurally, that is how your cloud is, guys. Okay, so if I would just show you this diagram. So in this diagram, what you can see is, so as I told you, these public cloud platforms like AWS, Azure, they have their presence across the globe. Okay. So now the point is that since they have their presence across the globe, so they have their data centers spread out across different regions. Okay. So let's say in Mumbai region, Mumbai, India region, let's say there are 3 availability zones. Now, guys, what comes to point is what is an availability zone? So availability zone, on a high level, you can just think of it as a data center. So one availability zone is equal to one data center. But actually inside one availability zone, you can have one or more data centers as well. Okay. So let's say here availability zone 3 has one data center. Then availability zone 2 in one facility. Availability zone 3 has one data center in one facility. Now, what is facility? So facility can be a room and infrastructure building. So that's basically a facility for you. Okay, so here you can see in this image, in this diagram, that availability zone 3 has one data center in one facility. Then availability zone 2 has 2 data centers in 2 facilities. And availability zone 1 has 2 data centers again in one facility only. Right. So this can be any match around. Right. So this is how it can be. So now the point that I was on is that structurally how cloud looks like is collection of the data centers that are in different regions plus in same region and in different regions that are connected with each other. And that forms your cloud. Right, guys. And inside these data centers, you have racks, and on multiple racks, you have multiple slots. And then on any slot, you can create and run a physical. Create and run a what? On every slot there is a physical machine, and on that machine you can create and run your virtual machines. Right. So that is what is your cloud is, right? So this collection of data centers that are not just in one region but across different regions, and they are connected with the internal network of AWS or Azure, and that forms your cloud. Correct. So what is VPC? VPC is virtual private cloud. So actually, all these data centers from different regions are anyways connected with each other using their default network, correct? So using the network of AWS, implicit network of AWS, they are connected with each other. Okay. And while you create your network, while you create your VM, you can create it inside a default VPC, default network, or you can have a custom VPC as well. We will study how we can create custom VPC later. Okay, what is a hypervisor? So that must have been covered then. That was before, but anyways, it's nothing but a software program that you can, on top of which you can create multiple virtual machines. So it allows multiple virtual machines to be created on a physical machine. Okay. Now, there is no limitation as such, but then it depends on your underlying physical machine, how many resources it has. Because when you create a virtual machine with the help of a hypervisor on top of your physical machine, so your virtual machine utilizes the space, utilizes the resources of your physical machine only. Like if your physical machine is having 8 GB of RAM and 4 vCPU, so out of which 1 vCPU and 1 GB of RAM, you can give it to your virtual machine, okay, from your physical machine, correct? So creating too many virtual machines will consume more resources from your physical machine, and that can make your physical machine quite slow in nature. Okay, but yes, in cloud, of course, you have many physical machines and you can always create virtual machines at your will. I can just show you one diagram here, since you have told me had some queries on hypervisor a bit. So I'll not get into the details of that right now because I'm not into that topic anyways, but I will just show you one presentation image here. So, so in this particular presentation, as you can see, on the top are the, on the right are, on the left are the Docker containers. Don't worry about that right now. But here on the right, you can see on one physical server, one infrastructure, I've created multiple VMs, VM with app A, app B, app C. So there are 3 VMs, one with app A, app B, and app C, right? And they have been created on top of one physical machine, one infrastructure with the help of a hypervisor, right? So that's how it goes. And that's why there is KISS2S. But then these virtual machines will be using the resources from this underlying physical machine only, right? So that's the point. Okay. Okay. Yeah. So then where I was. So see, what I was trying to tell you in the middle of the things, guys, that when you create your virtual machine, you can decide on the region and the availability zone in which you want to place your VM. Like you can go to these network settings, and then with the subnet, you can actually decide that in which availability zone you want to create your VM. So you have decided the region will be North Virginia, and then inside North Virginia, you have 6 availability zones from 1A to 1 F, correct? 1A to 1F. So 1A, 1B, 1C, 1C, 1D, 1E, 1F. Okay, so you can actually tell this to my Amazon that, okay, I want to create this VM in North Virginia region under availability zone 1A. Correct. So the point is, guys, it is an option given to you to choose your availability zone as well, but it is not mandatory. So if you say no preference, then my Amazon will put your VM in any availability zone inside North Virginia. But yes, the region you always have to decide, has to be selected by you only. And then availability zone, if you don't select it, then Amazon will try to place it in any availability zone inside North Virginia. But you will come to know that in which availability zone your VM is residing after your VM is created. Okay. But if you want, you can give the preference, let's say 1A. Now, or 1B, or whatever availability zone that you want. Now, guys, the point is that you are being given the authority, the liberty to choose your region plus the availability zone where you want to create your VM. But the point is that, is Amazon giving you the chance to select on the rack in which you want to create your VM, on which physical server you want to create your VM? Is it something that Amazon gives you the authority of? The answer is what? No. Of course, a big no. Why? Because these are hardware changes, and that's why Amazon will only do it, right? So guys, yes, but you can decide on the region and the availability zone. Fine. And you know one thing, so in public cloud platforms, it is like anybody can create their account on public cloud platform, like you, me, even an attacker can. Do you all agree with me? Do you all agree with me? Yes, of course. Right. So anybody can create their account on this public cloud platform. And if that is the case, guys, who knows that, let's say if my virtual machine, which I'm creating, I can select the region and availability zone, but on which physical server my VM would be created inside that region availability zone is something that I don't know. On which rack, which physical server my VM would be created, that I don't know. Correct. So let's say if my VM has been created on this physical server. So are there not chances that somebody else's VM can also be created on the same physical server? The answer is yes, of course, that can happen. And guys, that someone else can be an attacker as well. Correct. So that can also be the case. But still, Amazon will provide you the good security measures to keep your machine secured. Correct. Virtual machine secured. But if you want heavy security measures, maybe if you don't want that that physical server on which my VM is getting created, that should be given to anyone else. So do you have that option to actually select it in Amazon? Can you tell Amazon that, hey, Amazon, on whichever physical server you are going to create my VM, you're not going to tell me on which physical server you are going to create my VM in the cloud, but on whichever physical server you will create my VM in the cloud, make sure that there is no other VM of anyone else on that particular physical server. Okay. So can you make this thing happen in Amazon, guys? The answer is yes. Okay. But yes, of course, that would be chargeable option. For that, you'll have to pay for the complete physical server. Okay. So yes, but then that is possible. And how that is possible, you don't even have to go to private cloud. It's pretty much possible by an option in EC2. So you can just go in the advanced details and you can go with Tennessee option. So by default, it is shared only. Where is the Tennessee, guys? I'm not getting that. Yeah, here it is. Tennessee, correct? So here you can see Tennessee. So by default, it is shared only, guys. And if you don't select it, or if you select it, then also it would be shared. And then if you select shared, then it would be shared. And then if you select dedicated, then it would be dedicated. And once it is dedicated, then on the physical server where your VM is getting created, nobody else's VM can reside on that physical server. Okay. So that is something that you can tell Microsoft. So of course, Microsoft will not tell you on which physical server it is creating your VM, but yes, it can make sure that on that physical server, nobody else's VM is getting created. Not even in an attacker's VM or even in legitimate user's VM, correct? So this is something that you can tell Microsoft. You can have it, sorry, from Amazon. You can have it allowed from Amazon. See, dedicated and dedicated host, correct? So dedicated host means launch this instance on a dedicated host means, I think with this, that host will not be given to anybody else, like even your another VM, run a dedicated instance. Okay. 1 second, dedicated host. That complete host would be dedicated to you. Complete physical machine would be dedicated to you with a dedicated host option. Okay. And then anybody else's, I think your VM, your another VM cannot be created on that physical machine, correct? But with run a dedicated instance, it is like only your different VMs can reside, but nobody else's VM can decide on that physical machine, right? So the type of tenancy, dedicated tenancy instances run on single tenant, dedicated hardware, correct? So dedicated instances, tenancy instances run on a single tenant, dedicated hardware. Host tenancy instances run on a dedicated host, correct? So here is the difference. So dedicated tenancy instances run on a single tenant, dedicated hardware, okay? Whereas host tenancy instances run on a dedicated host, correct? So that's the point, right? Fine. Anyways, if you go with dedicated, it's like you are going to get like dedicated server. With dedicated, you can take it like that you are going to get a dedicated server only for your, only for you. And then if you are going with shared, then it is like somebody else's VMs can also be created on that physical server. Okay. So I hope this is clear to you guys, but of course, extra charges will apply if you go with the dedicated option. And by default, it is shared only. Right. So yes, you can decide that on the physical machine where your VM is getting created, nobody else's VM, you can say an attacker's VM or nobody else's VM can get created, right? Yeah, I think then you should be getting that, Rohit, right? Okay. So that's the point, guys. I hope this gives you some insight on the shared and the dedicated instance. And yeah. I don't know whether this was discussed with you or not, but this gives an insight of the things. Well, but if it was discussed, then you may have found it repetitive. Okay. Fine. So then it is good. Yeah. So then auto assign public IP. So I'll say allow it, enable it so that public IP would be assigned to this VM. And guys, firewall security group. So basically security group decides that which traffic is allowed to come inside your VM or which traffic is allowed to go outside of your VM, correct? Yeah. So even for tenancy, I can just give you this note as well. Right. So firewall, that is which traffic is allowed to come inside your VM and which traffic is allowed to go outside. So that can be decided with the security groups of your VM. So with every security group of your VM, like one VM can have one security group. And with that security group, there are some rules that are called as inbound and outbound rules. So inbound rule will decide that which traffic is allowed to get inside my VM, and outbound rules are there, which states that which traffic is allowed to go out of my VM. Now, by default, all traffic is allowed to get inside your VM, and no traffic is allowed to. Sorry, did I said it interchangeably? So listen it again. So by default, all traffic is allowed to go outside of your VM, but no traffic is allowed to get inside your VM, correct? So all traffic can go out, but no traffic can come inside by default. Now, if you want to deny some traffic to go outside of your VM, you can write such a rule in the security group rule in outbound port rules of your security group. Or if you want to allow some traffic to get inside your VM, then again, you'll have to write a rule for that traffic to get inside your VM in the inbound port rules of your security group. Correct? You have to write that rule. So guys, here I can give the security group any name, or I can go with this default name. But the point is that I want to connect to this VM. So if I want to connect to this VM, so what I need, since this is a Windows VM, so I would like to connect to this VM. So I will need access to RDP protocol, that is remote desktop protocol, that works on port 3389, guys. Correct. Now, what are these port numbers basically? So you have RDP working, remote desktop protocol working on port 3389. Then you have SSH, which with you can connect to your Linux VMs working on port 22. Then you have HTTP, hypertext transfer protocol, to get in the internet traffic when you have converted your VM to web server functionality. So you must have allowed traffic through port 80, that is HTTP port, correct? And if you want HTTP with secure, you can go with port 443. So guys, what are these port numbers? And from where to where these numbers are there for different protocols. So basically these numbers, doors, and these numbers, so these ports are called as, there is something called as ephemeral port range. Do you know what is an ephemeral port range? Ephemeral port range, this must be there with you. Ephemeral port range, guys? No? Okay, you should be knowing about it. Ephemeral port range, actually, it's a range in which all these protocols work, right? So basically, ephemeral port range ranges from 0 to 65535. Okay. And every protocol, whether it is RDP, HTTP, HTTPS, SQL traffic, all will have a port number that will be inside this port range only, from 0 to 65536, correct? So it will include all traffic. So if you, let's say, if you say, I want to allow the traffic from 0 to 65535, that means you're allowing traffic from any port, okay, any protocol. So now the point is that actually the usable range by users goes from, I think, 127 or 128 to 65535. Before that, it is not usable by the users, correct? So, but then whatever the protocol that you're using, it would be using a port number inside this range only. And this is called as ephemeral port range. Okay, so now, as I told you, RDP works on port 3389. So we are allowing that. Okay. Fine, guys. Okay, so that is good. And I don't need HTTP, but if you want to include HTTP, you can always do that. Anyways, you have done the web server practical, so will not do that. But if you want, you can just include it. Okay, so you can say HTTP from anywhere. Now see, for HTTP from anywhere makes sense because you want to make your VM to work as a web server, if at all. Correct, so that you want to receive the internet traffic from anyone. Okay, but RDP, you can enable the source type, like you can enable this traffic from anywhere or my IP. So if I say my IP only, I'll be able to connect to this machine through RDP. Or if I say anywhere, so it is like you also can connect to my VM, provided if you have the username and password or the key pair of my VM. Correct? Fine. So these are the two security group rules in my inbound rules in the security group that I have allowed. Okay. Now you must be wondering that I'm not seeing the outbound port rule. So that you can see after your VM is created, you can go to security groups and you can see the outbound port rule here, there. Web server practical, I'm anyways not taking it up because you have already have done it, Shailesh, right? Okay. We are in the volumes and snapshots backup. Okay. So now the next thing is, guys, this is the hard disk storage. Okay, now this is your root volume. That means like your C drive on your laptop, you have C drive. Okay, so here you have root volume. Okay, so that is there. Now, when you are creating Linux VM, the minimum size of your root volume should be 8 GB, and in Windows it should be 30 GB. Anyways, up to 30 GB is free for you. Okay, up to 1 year. Then if you want to store your user data, see, this will contain the operating system files. Plus, if you want to store your user data, you can put it in the C drive in this root volume. But it is not but is it a good idea to put your user data in the C drive, guys? Is it a good idea? No, of course not. That's not a good idea. Correct. So since that is not a good idea, so then you can put your user data in a separate volume also. But right now, I'll not create the volume. I can create it from here itself, like a D drive, but I'll not create it right now. But later on, I'll show you how you can create it and then do the stuff. You can mount it as well. So that is good. And then so I'm not creating additional volume here. And then in the advanced details, I'll not go into the details of this thing, maybe done already, or otherwise what I will just tell you, see, shutdown behavior, it is stopped. So that means you'll be able to shut down this VM and then you'll be able to terminate this VM as well. But if you say shutdown behavior is terminate, then guys, you will not be able to shut down this VM, but you will only be able to delete this VM, terminate this VM. And if you want to shut down your VM, then you will have to disable this option. And then, so you have to make shutdown behavior is stopped. Then after a VM is created, you can make that, and then only you'll be able to shut down as, then you'll be able to shut down your VM. Okay, so let's keep it stopped. So if you want, you can shut down your VM. Plus, guys, termination protection. So see, by default, it is not enabled, it is disabled. But if you enable it, so you'll not be able to delete your VM, correct? So if you then want to delete your VM, then you'll have to go manually and change this option to disable, and then you'll be able to delete your VM, correct? So this is for preventing accidental delete of your VM. I hope that is clear to you, right? So that's the only point that I wanted to discuss here. And then in the user data, of course, you can put a script to promote this VM to web server functionality, or you can install IIS functionality directly going to VM also. Anyways, we are not doing that here. So let's create this VM, guys. This is all good. So shutdown behavior, if you say as what enable, as what shutdown behavior as what terminate only, then you'll not be able to shut down your VM. That means you cannot stop your VM from running. You can delete it, but you cannot shut it down. You cannot stop it. Okay, then if you have to stop it, because if you want to get it again, you want to start it again, so you may want to stop it, because anyways, when you stop your VM, tell me one good thing with a VM, which are the different costs that are involved? There are many, but majorly there is the computation cost and the storage cost. Storage cost for the secondary hard disk storage of your VM, and the compute cost for the computations, the vCPU capacity, the computations, correct? So then guys, when your VM is running, there is compute plus storage cost, both that are involved. But when you shut your VM down, so will you be incurring the compute cost or the storage cost, or you will not be incurring any of them, or you will be incurring both of them? Will you be incurring? Yeah, so then you should be, or you will be incurring the storage cost, but storage cost only, not the computation cost, because your VM is not running at that time, but the storage, secondary hard disk storage that is available with your VM is still available with your VM, even if it is in shutdown mode, correct? So you'll still be incurring the storage cost. Now the point is, you can start your VM back also, but if you say shutdown behavior as not working, or you don't give that, then you'll not be able to shut down your VM, but you can directly delete your VM. With shutdown behavior working, so then you'll be able to shut down your VM as well, stop your VM as well, plus delete your VM as well. I hope that is clear to you. Fine. So guys, I think we have been able to create our VM. Okay. And sitting in India, I am able to create a VM in North Virginia. So this is the beauty of the cloud in matter of minutes. Now let's connect to this VM. So let's connect to this VM, right? Anuj, I'm not getting that. So guys, how will you connect to this VM? How will you connect to this VM? So you have multiple ways of connecting. So I can say connect. I can go to RDP client, and then I'll say get password, and I will get that PEM key file, and I will decrypt it and will get the password. Okay, and then you got this password, guys. So you can just copy this password, and then you can try to connect to this VM. So how to try to connect? Say download remote desktop file, go to that remote desktop file, right? And then you can say connect. Username is already there, administrator and password that you have copied, you need to put it here, and you say okay. And you'll be able to connect to your VM. Let me minimize this while this is getting connected, and let me tell you again. So just go to that instance. Inside that instance, click on connect. Then click on RDP client. Then go down and then click on get a password. Okay, and then click on upload private key file. that you had downloaded PEM-key file, and then say decrypt password. And here you go, the public DNS, the username and the password. And now you can download the remote desktop file. You can say connect. It will ask you for the username. Username is already given administrator. The password, you've got it. You can give it here and get connected with your VM, right? So now the point is, so I'm able to connect to my VM. So now let's go and create an additional volume and attach it to our VM. Okay. So see which step I am in, guys. So I've written the steps. Windows EC2 instance with only C drive is what we have created, root EBS volume. So we have done step number 1. Now, shall we go and do step number 2, creating additional volume for user data? Yeah. So yes, maybe later, Praveen, I can show you that sometime. Yeah. So let's go and do the step number 2, guys. So here in step number 2, let's create an additional volume. So go to your instances, go to volumes. There's one volume and then 30 GB, that is the root volume. Correct, Leonard. So now this is the root volume and then I'll create another volume. So I'll say create a volume. Now guys, tell me one good thing. If you create your volume in one availability zone and your EC2 instance is in another availability zone, will you be able to connect this volume to that EC2 instance? So guys, it is like saying if you have your hard disk in one AZ and the VM in another AZ, it's like having a volume in one AZ and the VM in another AZ, you'll not be able to connect to that VM. It's like saying that you are having a portable hard disk at your home and you want to connect to it from your office location to that physical portable hard disk. You cannot do that, right? One more explain step 2. So what steps 2 says is that you just have to create the volume. Okay. So what you have to do is you have to create additional volume for the user data, example D drive. So what you need to do is you need to go to volumes in EC2 and you need to make sure that you are creating the volume in the region in which you have your EC2 instance. Otherwise, you will not be able to connect your volume to the EC2 instance, because it's like saying having a hard disk at your home and trying to connect to it through your laptop from your office. So that's not possible, correct? So here in the volumes, there's 30 GB of root volume. Now I'll create another volume here. And before that, let me check the availability zone of my instance, of my EC2 instance, so that I can put this up in the same region. Sorry, same availability zone. Anyways, you can check out the availability zone of your root volume also. That is US East 1A. Right then. So it is US East 1A. So I will put that one in US East 1A. If you want to check it with your EC2 instance, you can go to EC2 instance also. And EC2 instance as well, and then you can see to it. It's US East 1A, correct? So now you can create the volume in US East 1A. I'll create a volume here. So I'll say create volume, and I'll select any storage option here. So there's general purpose SSD, solid state drive, provision IOPS SSD. It is having better IOPS input output per second than the general purpose SSD, correct? Plus with cold HDD, it's like, it's having very cost effective, but then the speed will be a problem here, correct? So you can just go with general purpose SSD, and then the size, I will just select 1 GB. So this will create a 1 GB of volume, okay? In the same availability zone 1A, otherwise I'll not be able to connect to this VM, right? So I'll just say availability zone 1A. And that's it. So just create this volume. So the volume has been created, guys. Okay, now tell me one good thing. So the volume has been created, but tell me one good thing, guys. Will you be seeing this volume on your EC2 instance? Yeah, so the point is that the volume has been created, but it has not been attached to your EC2 instance. See, it is getting created still. So it's available, but it is not attached. The first root volume is in use. So now I'll select this volume and I'll say actions and attach this volume. And I'll give the instance name where I want to attach this volume. So you will not be able to see the instance if your instance is in different availability zone and the volume is in different availability zone. So since the instance is in the same AZ as your volume is in, so you are able to see this instance and you will attach the volume. Correct. So now you have attached this additional volume to your EC2 instance, guys. Right? So the point is what? How did you attach? Okay. So I just clicked on this and then I said attach volume. And then I selected my EC2 instance there and it got attached. Okay. So this is how I attached the volume. Okay. So I can just put this step right here. So what's the step? Next step is attach the additional volume to my EC2 instance. That's what I did. Attach the additional volume to my EC2 instance. And then after that, what you need to do is you need, so first thing is, will you be able to see this? Yeah, we can detach also. Correct. But then the point is, will you be able to see this volume now on your EC2 instance? Will you be able to see this volume on your EC2 instance? Yeah. So now, see, this volume will not be visible here. Let me tell you. This volume will not be visible here, even after I have attached it. Now, let's see whether it is visible or not. So I need to go to disk management. Okay, so the shortcut is disk mgmt.msc to get into the disk management. Disk mgmt.msc. Okay, so here it is, disk mgmt.msc. So see, anyways, if you go to your D drive here, or I mean, my computer here, you will not see that volume because no doubt that volume has been created, has been attached, but you still don't see it on your EC2 instance. It has been attached also, but guys, the point it is not mounted yet. So you need to mount it first. So that's why I'm in disk management.msc. And here, if you scroll down, you will see that volume, 1 GB of unallocated volume, correct? Can you see that 1 GB of unallocated volume? And it is offline as well. So just right click on here first on offline and bring it online first. So when you say online, it says it's not initialized. So just initialize it first. So right click again and say initialize. Okay. And then you can just say, okay, so it would be initialized. So bringing it online, then initializing it and then allocating it. So right click here now and say new simple volume and create this volume. So this is how the new simple volume has been mounted on your machine. And now you will be able to see it in your drive. So see D drive. Can you see that? Yeah. Additional drive. Okay. So now it has been mounted. So guys, tell me one good thing. Is it clear till this point? Attach the volume to EC2 instance. And then the step number 4 also we did it because we were not being able to see that volume. So we did the step number 4, that is mount the additional volume on my EC2 instance. I hope this is clear to everybody. If you can please confirm. So what I did is I will just show you both these steps, 3rd and 4th again. So pay attention here. So in step number 3, what I did is I went to the volumes and I said create volume and I given the size of that volume as 1 GB. And then I given the availability zone as same as my EC2 instance availability zone. So as to I can attach it to my EC2 instance. So I just gave the availability zone and then I said create volume. Once said create volume, the volume got created. Then the next step was to get inside that volume. So what was the first step is to create the volume. So I created that volume. Then the next step was that it was not in use. It was available. So I need to attach it with my EC2 instance. So I just selected that volume, not got inside it. And I went to actions and I said, attach this volume. So I said attach volume and then I selected my EC2 instance. It was visible to which I wanted to attach my volume. So this is how I attached my volume to my EC2 instance. Then I went to my EC2 instance thinking that I'll see that volume in my PC, but I was not seeing it at that time because the point was that I had created the volume, I attached it to my EC2 instance, but I had not mounted it on my EC2 instance. So that's why I was not able to see it. So then for mounting this volume onto my EC2 instance, what I did is I went to disk management. So I said disk mgmt.msc. And here in disk mgmt.msc, I did 3 steps. First, right clicking here, bringing the volume online. And then the next step was, so first was from offline to online, bringing it. And then the next step was to initialize the disk. Okay. So I did that. Okay. And then of course, here also, then I said allocate it, and then I right click and set that, I think, and then I was able to allocate this volume. Correct. So this is how I mounted my volume onto my EC2 instance, and then I saw it that it was available in my D drive. Correct. So new 1G volume, it's pretty simple. You need to get into that. I need to get out of this. I need to go to my desktop. Yeah. So you need to do what? You need to right click here, bring it online, and then you need to right click, and then you need to do what? Then you need to initialize the disk, and then yeah. So these steps you need to do, and then it would come online. Correct. So bring it online, then initialize it, then here right click and say create new simple volume. Okay. Right, Leonard? So here first you right click and bring it online, then again click it here, and then do what? Initialize the disk, and then right click here, and then do what? Do what? Then do what? Create a simple volume. Okay. And then you should be good with it. Right? Right. So put some data in that volume. So let's do that quickly. Okay. And let's have it in a flow so that you can enjoy it as well. Okay. So what I'll do is I'll go to that instance itself. Okay. And I'll go to that D drive and I'll put some data out there. So let's go to D drive. Let's create some folder here. Let's say hello all. I'll put it here. Or I'll just create a hello folder from hello to hell. No. So here I will just create a document, text document. I'll say hello, document name also hello. And then inside that, I'll just write down hello, everyone.
Just a quick info, guys. Intellipaat offers advanced certification in DevOps and cloud computing in collaboration with IIT Pravartak, a technology innovation hub of IIT Madras. This online advanced certification in DevOps and cloud computing by IIT Pravartak will help you gain expertise in DevOps, access management, DevSecOps, Terraform, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel. The link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take your first step towards career growth in the field of cloud and DevOps.
Welcome to AWS. Correct. And so I'll just close it here. I'll save it. Okay, so I've just written this, and this document is what is there inside a folder called as hello. Right. And inside that, this document is there, which says, hello, everyone, welcome to AWS. Okay, guys. So I have this data in this drive, in this D drive. Okay, correct. And now, so I've put some data in this drive, guys, and now just minimize this VM. And now what you do is, so now take the snapshot of this additional volume. Okay, so let's take up the snapshot of this volume. So let's go and do that. Okay. I will just take up the snapshot of this additional volume, guys. Okay. So let me just do that. Okay. So what I'll do is I'll go to volumes and I'll go to this 1 GB of volume and I'll take up a snapshot, or I can directly go to snapshots and take the snapshot, or I can just click on this 1 GB of volume and go to actions and say, create a snapshot. So I'll create this snapshot. And what I can give it a name, I can give any description here of this snapshot if you wish to. Otherwise, you can leave this description. Okay. And that and you don't need to give anything, just that volume snapshot. I'm taking it up. You can say create snapshot. So this will create a snapshot. So the snapshot has been created. Okay, guys, I hope this is good. So you have created the snapshot. And now what you need to do is, now you can actually delete this volume. Okay, so you have created the snapshot of this volume. Snapshot is the point in time image of the volume, guys, right? So what is a snapshot? It is a point in time image of that volume. So whatever is in that volume has been captured in the snapshot. That data has been captured in the snapshot. So now what I'll do is, now I'll unmount and delete the additional volume, right? So what you can do is, you can just delete the additional volume. So you can unmount, detach, and delete the additional volume, or directly you can detach and delete the additional volume. So this, where is the volume like? If you go to snapshots, you will see that snapshot. You can see the snapshot is here, correct? And then you can go to volumes and you can go to that 1 GB of volume, and then you can go to actions. You can say detach volume. So right now it is being in use by your EC2 instance. So when you say detach it, so it would be detached. And once it is detached, if you refresh it, so you will see it is available. It's still says in use. So see, now it's available. It is being detached from your EC2 instance. So now you can select this volume, and then you can do what? You can actually do what? You can delete this volume. What you can do, guys? You can delete this volume. So you can say delete. Right? So this volume has been deleted now. So see, I have deleted this volume. So now the point is, so I had created the volume, I had put some data in that, I've created the snapshot of the volume, and then I have deleted that volume. And once the volume has been deleted, guys, you can go to your EC2 machine and you will not see that volume anymore in the disk management also, plus you will not see that volume anymore in your My PC also, right? So that volume with its data is gone. So now the point is, can you restore it back? Can you restore it back, guys? You can do that. Can you restore it back? Yes. How you can restore it back? Because you have created a snapshot of that volume. So from that snapshot, you can restore that volume, that data of that volume back. Okay. So now what we'll do is, so we are done till step number 7, guys. Okay. Now what we'll do is, we will create a new volume from the snapshot and we will attach it to our EC2 instance again. So let's do that. Okay. So come here and then do what? Go to snapshots. Select that snapshot. And then what you do is, go to actions and then say create a volume from the snapshot. So you can create this volume from the snapshot. And then see, now the point is, can I create a 2 GB volume from this 1 GB of snapshot? Can I do that? Can I create a 2 GB of volume from this snapshot? Is it possible? Can I do that? Maybe, no, yes, no, yes, it is possible. You can do that, right? So, but the point is that, see, anyways, you cannot reduce the size of the volume. If you have a 1 GB of snapshot, you cannot create a 0.5 GB of volume out of it. Now, the point is, you will say anyways, less than 1 GB of volume you cannot create. Whether it is through snapshot or whether it is directly, you cannot create a volume of less than 1 GB because minimum is 1 GB. I agree with you. Okay. But even if you have a snapshot of 2 GB and if you want to create a volume of 1 GB out of it, can you do that? You may not do that, guys, because in that case, what can happen is that you may lose on the data because the snapshot can contain 1.5 GB of data and you're creating a 1 GB of volume out of it. So what about that 0.5 GB of data in it? So you may lose that, correct? That's why Amazon may not allow you to do that, correct? Okay, so you may not reduce the size of the volume when you create it from the snapshot, but you can always increase the size. That's possible. So, so let's increase the size of this volume that I'm creating from the snapshot to show it to you. Okay. So, So let's say I increase the size to 2 GB. Okay. General purpose SSD volume. I want to create a drive and 2 GB of volume. And then, of course, I want to create this volume in US East 1A only because my instance is there and I want to attach this to my instance again. Correct? Tags are optional. You can just leave them. So just I did what size as 2 GB and that's it. Availability zone US East 1A tags are optional. You can ignore them. Anyways, what are tags? I'll tell you later on if you don't know about it. So then you can say create this volume, right? So you have created this volume. So successfully created the volume. Okay, now what you need to do is you can just go to volumes and you will see that volume, guys. So this will also charge you. So basically, when you create the snapshots of a volume, they are being stored in something called as your S3 buckets, right? And in S3 bucket, the free limit is up to 5 GB. After that, you are charged for that, right? So that's the point, right? So we have now this 2 GB of volume. In case we try to reduce this disk size, does it give an error message that it's not possible to reduce? Of course, it should give you, Rohit. Right. So now that you have 2 GB of volume, guys, okay, the size of the snapshot will be equal to the size of your volume, right, Shailesh? So now you have the 2 GB of volume, guys, and now see, this is available. This is not in use. So you can now attach it to your EC2 instance. So I've just selected that and I can say attach. So I can say what? I can say attach the volume and I'll select my EC2 instance here. And you will only be able to see your EC2 instance if you are if you are having this volume in the same availability zone as your EC2 instance is in. So I'll say attach this volume. So it's done. It is attached, correct? And now you go to your EC2 instance, correct? Now you go to your EC2 instance, guys. Fine, sure, Anuj. Right. So here you go. And now, guys, if you come here, see out of this 2 GB, 1 GB is healthy primary partitions. It's available online. It is allocated as well, correct? But that another 1 GB is unallocated because that you have what? That was not there in the snapshot, but then you had extended that volume size through that snapshot. So now either of this 1 GB unallocated, you can create a separate volume out of it. You can say right click and new simple volume, or you can extend this volume only. From 1 GB, you can make it to 2 GB. How you can do it, guys? So you can just right click here and you can say what? Extend the volume. Extend the volume. Correct. And then you say next. That previous 1 GB will be automatically mounted because you had not unmounted it before. But this additional 1 GB is not mounted. So I can create a new volume out of it, another volume, E drive, F drive, or I can just extend that D drive with this 1 GB. So that's what I'm doing, extending the D drive. So what I did is I'll just show it to you again. So if you want to create a new volume, right click here and say new volume. But if you want to extend it to D itself, so you can right click on D and say extend the volume. And then you say next, next again. Finish. That's it. Okay, so see now it is 2 GB of healthy primary partition. And when you come to my PC, you can see now the size, it still shows 1 GB. So you can just refresh it and it will show you 2 GB. See, it is 1.99 GB. Okay, so 2 GB. If you go inside that, can you see that hello file, guys? Hello folder. And inside that hello folder, can you see that document? Hello. Can you see hello everyone? Welcome to AWS. That was there in the previous volume that we had deleted. But since the snapshot of that volume was taken, I am able to restore the data of that volume from that snapshot, even after the volume was deleted. Yes, guys, is it clear to everybody? Yeah. So this is how it is done. So this is how you can do volume level backup and restore of your data. So see what I did, created a new volume from the snapshot, attach it to my EC2 instance. Then the new volume was mounted to my EC2 instance. Then you'll be able to see your data in that volume. So you have restored your data, guys, correct? Okay. So Sunita, image versus snapshot. Normally image you create of your EC2 instances, okay? Right? So images you create of your EC2 instances, so that will contain the computing power and stuff. AMI's Amazon Machine Image. And then from that AMI image, you can create that same EC2 instance in another region also, or maybe in the same region also. Whereas snapshot, normally for the snapshot of the volume, when you create the snapshot of the volume, it will have the backup of your volume, backup data of your volume, right? So it is clear, will it? So this is a way to backup information. Correct, Leonard. Okay, if I create 2 GB and with F drive, still 1 GB available as D drive. If I create 2 GB with F drive, still 1 GB available as D drive. No, for that you need a 3 GB. So I mean, if you are creating a 2 GB of volume, so that D drive of 1 GB will still not be available. So it can be like if you create a 2 GB with F drive, how can you create that, Vinayak? Because see, when we went here, so we had the option of giving that 1 GB to another drive, not the 2 GB. Out of that 2 GB, 1 GB was already allocated to D, but that additional 1 GB that was there, for that I had the option either to give it to a separate drive or to just extend the D drive with that particular 1 GB itself, right? There's another option, create snapshot lifecycle policy. Yeah, so create snapshot lifecycle policy is another good, interesting option, basically. So with that, you can give the lifecycle rules. Okay, lifecycle manager. You can go to lifecycle manager and then you can create new lifecycle policy. So you can say next step and then see it tells you here. Automate the creation, retention, copy, and deletion of snapshots and AMIs, right? So you can automate that. You can tell when to create the snapshot and stuff. So you can schedule those options beforehand, right? Target resource type, you want to create the snapshot of volume. Okay. And then tags optional policy status when you want to do it. Correct. All those things you can specify. And then when you want to create it, configure schedule one, that is when you want to create it. Maybe you can have here of VM1, name is VM1. Okay. And for that volume or that instance of the instance of that, you want to create a snapshot policy description. You can have anything, LLP1 or whatever, and that will create a role that will handle that policy, and then you have it enabled, and then you can specify the, I mean, I can go with instance because that's the name of the instance here. Otherwise, I have to put the volume name. Fine. So I can put any name here. It's not available. Okay, I need to add it. So I've added it. Correct. I can go with volume also. I've added that. And then I can go next. And then I can create the schedule. The schedule name, when I want to take the backup, daily, every 12 hours, starting at what time. And then whatever the backup that I'm taking, I want to retain that backup for how much amount of time I want to keep it. So these all things you can specify. Correct. And to keep it for how many hours? Let's say 6 hours or 10 hours. So that also I can specify. Correct. Okay. So this all you can give it here. Do I want to keep the copy of the snapshot in another region also? That also I can say with cross-region copy. Correct. Plus, do I want to archive? Do I want to store its copy? I want to archive it. So that also I can do. And then I can review this policy and I can create this policy. So then the snapshot would happen at that specific moment of time. What's the difference between selecting instance or volume? So instance means complete instance can be backed up, and then volume, it will do that volume backup only, I think. See, resource is there something that can be a volume, that can be an instance also. So resource can be anything. It can be a volume. It can be an instance as well. Okay. And so resource is something that can be a volume, that can be an instance also. Correct. Okay. And instance will contain your volume, plus it will contain the vCPU capacity, plus the RAM capacity, correct? And your volume will just have the secondary storage. Okay. So it makes a lot of difference because see, when it is an instance, so even the application level properties comes into it, like whatever the softwares you install on it, and not just the data in the secondary storage. Whereas in volume, it is just the data in your secondary storage. So it should be incremental in the lifecycle rule, the backup. Yeah, when we select instance, it should be AMI plus EBS, correct? We don't have to initialize and mount the volume when we create it using Snapshot. No, it's not like that. When we create it through Snapshot, you don't have to initialize and mount. It was because we had not unmounted it, and that's why we had not, we didn't require to mount it again. If I would have unmounted it, then I would have needed to mount it again. So now guys, see, I'm more interested in telling you about some networking concepts since you are, you have understood something about the EC2, correct, and the volume and snapshot policy. So now I would be interested in telling you about some good things on IP addressing concepts. So are you all ready? Shall we go and discuss about IP concepts? Yeah. And do let me know if you already know it, but even like the experienced pros also sometimes they don't know it, right? So basically, it's like I'll be telling you how the concepts of subnet mask, CIDR blocks, and then how you can actually design your network by actually deciding the value of subnet mask, right? So let me just go and let me put it in front of you guys. It's about CCNA concept, but if you don't know about it, guys, then when you will design your networks, it becomes like when you create your network in AWS or Azure, it becomes really difficult to understand that what is happening and why you are doing it, basically, correct? So I am going to discuss about here the IP addressing. See, I can directly go and create a VPC, but then how you can design and create that VPC is something that you should be aware of, right? And that is what I'm going to tell you here. Not many people can tell you this thing, but believe me, if you don't know this thing, then it's not good, right? Then you'll have difficult times in VPCs, which is considered as one of the complex topics. It's not that complex, right? So IPv4 is what? It's a, so I'll just write it down and express me here, right? So IPv4 is, it's a 32-bit addressing scheme, guys, which consists of 4 octets, where each octet carries 8 bits. So overall 32 bits, right? So let me put it here. So A.B.C.D, these are the four classes. So 4 octets, you can see A, B, C, D, each octet of 8 bits. And so each octet of 8 bits, so 8 plus 8 plus 8 plus 8, that is 32, 4 octets. And guys, since each octet is of 8 bits, so 2 to the power of 8 is 256. So each octet can have a value ranging from 0 to 255 only. Correct. So this is 192.168.0.4 example of IPv4 address. Okay. So this values cannot go beyond 255. And guys, this is what is private IP addressing. It is used in the virtual network. So these addresses are reserved for private IP addressing in the virtual networks, in the VPCs, in the on-premises virtual networks, correct? That is 10.0 block, 172 and 192 block, correct? So you can use it for private IP addressing. Now, as we all know that there are 2 types of IP addresses. That is a public IP and a private IP. So public IP is used over the internet, which is routable over the internet, whereas private IP is used within the private network, that is in your intranet, correct? Then let me give you the, so this example already taken for private IP addressing in Azure or in AWS. Now, whenever I take up Azure or AWS, this document remains the same, correct? Okay. So then let me tell you about CIDR block, guys. So what is a CIDR block? Anyone having any idea? What is CIDR block? So CIDR, that stands for maybe the classless interdomain routing. Okay, and it is nothing but a block of IP addresses, guys, or you can say the range of IPs. Okay, so block of IP addresses, or you can say the range of IP addresses. Correct? So here I can say that this is my CIDR block because I have expressed it 192.168.0.0/24. So this complete is called as the CIDR block because it gives you range of IP addresses, block of IPs. And in this /24 is called as the subnet mask, guys. Right? Okay. Right. So this is like /24 is the subnet mask. Okay. So now the questions here that I'm going to ask you, and we will be seeing the answer to those is, so let's say if this is my network, this is my CIDR block. So guys, we have to answer these three questions here. What is the overall IP address range in this network? That is in this CIDR block. Then what is the usable IP range in this network? And then what is the subnet mask representation? Okay, so what is the overall IP address range in this network, guys? Let's answer the first question first. So overall IP address range in any network is given by the formula 2 to the power of n. Correct, Adarsh? You know that, right? So that is good. So overall IP address range in this network is 2 to the power of n, guys. Now then you'll say, what is n? So guys, n in case of IPv4, that is a 32-bit addressing scheme, is given by what? IPv4 is 32-bit addressing scheme, correct? Where each octet is of 8 bits. So to calculate the value of n here, you will subtract the subnet mask value from 32. So 32 minus subnet mask, that is 32 minus 24, that is 8. So the value of n becomes what? 8 here. And 2 to the power of n is, that is 2 to the power of 8, that will become 256. Okay, so overall IP address range in this network is what? 2 to the power of 8, that is 256. So overall IP address range in this network is 2 to the power of 8, that is, and that is 2 to the power of 8, that is 256. And guys, how will you represent it? So you'll represent it like this, that is starting from 192.168.0.0 to 192.168.0.255. So from 0 to 255, that is 256 addresses. So this is the answer to your first question. That is, what is the overall IP address range in this network, right? Right, that is in your on-premises, but in cloud, 5 IPs are reserved. Anyways, we'll come to that. Right now, let's talk of the on-premises only. So this, anyways, this is the answer to your first question, guys. The overall IP address range in this network. Then let's answer the second question. So what is the usable IP address range in this network, guys? So what's the usable IP address range in this network? So guys, usable IP address range in a network in your on-premises is given by the formula 2 to the power of n minus 2. Now, why 2 to the power of n minus 2, guys? Because 2 addresses are reserved. They cannot be given. They cannot be used by the user computers. So that is the first address and the last address that are reserved. So first is reserved for the network and the last is reserved for the broadcast address. So they cannot be given to user computers, right? So that's why it is 2 to the power of n minus 2. So 2 to the power of n anyways is 256 minus of 2. So that is 254, correct? So the usable range goes from 0.1 to 0.254, right? So that's the usable IP address range in this. That's the usable IP address range in this network, correct? Right? So that's the usable IP range in this network. That is from what you call it, or what you can have it is 2 to the power of n minus 2, right, guys? So first is not usable and the last is not usable. So the first is 0.0, that's not usable, and the last is 0.255, that's not usable. So the usable range goes from 0.1 to 0.254, correct? Okay, I hope this is clear to everybody, right? So anyway, some or a few of you know it, so that is again good. to know it, right? So then guys, the next thing is that, okay, let's answer the third question then, that what is the subnet mask representation anyways? What is the subnet mask here? So good, correct, right? So do I need to tell you these things, guys? You know this, right? So let's get into the third one. That is, what is the subnet mask representation? So the subnet mask here is 24, correct? So 24 means what? Like, so you have the subnet mask as /24. So 24 means every octet is of 8 bits, guys. So out of this 24, every octet takes 8 bits. So the first octet you assign 8, second octet you assign 8, third octet out of this 24 you assign 8, and then are you left with anything? 8 plus 8 plus 8, 24. So you're not left with anything. So the fourth octet will have a 0, right? So then the subnet mask representation, if you have to do, so this is how you do it. That is, you put it like this. That is, you will have 4 octets here. You write it in the powers of 2, right? So that is 1, 2, 4, 8, 16, 32, 64, 128. Then again 1, 2, 4, 8, 16, 32, 20, 64, 128 here also and here also. Correct? Okay. And then guys, here you will write ones at all the 8 places. Why? Because there is 8 here. Then again, here also you'll write 1 at all the 8 places because there is an 8 here. Then again, here also you'll write ones at all the places because there is an 8 here. And then there is a 0. So you will not add a single one here. There'll be all zeros. And then you will add all those weights wherever there are ones. So then you will add this 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. So that comes out to be 255. Similarly, here it comes out to be 255. Then here also you'll add all the weights. So it comes out to be 255. And then here, guys, you will not add even a single weight. You will not add even a single weight because there are all zeros. So this will be a 0. So then if you would represent it, so it would be 255.255.255.0, right? So that's what it comes out to be. So that is what is the subnet mask representation is. And let me tell you, subnet mask can be helpful to find out the addresses in a particular network, correct? In fact, on all your hardware networking devices, the IPs, the addresses are given in the form of subnet mask only, correct? So this is the value 255.255.255.0. And guys, just to make it more clear to you, let's say if this would have been 25 instead of 24, then this would have been 8 plus 8 plus 8, and then you would have been left with just 1. So here there would have been 1. And then here there would have been all ones, all ones, all ones. And then the last, there would be there is just 1 1. So you will just put 1 here. Okay. And guys, remember it starts from LHS. So the 1 will not come here, but it will come here, right? And then you will add all weights here, here, here. But here you'll just add 1 weight, that is of 128. So then you will say 128 here. Okay, so then the subnet mask representation will become 255.255.255.128, correct? And let's say if this would have been 23, then this would be 8 plus 8 plus 7 plus 0. So it would be all ones, and 7 ones. The last one would be a 0, and here all zeros. So it would be 254 because you'll not add this one. Rest all you'll add it here and it would be 0. So it would be 255.255.254.0. Okay, so that's how it goes.
Let's have a quick quiz question, guys. And the question is, what is AWS Cloud Formation? And your options are a service that allows you to create and manage virtual private clouds, a service that allows you to create and manage virtual private clouds, or a managed service that provides a relational database capabilities, or an analytics service that enables real-time data streaming and processing. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers advanced certification in DevOps and cloud computing in collaboration with IIT M Pravartak, a technology innovation hub of IIT Madras. This online advanced certification in DevOps and cloud computing by IIT M Pravartak will help you gain expertise in DevOps, access management, DevSecOps, Terraform, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel. The link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take your first step towards career growth in the field of cloud and DevOps.
I hope it is clear to you. Anyways, in our example, it is 24. So this is how it goes. 8 plus 8 plus 8 plus 0. And sorry, I made it incorrect here. So here it would be 254 and then 0. Not 254, 255 and then 0. Sorry, what am I doing? 255 and then here 0. Right. So is it clear to all of you guys? Yeah. So thus we have answered all the questions here. Subnet mask maximum number is 32. Yeah, maximum is 32, but ideally you cannot take 32, Amit. I'll come to that later. And these are the private IP addresses that are reserved that you can use in AWS Azure, correct? Public IP range anyways would be assigned to you directly by AWS. You don't direct control that anyways. Right, so fine. So if this is clear, guys, just answer this one. 10.0.0.0/22/23. Okay, so tell me, what is the value of n here? N is what? It is 9 because 32 minus 23 is 9. So what is the overall IP address range in this network then? It is 2 to the power of n, that is 2 to the power of 9, that is 512. So what is the overall IP address range in this network, guys? 2 to the power of n, that is 2 to the power of 9, that is 512. Now how to represent it? So you will go from 10.0.0.0 because that's what it is. And then you will go till 10.0.0.255. So 256 bits here. And then you will go from 10.0.1.0 to 10.0.1.255. So 256 bits here again then. So that's how it goes. So from 10.0.0.0, you will go till 10.0.1.255, guys. Correct? So you'll go from 10.0.0.0 to 10.0.1.255. And this will be the answer to the question that this is the overall IP address range in this network. Now the question, if at all, comes to your mind is that, can we not go from 10.0.0.0 to 10.0.0.511, guys, directly? Is it possible or is it not possible? Why we have gone from 1.0 to 1.255? Why we are not going beyond 255? Because, guys, IPv4 32-bit addressing scheme, every octet of 8 bits, 2 to the power of 8 is 256. So every octet cannot have a value greater than that, cannot have a value greater than 255 because it goes from 0 to 255. So cannot have value beyond 255, correct? And that's why once this range of 0 to 255 is over, then you will again start back from the third octet. This 0 will then turn to 1 and then it will go from 1.0 to 1.255. Had it been instead of 512 bits, had it been 1024 as the value, then this would have gone from 0.0 to 0.255, 1.0 to 1.255, 2.0 to 2.255, 3.0 to 3.255, correct? That is how you would have gone 4 times 256 equal to 1024. What is the usable IP address range in this network? Can you tell me what is the usable IP address range in this network? It is 2 to the power of n minus 2. That is 512 minus 2. That is 510. First and last is not usable. So 0.0 not usable and not 0.255, but 1.255 not usable. Correct? 2 IPs not usable in your on-premises environment. That is 0.0 and 1.255, first and last. So the usable range will go from 0.1 to 1.254. Okay, is that clear to you guys? Right? And then what is the subnet mask representation? So this anyways, I explained you above itself for 23 also, the subnet mask representation. So this is what it goes. 23 means 8 plus 8 plus 7 plus 0, all ones, 7 ones, and 0 ones. So 255.255.254.0. So now let's talk about AWS networking, guys, or you can say Azure networking, or you can say GCP networking, or in short, you can say cloud networking. So whatever I have discussed till this point is about on-premises networking, correct? Now let's talk about the cloud networking, correct? That is the AWS networking here. So guys, AWS networking here, the overall IP address range formula remains the same, guys. That is 2 to the power of n, right? Then what changes? So changes the usable IP address range formula. So what changes here? What changes is the usable IP address range in a network formula. So that is 2 to the power of n minus 5 it becomes here, not minus 2. In your on-premises networking principles, it's 2 to the power of n minus 2, whereas in AWS, in Azure, in GCP, in cloud, it is 2 to the power of n minus 5, guys. Now, why minus 5? I've written it here. Why minus 5, guys? Because like your on-premises, here also those two addresses are reserved, one for the network, one for the broadcast. The first address and the last address reserved for network and broadcast simultaneously, respectively, I would say, correct? And then there are 3 more addresses that are reserved here. That is one for DHCP, Dynamic Host Configuration Protocol. One address is for the router bit, and one AWS or Amazon reserves for future use. Okay, so one Amazon reserves for future use, correct? So that's how it goes. If it would have been Microsoft Azure, so I would have said one Microsoft reserves for future use. And that's how it becomes 5 addresses, guys. And which are those 5 addresses, guys? The first 4 and the last 1 address. First 4 addresses are reserved and the last 1 address is reserved. So that's how it is. 5 addresses that are reserved. Okay, fine. So if this is good to all of you guys, which addresses are reserved? You can say first 4 and the last 1 address are reserved. Okay, welcome. So see, Dynamic Host Configuration Protocol is a network protocol that is used to configure the network devices to communicate on an IP network. A DHCP client uses the DHCP protocol to acquire configuration information such as the IP address, a default route, and 1 or more DNS server addresses from a DHCP server, correct? So that's what it uses. So the benefits of using DHCP are that it is having portability, no configuration, no reconfiguration necessary. The standard parameters are sent by service to each PC automatically, and it is easy to use. PCs and Macs do not have to be rebooted for DHCP addressing to be in effect, correct? Even I can give you this particular note from Cisco about DHCP. Anyways, who better than Cisco to talk about DHCP, correct? So take this. Why one address is for router? To make the subnets of a network to communicate internally automatically. So the subnets of 2 networks can talk to each other automatically, and that is possible with that one router bit, actually. It's like saying that the neighbors that are residing in your colony, they can talk to each other automatically. So if you want to talk to your neighbors, do you need an internet connection? Do you really need an internet connection to talk to your neighbors or to talk to your family members? No, of course not, right? So you can talk to them implicitly, by default, correct? So in the same way, the subnets of the same network can talk to each other by default, implicitly, and that is possible because there is one bit that is reserved for the router bit. Okay, with that it is possible. So guys, about AWS networking, I was here, so fine. So let's get ahead. So now if you are good till this point, guys, you are in good shape actually to design your own network. So let me give you a use case and let you design your network. So let's say if we own an organization, guys, let's say if we are having an organization, okay, wherein we have what? In which we have 4 departments. How many departments, guys? 4 departments. Okay, understand my use case. So we are having an organization with 4 departments. Okay, and let's say in each department, I need 100 servers today. I need 100 servers today in each department. And in future, I need 100 more servers in each department. That is 10 years down the line. So now you have to design this network. So guys, first of all, tell me what is the overall requirement of my organization? How many servers I will need in my organization? 400, 200, 400, it's 800 servers, correct? See, 100 is the today's requirement in each department. And I have 4 such departments. So 4 departments, 100, 100, 400 is today's requirement, current requirement. And future requirement, again, 100 more in each department. And there are 4 departments. So again, 400 is the future requirement. So overall requirement, I said, so it is what? 400 plus 400, that is 800. Oh, sorry. Yeah. So overall requirement is what? It is what? It is 800 servers, correct? So guys, now you tell me one good thing. If your overall requirement is of 800 servers, how many usable IP addresses you will need for this organization? One server would be assigned how many addresses? One address to one server, correct? So if you have 800 servers, how many IPs you need? 800 IPs, correct? So total addresses that you will need is 100 plus 100, that is 200 servers into 4 departments, that is 800 servers. For that, you will need 800 addresses. So guys, now can you tell me one good thing? So can you now decide on the value of the subnet mask that you should be choosing for your network to cater to this requirement? And let me tell you, your value should be optimum, nearest one to the requirement. It should not be like you are taking a too big value, because that way you will be losing on the addresses, correct? That you can use it for some other network. So what should be your value of the subnet mask? /22, is it? Okay, let's see it. Okay, so let's say if if I take up the value is /24. Okay, so then if I have the value as /24, so then I get how many IPs? N is 32 minus 24 is 8. So 2 to the power of n, that is 2 to the power of 8 is 256. Now 256 is less than 800. So of course I cannot take that. Because if I say 256, I cannot assign out of 256, 800 IPs to 800 servers. Not possible. Then with /23, value of n is what? Value of n is what? Value of n is 2 to the power of, that is value of n is what? 32 minus what? 32 minus 23, that is 9. So 2 to the power of 9 is 512. Okay, so again 512 is less than 800. You cannot go with that, right? And then what about /22? So of course that should cater to the requirement then, correct? So if you go with /22, so that is like 32 minus 22 is 10. So 2 to the power of 10 is what? 2 to the power of 10 is 1024. And guys, 1024 is big than 800. So out of 1024, 800 IPs can be assigned to 800 servers. So this is good choice. Okay. And then if you divide this 1024 by 4, why? Because there are 4 departments, correct? So divide this 1024 by 4. So every department will get 256 IPs, correct? And every department's requirement is of 200 IPs for 200 servers. So out of this 256 IPs, 200 IPs can be given to 200 servers. So this is also good, right? For each department. So for each department, the subnet mask value should be giving you 256 IPs, so that you get with /24 as the subnet mask for each department, and for overall organization, the subnet mask value will be /22. Okay. So that's what goes here. So now you can say, okay, so now you can say, so slash 24 will be for the subnets and slash 22 will be for the network. And let me tell you guys here, the organization is equivalent to your network and the departments in the organization are equivalent to your subnets in the network, correct? So the organization, it's like equivalent to your network and the departments in the organization are equivalent to your subnets in the network, correct? So I can say organization subnet mask should be /22 or network subnet mask should be /22 and department subnet mask should be /24 or subnet mask should be /24. Right. So once you have decided on this, you have actually what? You are in good shape to actually design your network. You have actually designed your network now. Now you just need to represent it, correct? And as I told you that you can take from these IP address ranges for private IP addressing here in AWS Azure for your VNet or for your VPC. So VPC again is a virtual network only, right? So you can go with 10.0.0.0 block. Okay. So either you can go with 10.0.0.0/22 for your network or 172.16.0.0/22 for your network or 192.168.0.0/22 for your network. So you can go with any of them, guys. Let me tell you. Now it is your choice. So if you're thinking that which one I have to go with, so let me tell you, you can go with any one of them. So now here, the point is, let's say I go with this 192 block. So it would be 192.168.0.0/22. Okay. So here, that is what I'll go for the overall network because overall network is /22. So how I'll represent it, guys? So here, what I was saying is 192.168.0.0 to 192.168.0.255. This is how you can go about it. Okay, so this is 256 bits. And then you will go from 1.0 to 1.255 because the subnet mask is /22. /22 means 1024 IPs. So you need 1024 IPs. So you'll go from 0.0 to 0.255, 256 IPs here. Then 1.0 to 1.255, again 256 IPs here. Then 2.0 to 2.255, again 256 IPs here, guys. And then 3.0 to 3.255, again 256 IPs here. Correct. So this is how you can go about it. And this is 4 times 256 is equal to 1024. And let me tell you, for individual department, the subnet mask was /24, that is 256 IPs. So this you can term it as your first subnet. And this is second subnet, this is third subnet, this is fourth subnet, guys. Okay. And the rule that 5 IP addresses are reserved, they cannot be used, that doesn't only apply to your VNet, but that applies to all the subnets of a virtual network. So from this subnet, 5 addresses will be subtracted from each subnet. So this subnet 5 addresses will be subtracted, will not be usable by the user computers, guys. Right. So the IP address range goes from 192.168.0.4 to 192.168.0.254 because I told you the first 4 are not usable and the last one is not usable. So which are the first 4? Like 0, 1, 2, 3 and the last one is 255. So they are not usable. So the usable range will go from 0.4 to 0.254, guys. Right. And here in the second one, the usable range will go from 1.4 to 1.254, here 2.4 to 2.254, and here 3.4 to 3.254, guys. So that's how it goes. And let's say if you create one of the VMs here, then it will take any IP from this usable range, correct? And if you create one VM here, then again, it will take any IP from IP from this usable range again here, correct? And guys, can you tell me one good thing here now? So in this subnet, how many VMs I can create? How many IPs I have usable? So that many VMs I can create. So how many VMs I can create, guys? Can you tell me? Out of 256, 5 are not usable. So 251 are usable. So here you can create 251 VMs in this subnet. 251 here, another 251 here, another 251 here. So overall, you can create 1004 VMs. So that's how it goes about, guys. So this is the answer to your question. Like this is how you have designed your network, correct? Now you can create it as well, guys. Yeah. So one more thing I would like to tell you here, guys. that the thing is that what I was telling you is, do we consider the future requirement, or should we consider the future requirement, guys? Tell me. Should we be considering the future requirement while we are designing a network? The answer is, of course, a yes. Now, is it because I've considered it? Not just because of that, but it is because, guys, you should always do that. You should consider it. We should always do that. Why? Because in future, let's say if you don't have a scope for that in your future, like if you are just planning for 400 servers and 10 years down the line, you need 400 more servers. Okay, and you don't have those many IPs now left out. So then you may have to redesign your network or modify your network, and that can be a tedious task. But as said, that the future cannot is not fixed, right? But then of course it can be predicted, and then you can design it accordingly. That can be helpful, right? Yeah, correct. Okay. So anyway, see, you can do this thing is you can select your network, and then you can go to actions, and then you can go to instance settings, and you can just say termination protection. Where is it? Change termination protection. And if it is enabled, just disable it and then save it. Okay, fine. And then you try to delete it. Okay, so then that should help. Okay, so now let's talk about this one. So if this is the case, so here, what is the overall requirement? So I have an organization with 2 departments where every department's today's requirement is of 200 hosts and future requirement is of another 20 hosts. So what is the overall requirement? So it is 200 plus 20 of each department's today and future requirement. And there are two such departments. So 220 to do, that is 440 hosts is the overall requirement. So to get 440 hosts, that means 440 IPs. What should be the value of my subnet mask? What should be the value of my subnet mask? Is /24 good enough to cater to 440 hosts? No, /23 is what you will need for your overall organization. With /24, you get 256 IPs. That is lesser than 440. With /23, you get 512 IPs, out of which you can assign 440 IPs to a 440 host. So this is good. And there are 2 such departments. So 512 by 2. So every department will get 256 IPs. Anyways, every department needs 220 IPs, usable IPs. So out of 256, 220 usable IPs can be assigned to 220 machines. So this is good enough again. So 256 for each department, that is /24 for the departments, and /23 for the overall organization for the entire VNet, correct? And then if you have to represent it, so again, you can go with any of the address ranges like 172 or 198 or 10.0 block. So let's say I go with 172.16.0.0/23. So then this will be my VNet or VPC, and then I represent it. So I'll go from 0.0 to 0.255, 256 IPs here, and 1.0 to 1.255. Again, 256 IPs here, correct? So again, 256 IPs here. Okay, so that's how I go about it. And so that's what you get here, 256 IPs here, 256 IPs here. And yeah, guys, so that's good, isn't it? Yeah, so overall 512, and then this can be termed as your subnet 1, subnet 2, and then this is like 172.16.0.0/24, and this is 1.0/24. Okay, you can say. So here the usable range will go from 0.4 to 0.254. First 4 not usable, that is 0, 1, 2, 3, and the last one not usable, that is 255. And here the usable range will go from 1.4 to 1.254. Again, first 4 not usable and the last one not usable, that is 0, 1, 2, 3 and 255. Okay, and if you create 1 VM here, it will get any IP from this usable range. 1 VM here will get any IP from this usable range, right, guys? So that's how it goes here, right? So now you must be thinking that you are pretty good in this. If I'm not wrong, guys, are you all good with this? Yes or no? So now if you're thinking that you're pretty good with this, somewhat, okay, let me give you a tricky example. Now the point is, so now let me give you a tricky problem here, guys. Let me give you a tricky example. So let's say my today's requirement, Let's say I have 9 departments in my organization and my today's requirement is of 50 hosts and future requirement is of 100 hosts for every department. And I have 9 such departments in my organization. So what is the overall requirement out here? So now, okay, so what is the overall requirement, guys? 1350 hosts, correct. So 100 plus 50, that is 150 for each department. And likewise, you have 9 departments. So 150 into 9, that is 1350 is the overall requirement of this organization. Now tell me the value of subnet mask that I should be choosing for this case. Should it be /21? Should it be good enough? Just rethink on that, because this is not that straightforward. Please. Okay, let me put it here. So of course, /24 is not good. 256 less than 1350. With /23, you get 512, which is less than 1350. You cannot go with that. With /22, you get 1024 IPs. So again, it is less than 1350, so you cannot go with that. But with /21, you will get 2048 IPs, because 32 minus 21 is 11. 2 to the power of 11 is 2048. So 2048 is way big than 1350. So why it is not good, right? So why it is not good? Because guys, I'll tell you. So, okay, fine. Let's think that it is good enough. Okay, so let's give 2048 IPs. Okay, that is /21 as the subnet mask for your overall organization. So then guys, there are 9 departments in your organization. So if you divide 2048 by 9, so each department should get 227.56. That is 227 or 228 IPs. Yes, so 227.56 IPs is what your all departments will get, correct? Sorry, for your departments, every department should get 227.56 IPs. Now tell me one good thing, guys. Do you have any subnet mask that will give you exactly 227.56 IPs or 227 or 228 IPs? Is there any subnet mask that's giving you 227 or 228 IPs? No, because see, with /24, you get 256 IPs, that is greater than 227 or 228. And if you go with /25, so how many IPs you will get? So you will get 128 IPs. That is lesser than 227, and it is lesser than your requirement also, because every department needs 150 usable IPs. With 128 IPs, how can you give 150 usable IPs to each department? So that is not possible. And anyways, it is also not equal to 227 or 228. So then guys, with /24, again, you get 256 IPs. That is greater than 227 or 228, not equal to 227 or 228. So now you tell me one good thing. Can you give 227 or 228 exact IPs to your each department? Is there any subnet mask that is doing that? Is there any subnet mask that is giving 227 or 228 IPs? No. So the closest match that you can go with is not /25, because that gives lesser number of IPs than 227 or 228, or even your required IPs, that is 150 usable IPs, correct? So then you will have to go with what? You will have to go with /24, that is 256 IPs for each department, guys, and you don't have any other option. Yes or no? So either go with /24 or more than that, right? So the least possible option that you can go with is /24. Do you all agree with me or not? Right? Got it? So now if you assign /24, that is 256 IPs to your each department, guys, for your each subnet, then you have how many departments? How many subnets? 9. So 2/24, that is 256 into 9. That means you will end up giving 2304 IPs to your 9 departments. Am I correct? Am I correct or not? You will end up giving 2304 IPs to your 9 departments, right, guys? But then, guys, with /21 as the subnet mask for your overall organization, you are only getting 2048 IPs. So out of 2048 IPs, how can you give 2304 IPs to your 9 departments? Is it possible? Is it possible that out of 2048 IPs, you will give 2304 IPs to your 9 departments? Of course not. And you cannot go below or greater than this /24, correct? So this is fixed for your individual departments. So individual departments overall have to give 2304 IPs, correct? So that means the overall subnet mask for your entire organization should not be /21. it should be greater than that. Like it should be /20 because it should give you more IPs than 2048. Do you all agree with me or not? So with /21, it's not going to work, correct? Because this is contradictory. Because with /21, you get 2048 IPs. That is lesser than 2304. And yes, of course, since that is lesser than 2304. So the point is that out of 2048, you cannot assign 2304 IPs to your 9 departments. So then you go with /20 as the subnet mask for your overall organization. And that way you get how many IPs? 4096 IPs. Okay, and out of 4096 IPs, you assign 2304 IPs to your 9 departments, and then you're left with 1792 IPs. So what? That's not a problem. But then you can cater your organization's requirement this way. So for your overall organization, the subnet mask will be /2020, and for the individual departments, it would be /24. See, one more thing, just last thing here. So with /30, see, can you give /30 as the subnet mask for your overall organization? /30 as the subnet mask for your overall organization, guys. Can you take that? Sorry, not just this network, but any network. Can you take /30 in the cloud? The answer is a no, guys. Why? Because if you take /30 for any network, so it is like the usable IP, the IPs will be 32 minus n will be 32 minus 30, that is 2, and 2 to the power of n, that is 2 to the power of 2 will be 4. So you'll have 4 overall IPs, correct? So out of 4 IPs, 5 are reserved. So you'll be left with -1 IP. So you cannot take this, right? Okay, so of course, if /30 is not allowed in cloud to be taken, so /31 and 32 are again not allowed. Someone was asking me this before. Then what about /29? So with /29, the value of n will be 32 minus 29, that is 3, and 2 to the power of 3 is 8. So you'll get to 8 overall IPs, out of which 5 are not usable. So you'll still be left with 3 usable IPs. So theoretically, you can take /29 as the subnet mask, but practically not, guys. Why? Because you don't design a network with only 3 usable IPs that can be assigned to 3 computers, correct? So practically, you should not go below /27, correct? Is that clear, guys? Yeah. So one thing is remaining is that here is that we have designed this network. So out of these so many networks that we have designed, shall I show you how you can create one of the network in AWS, right? It's just a 2 minutes process, right? Shall we create a small network that we have designed here? Yeah. So here, let's take this up. Okay. So fine. So this was the requirement, correct? So in this, we had organization with 2 departments, correct? So like VNet, VPC with what? 2 subnets. Okay, so let's go and do that. So let's create a VPC with this subnet mask, and then 2 subnets with this subnet mask. Okay, and with this CIDR block, correct? So let's go and create a VPC with this CIDR block and the subnets with these CIDR blocks. So how can you do it in AWS basically? So you can just go to AWS, search for VPC, and then you can go to your VPC, or you can say create VPC. You can create VPC only, and you can give this VPC a name. Let's say test VPC. And here you can give that CIDR block. So CIDR block, anyways, I have mentioned it here. So that is 172.16.0.0/23, the one that we have designed, guys. Okay. So you can just give it here. And that's it. And you can just say create VPC, correct? So create VPC this way. Once the VPC is created, now you can add subnets to it. So to add the subnets to your VPC, you can just go to subnets. Then you can say create the subnet. Okay. So now when you create the subnet, you need to select that VPC, test VPC, inside which you can add your subnet. So you can say subnet 1, and you can give that the CIDR block as the one that you have designed, that is 172.16.0.0/24, and then 172.16.1.0/24. So first subnet CIDR block first, here given, tags are optional. So you can just create this subnet, or you can add another subnet also here and then create it. So add another subnet, and then you can give it a name. Let's say subnet 2, and then you can give it here as 172.16.1.0/24. And then you can say create subnets. So this will create 2 subnets in your one VPC, correct? So you have one VPC created. The first one is the default VPC that is created in every region by Amazon. So this is your VPC, test VPC. And then if you go to subnets, so these are the 2 subnets that you have created, correct? They are the part of your test VPC, correct? Yes, guys. So this is what I wanted to tell you. Yeah. If this is something that you have you're not doing it along with me. Anyways, I didn't tell you to do it along with me. This thing, you can just watch for this. Anyways, we will do this in detail tomorrow. Right. So is it clear, guys? So we have designed our own network, and then we have created our network also in AWS. Now I am deleting it in front of you so that if you want to see how you can delete, you can see it. So yeah. So deleting the VPC, and that deletes the subnets also. So VPC I've deleted. So along with that, the subnets also gets deleted. Now let's go to EC2, and maybe I can just close this EC2 instance, close this window, and then I will go what? I'll go to volumes. I'll rather go to snapshots and delete the snapshot first. Lifecycle manager, anyways, I had not created that event. So I'll just delete the snapshot first. So this is deleted. Then lifecycle manager I had not created. Then the volumes. So see, 30 GB of volume, you cannot delete it directly because that is associated with your instance as a root volume. So delete the instance, and that would be auto deleted. You can check it later after deleting the instance. But this 2 GB of volume, you can detach, and then you can delete it. So without detaching, you will not be able to delete it. But yes, after detaching, you will be able to delete it. Successfully detached, but it's not showing up. It's still showing the same. I'll say force detach it. It says successfully detached. I'll just refresh it. So I'll now go here. What is happening then? I'll go inside this, and then it's just in use, it's showing. Basically, now it's showing available. So now I can delete it. Okay, so yes, this is how I deleted this. And then now you can go and delete your instance as well. So then the 30 GB volume will go deleted. Yeah, so it is that only. I think I am also facing that issue, right? So I will just go to instance settings, change termination protection. So see, I'll disable termination protection because it was enabled. So I was unable to delete my instance. Now that it is changed, it is disabled. So now I'll be able to terminate my instance. So see, now it is successful shutting down, correct? So now it's successful. I'm able to delete my instance. And once the instance is deleted, the volume will also go away, the root volume. The root volume will go away. If it doesn't, then you can delete it from here. Right, so this was what I created, and I think this is what I am already being terminating it. So it would be terminated as such. Right? So yeah, that was it. Then fine. So see, even on Google, if you will Google it out, see, it gives you that only. AWS free tier includes 30 GB of storage, 2 million IOPS, and 1 GB of snapshot storage with Amazon EBS store. Free tier limit. That billing will show you. And this is what G Praveen, even here also you can see it. I've just typed AWS free, AWS EBS free storage limit, and it says it's 30 GB of storage. Correct, with 2 million IOs and 1 GB of snapshot storage with Amazon EBS. And see, Amazon EBS pricing from AWS, you can see to this pricing. See, here it is given on the Amazon's website itself. Amazon AWS website, free tier, right? Even the pricing calculator is mentioned here. And in this free tier, it's mentioned here. The free tier includes 30 GB of Amazon EBS. Correct? Yeah. So can you see this? Yeah, so it's there. Yeah. In public cloud like AWS, it will not conflict because that is for your account that you will take it up. Somebody else will take it up for their account, right? So that will not conflict here. But yes, in your on-premises environment, otherwise in your organization, if you're using it up, then again, the same another network you cannot create with the same IP address range, correct? In your organization. Even in AWS, like let's say if you are creating a network with the same CIDR block, and I am also doing it, and if we want to peer our networks, if you want to connect our networks, so that will not be possible, because the point is that similar CIDR blocks or overlapping CIDR blocks network cannot peer with each other. Otherwise, there'll be a problem of duplicate IPs, correct?
Just a quick info, guys. Intellipaat offers advanced certification in DevOps and cloud computing in collaboration with IIT Pravartak, a technology innovation hub of IIT Madras. This online advanced certification in DevOps and cloud computing by IIT Pravartak will help you gain expertise in DevOps, access management, DevSecOps, Terraform, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel. The link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take your first step towards career growth in the field of cloud and DevOps.
So we'll be quickly discussing on the IP addressing concepts. Again means I'll just summarize it. And then second is we will be starting with VPC. That is VPC, or you can say virtual private cloud. And in that, guys, we'll see if we can discuss about NAT gateway. I would like to discuss on that, and the NAT instance. I'll open the IP concepts quickly here. See, IP concepts, I'll just show it to you from here itself. Correct, I'll not copy it again and again. Okay, so IPv4, as I told you, it's a 32-bit addressing scheme that has 4 octets, where each octet carries 8 bits. So overall, it's 32 bits, correct? So just an example, like ABCDC class. So 192.168.0.4 is an example of IPv4 address. And then I told you that private IP addressing is nothing but, these are the IP addresses ranges that you can use in your virtual network. They are, that is something that you can use in your VNet, in your virtual network, these private IP addressing, correct? And then there are 2 types of IP addresses, as I told you yesterday itself. That is, we all know that is a public IP address and a private IP address. So public IP is used over the internet, which is routable over the internet, and private IP address is used in the company environment or in your intranet, correct? So then I told you this thing that, these are the IP address ranges that are reserved that you can use in for private IP addressing in Azure, AWS, or GCP, all of the clouds, correct? Or even in your on-premises. Then I told you about CIDR block. So CIDR is a classless interdomain routing. Okay, and it's nothing but a block of IP addresses, or you can say the range of IPs. So this was an example of a CIDR block, 192.168.0.0/24. Okay, now here, this is called as a CIDR block, and in this 24 is called as the subnet mask. Okay, fine. So that's the case. So then we had these questions that what is the overall IP address range in this network? We needed to check what is the overall IP address range in this network, then what is the usable IP, and what is the subnet mask representation. So for calculating the overall IP address range in the network, we had the formula as 2 to the power of n, where n in IPv4, which is a 32-bit addressing scheme, is given by what? 32 minus the value of subnet mask. So that comes out to be 8. So 32 minus 24 is 8. Okay. So n value is 8. So 2 to the power of 8 is 256. So this is 256 overall IP range. And then if you represent it, so you can go from 0.198.192.168.0.0 to 192.168.0.255. Okay. So this was the answer to the first question. Then the second question was, what was the usable IP address range in this network? So in on-premises, the usable IP range is given by the formula 2 to the power of n minus 2. Now, why minus 2? Because the first address is reserved for network address and the last address is reserved for broadcast address. So that's why minus 2. They cannot be given to user computers. So it was 2 to the power of n minus 2. So 256 minus 2, that is 254. Okay, so first and last result. So the usable range goes from 0.1 to 0.254. 0.0 skipped and 0.255 skipped. Okay, so that's how it goes. Then we had this subnet mask representation. So 24 was the subnet mask, correct? So how would you represent it? Out of 24, you give 8 to the first octet, then 8 to second octet, then 8 to third octet, and then you're left with of 24. So on the fourth octet, there'll be a 0. So then we represented it like this in the powers of 2. So 1, 2, 4, 8, 16, 32, 64, 128 each octet. So 4 octets. And then since first octet contains say 8, so there are 8 ones. Then second octet again 8. So 8 ones. Third octet 8 ones. And then fourth octet there is no one. Right. So there are all zeros. There is nothing because there is 0 in the fourth octet. So there are all zeros. So then it was like you need to add all the weights, whichever contains ones. So it was 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. So 255. This also 255. This also 255. And this is 0. So it's 255.255.255.0. Okay, fine. And then subnet mask can be helpful to find out the addresses in a particular network. Typically on your networking devices, the addresses are mentioned in the form of subnet mask. Okay. Fine. So this is what we saw. And then I took another example wherein this was the CIDR block. Then the n value was 32 minus 23. That is 9. So overall IP address range in this network would be 2 to the power of 9. That is 512. And since we cannot go beyond 255, so we go from 0.0 to 0.255 and 1.0 to 1.255. So 256 plus 256, that is 512 IP. So the overall range goes from 0.0 to 1.255. And why we cannot go beyond 255? Because every octet is of 8 bits in IPv4 addressing scheme. Since it's 32 bits, every octet 8 bits. So 2 to the power of 8 is 256. So every octet can take a value ranging from 0 to 255 only. Not then the second question was that usable IP address range in the network. So it was again by the same formula, 2 to the power of n minus 2. So 512 minus 2, that is 510. So it goes from 0.1 to 1.254. First and last is what you have skipped. Then the subnet mask representation. So since it was 23, so you would have 8 ones here, 8, and then you're left with 7 out here. So you will give 7 here and then 0 here, right? So then when you represent it, so it is like all ones here, all ones here, all ones, 7 ones here, and then all zeros here. And you start from LHS, correct? So it is 255, 250, and 254 because you will not add this one because it contains a 0 here. So it would be 255.255.254.0. Correct? I hope this is clear to you. And then I talked about AWS networking, or in general, it is true for cloud networking. So AWS or Azure, it is true for that. So AWS networking, overall IP address range in a network is given by the same formula, 2 to the power of n, and usable IP range in a network is given by the formula 2 to the power of n minus 5. Okay. Now, why minus 5? So in on-premises, it was minus 2, but here in cloud, it is minus 5. Now, why minus 5? Because here there are 5 addresses that are reserved. Like in on-premises, you have 2 addresses reserved for network and the broadcast, but there are 3 more addresses that are reserved, one for DHCP, Dynamic Host Configuration Protocol, one for the router, and one, I would say, Amazon. Okay. If it would have been Azure, so I would have said one Microsoft reserves for future use, but here I'll say one address Amazon reserves for future use. Okay, so that's how 5 are not usable, cannot be given to user computers. So now see, let's say we are taking this problem, that is wherein we were having like, I told you that let's say we have an organization with 4 departments. Okay, how many departments? 4 departments. Each department's today's requirement is of 100 server and future requirement of 100 more servers. That is 10 years down the line. So to design the network for this organization, should we consider the future requirement? The answer is always yes, because if you don't consider it, then maybe in future you'll have to redesign or modify your network, because if you don't have those many IPs. So you should always consider the future requirement. Okay. So now the point was that if what was the requirement here? The requirement was 100 plus 100 in each department, 200 in each department, and 4 departments. So 200 into 4, that is you had a requirement of 800 servers, correct? Right. So total addresses that we need, usable addresses, were 800 for 800 servers. So I told you which subnet mask we should choose for designing this network. So then we had the answer is /22, correct? Because that's what I'll put it here. Because see, with /24, you get 2 to the power of 8. There is 256 IPs, because n is 32 minus 24, 8. Okay, so 256 is less than 800. You don't go with that. Even 512 is less than 800. Don't go with that. With /22, you get 1024 IPs, and 1024 is what? 1024 is greater than 800, correct? So of course, 1024 is greater than 800. So you can assign that. And since there are 4 departments, so if you divide it by 4, so every department will get 256 IPs, or every subnet gets 256 IPs, because I told you department is equivalent to your network here, and organization is equivalent to your network here, and department is equivalent to your subnet here, correct? So every subnet, every department gets 256 IPs, and anyways, every department needs 200 usable IPs, so they can be given from 256 IPs. So this was good. So for each department or each subnet, the subnet mask was 256, that is /24. And for the overall organization or overall network, it would be /22. Okay. So with this particular thing in picture, we were able to design our network, correct? So then I told you we can go from any of these address ranges for the VNet or VPC here. Correct. So it can be 10.0.0.0/22 or 172.16.0.0/22 or 192.168.0.0/22. So you can take any of them. So let's say if we decided that we'll go with 192 block. So then we go from 192.168.0.0 to 0.255, 256 IPs here. How many times I'll have to go? I want /22, that is 1024 IP. So I'll have to go 4 times. So from 0.0 to 0.255, 256, then 1.0 to 1.255, again 256, then 2.0 to 2.255, again 256, and then 3.0 to 3.255, again 256 IPs. Correct. So that's how it goes. And so this and this is like 256 IPs for each subnet also you need. So this can be termed as your first subnet, second subnet, third subnet, fourth subnet. And 5 addresses that are reserved are not just it's not like from the entire network they are reserved, but it is from every subnet 5 addresses are reserved. So 5 addresses will be subtracted from each subnet. So and which 5? The first 4 and the last one are reserved. So 0, 1, 2, 3 and the 255 is reserved. So the usable range, that's why it goes from 0.4 to 0.254. Okay. Then here the usable range goes from 1.4 to 1.254, 2.4 to 2.254, and 3.4 to 3.254. And let's say if I create a VM here, so it will take any IP from this usable range. And how many VMs I can maximum create in this subnet? So 256 were the IPs, out of which 5 are not usable. So 251 are usable. So I can create 251 VMs in this subnet. Similarly, here I can have 251 VMs, here also, here also. So overall 1004 VMs I can have. Okay. So then I took another problem. Okay. Which was again, so then if there are 2 departments, so the the need would be not for 800 servers, but for 400 servers, correct? Because 200 plus 200, that is 400 for 2 departments. And with 400 in picture, you would have gone with 512 as the address space, correct? /23, that is for your individual departments. And then /24 for your individual subnets, because every department would need 200 IPs, correct? So /23 for the overall organization and /24 for the individual department, /23 for the VNet, /24 for the subnet. Understood? Right. The second example that I took was similar to that, what your query was. So let's say if we had 2 departments and every department's today's requirement was 200 hosts and future of 20 hosts. So overall requirement was 200 plus 20 into, that is 220 into 2. So it is 440 host. Fine. So yeah. So /24 256 will not cater to 440 host. So 23 will, because you get 512 IPs, out of which you can assign 440 IPs to 440 host. And you have 2 departments, so divided by 2. So each department get 256 IPs, and anyways, each department needs 220 usable IPs that can be given from 256 IPs. Okay, so I went with 172 block and then /23 for the VNet. And then I represented it as 0.0 to 0.255 and 1.0 to 1.255. Overall, 512 IPs, 256 plus 256. And this is your subnet 1. This is subnet 2. So it goes like 0.0/24 and 1.0/24. So usable ranges from 0.4 to 0.254 and 1.4 to 1.254. Okay, and then we went with the bit tricky problem. Okay, and that was this one. That is my today's requirement is of 50 hosts. There are 9 departments in my organization, out of which every department's today's requirement is of 50 hosts, and future requirement is of 50 more hosts. So what is the overall requirement? So what was the overall requirement, guys? 150 into 9. So it was 150 into 9, that is 1350 hosts. And for getting 1350 or more than that value, we went with this subnet mask. It is /21 initially. Okay. If I would remove this initially. So /24 gives 256 IPs, that is less than 1350. Even 512 is less, 1024 is less, but with /21 you get 2048 IPs. So that is greater than 1350. So we thought we will go with this. But then there are 9 departments, so we divided it by 9. So every department should get 227.56 IPs, that is 227 or 228 IPs. But then there was no subnet mask that gives exactly 227 or 228 IPs, because /24 gives 256 IPs, that is more than 227 or 228. And with /25, you get how many IPs? With /25, you get 128 IPs. So 128 we cannot take because it was less than 227 or 228. At the same time, it is less than 150 also, which was the need of every department. So this was not possible to take, but we cannot get 227 or 228 exactly. So then we had gone with /24, which gives 256 IPs. Okay, out of which 150 IPs can be given to 150 machines in each department. So then the point was that if for each subnet you was assigning /24 as the subnet mask, so there are 9 such subnet, 9 such departments. So 256 into each department. So 9 departments is 256 into 9. So you had to give 2304 IPs to your 9 departments. Okay, overall. But then the point was with /21, you was getting 2048 IPs only. So out of 2048 IPs, how can you assign 2304 IPs to your 9 departments? Is it possible? No, of course not. So then this /24 also we cannot change because we cannot go with /25. So this has to be at least 2304 IPs to each department, correct? So then with /21, you cannot have those many IPs for each department. So of course, with /20, you can. Okay, because with /20, it's like getting 4096 IPs. And out of 4096 IPs, you can easily assign 2304 IPs to your 9 departments. And then you are just, and you are left with 1792 IPs. So that's not a problem because they can be there for future use. Okay, so that was the point. And then finally, I did tell you this thing, that is, can we assign /30 in the cloud to any virtual network? The answer was no, because with /30, the value of n is 32 minus 30, that is 2, and 2 to the power of 2 is 4. So 4 was the overall IPs that we get, out of which 5 are not usable. So it is -1 IP. So of course, you don't get any usable IP. So you cannot go with /30 as the subnet mask, and 3132 is also not allowed for any network in cloud. But with /29, you get value of n is 3, and then 32 minus 29 is 3, and then 2 to the power of 3 is 8. So you get 8 overall IPs, out of which 5 will not be usable. So you get 3 usable IPs. So theoretically, yes, you can take /29 with 3 usable IPs, but practically not. Why? Because you don't want to create a network with what? With only 3 IPs that can be given to 3 machines, right? So practically, you should not go below like about /27. Okay. We are here. And then I said that This was the look and feel of AWS portal. Correct? We had anyway seen that. Okay. So you need to select the region from here in which you want to create your resources. Plus there is notification tab here. Plus you can search for services. Plus there is like different heads in which you have the different services. Like you have in compute, the EC2 and other services. Okay. So, and if you want to use some service very frequently, so you can just mark it in the favorite by clicking on the favorite mark here, like VPC. If I want to use it frequently, so I can just check the star mark and then it would be added to my favorites. And if I remove that, it would be removed then. So yes, so I just wanted to show you how we can create that network that we had designed. So just go to VPC and then you can create your own VPC here. That is that network. So you just go to your VPCs and then you say create VPC. You say VPC only. You can give your VPC a name. Let's say test VPC. Okay, and then let's say I went with this example, this simple small example wherein the VNet was 172.168.0.0/24. So I just gave that. And then that's it. And then I just went and created this VPC, and then the subnets I'll create later after creating the VPC. So then I went to subnets and then I said create subnet. And then again, I went here like, and I had given the subnet cider block. So this was the first one. I should select the VPC in which I want to create the subnet. So that was my test VPC. And see, in AWS, as I told you, every region will have a default VPC of its own. So like here also you have a default VPC. Okay, but we are creating a custom VPC. Yeah, so I'll give this, let's say subnet one as test SN1. Okay, and then I gave the cider block here. And then I just went and added another subnet also. So I said test subnet 2. Okay, and then I gave another cider block wherein I would say 0.0 instead of that 1.0 because that was mentioned here, right? 1.0. Okay, /24, and then I said create. So this is how I created my VPC with my two subnets, and then you can create the resources, that is the virtual machines inside it, correct guys? So we had designed a network and then we had created a network, right? So this is how I did it. And then we went and deleted our VPC and the subnets in that by default got deleted. So see, currently you can create 200 subnets per VPC. But if you want to create more than that, so if you would like to create more, then you have to submit a case at the support center of AWS, right? If you want to create more than 200 subnets in a VPC. Okay. So currently in one VPC, you can create 200 subnets maximum. If you want to create more than that, then you will have to submit a case to the support center in AWS. I'll select the VPC instead of default VPC. I'll select that VPC where I want to create that instance, correct? Anyways, that will come in our example. I mean, in our lab. Not 200 servers. It is like 200 subnets in one VPC you can create. And one subnet can have many IPs. Like here, if you can see, in this example, your one subnet had 256 IPs, out of which 251 were usable. So in every subnet you can create here in this example, how many VMs? 251 VMs, right? Right. So shall I move ahead and then we will discuss about what? About VPC. We had discussed, I mean, just created a VPC, but I would like to get into the greater detail of it. And then probably we'll discuss about internet gateway and stuffs with that. So maybe instead of net gateway, I'll just write down here that first we will discuss about internet gateway here, along with this VPC, internet gateway, of course, VPC subnets, internet gateway, and then route tables. Right. So let's take up a story, guys. I will take up a story and I will try to explain you the concept with the help of that particular story. Okay. So let's go and do that. Yeah, so I'll draw it, guys, because I have it drawn, but then if I'll show you from there, it would be confusing, right? So I'll draw it here and I'll show it to you. Okay, so let me draw it here. So I'll just go to paint and I'll draw it. I'll draw the story, guys. So let's say, guys, we have a village. Okay. So this is my village. Now, so we will just call it as our VPC. Okay. So this village is equivalent to my VPC. Okay. Correct. And then in this village, there are, let's say, some houses. Now, this is a self-created story, right, guys? Okay. But I think like this is good to understand the concept. Okay. So the concept of route table, internet gateway and stuff. Even the NAT gateway, NAT instance also, right? So let's say in this village, we have houses. Okay. So let's say these are the houses in my village. So I can have many houses, 2, 4, 8, whatever, right? So just for the purpose of simplicity, let's say I have what? I have 2 houses in this village. Okay. I can draw 4 houses also. Sure. Thank you, Yash. Yeah. So I can take up 4 houses, but then in practical, I'm going to create only 2 subnets. So let's create 2 houses then, right? So let's say these are my houses in the village, and I can just call them as what? Shall I draw 4 houses or shall I draw 2 houses? Diagram will look good with 4 houses, but in practical, we are going to create 2 houses. 2 houses mean 2 subnet. Okay. Anyways, I was just asking you. So I'll just go with 2 here. I'll show you that diagram with 4, but then in practical, we are going to anyways do it for 2 subnets. So we'll draw 2 houses here. So that would be better. There'll not be any confusion then, right? Otherwise, unnecessary, there can be some confusion that can come into picture. All right. So for clarification, this is good, Premkor. Ideally, in one VPC, you can have up to 200 subnets, right? So let's say this is my VPC, this village, and inside that I have these 2 houses. That is the 2 subnets. Okay, so they'll be called as my subnets. So this is, let's say, my subnet, or let's say my house A, and this is my house number B. Okay, fine. So that's the point, right, guys? And now the point is that, just tell me one good thing here, guys. So see, I told you that, okay, before I tell you that, tell me one good thing here. The houses in a village, can they talk to each other by default? It's like neighbors, can they talk to each other by default? Or you need some internet connectivity, stuff like that? No, of course. So they can talk to each other by default, right? Okay. Without a router, they can talk to each other, right, guys? So these houses will be able to talk to each other by default. And that is the principle that goes with the subnets of your VPCs also. So the point is that the 2 subnets in a VPC, in the same VPC, can talk to each other by default because they are internally connected with each other. And that is possible again with one of the bits that is reserved, that is 1 bit, as you saw, that was reserved for the router. So with that, the subnets of the VPC can talk to each other by default. So this A and B subnet can talk to each other by default. Okay, fine, all good, right? So this is good. And then, guys, the point is that these subnets can talk to each other by default, or these houses can talk to each other by default. I can just write down here, this is my house, or you can say the subnet. Okay, so they can talk to each other by default, right? Because the subnets of one VPC can talk to each other by default. Okay, now, guys, the point is that let's say this is my VPC, so I can give this a CIDR block. So let's say the CIDR block of this VPC is 192.168.0.0/16. Let's say I give this CIDR block to my VPC. Now you know what is a CIDR block, correct? And then inside this VPC, let's say my subnet CIDR block, subnet 1 CIDR block is 192.168.0.0/24. Okay, so let's say I give this CIDR block to my subnet 1 or house 1, and then another subnet having this CIDR block 192.168.1.0/24. Okay, so let's say this is my CIDR block to my another subnet. Okay, fine, all good. This is all good, guys. Now so this is a village, as I've said. So let's say there is no internet connectivity in this village. What? There is no internet connectivity in this village, guys. But then there is this house, that is house number A. So owner of this house number A wants internet connectivity in his home. So what he will do is, he will just contact the sarpanch of the village, the head of the village, correct? And he'll just ask that sarpanch that, hey sarpanch, I want internet in my house. So can you please help me and get that internet connectivity for my house? So sarpanch is like, we don't have internet in our complete village. Okay. So guys, please do cooperate with me and take, because now you have 5G and I mean, almost all villages also do have that. Correct. So, but let's take the example of the old days maybe, right? So, there is no internet in the entire village. So sarpanch is like, there's no internet in the entire village. So how I'll get the internet to your house? So what sarpanch decides is, let's contact to an ISP in the nearest city possible, right? So there is let's say one city here, that is the nearest city to this village. Okay, and in this village, in this city, there is an ISP, that is internet service provider, right? So what sarpanch does is, he goes to this city and then he contacts the ISP out there, that is the internet service provider out there, and he tells this ISP that, hey, internet service provider, can you please provide internet in my village, as one of the house in my village needs internet capability. Okay. So then ISP is like, what you are saying, only one house needs internet capacity in your house, in your village? Like, do you have any more houses that needs internet capacity? So sarpanch is like, no, only one house needs internet capacity, right? So sarpanch is like, I cannot set up my entire network in your city, right, for just one house. Okay. So he says, I'm sorry, I cannot do that. So it's like he tells him that if there are more houses interested, then probably I can set up internet in your village. So then sarpanch goes back to the village and he tells owner of house A that this is the reason, and that's why internet cannot be brought to our village, to your house. So then this house owner A connects with other house owners, let's say B, C, D. Here, you can only see B. Okay, so he connects with other house owners, and let's say there is one house C or D that agrees for internet capacity, but this house B doesn't agree for this internet capacity. Okay. So house B is like, no, I don't want internet capability in my house, but there is house C or D that needs internet capacity in their house, correct? So the point is, let's draw two more houses. That would be better, guys. Okay. Because it would be like, I would be able to show you. Okay, let's me just give one moment here so that it's better for you to understand. So let's say instead of two houses, we draw, let's say, how many houses? Let's say 4 houses. Okay. So let me draw 4 houses here. Correct. Okay. Now this is completely occupied. So let me draw these 4 houses. Okay. And one thing is clear, all these 4 houses will be connected to each other by default. Correct? Correct or not? Right? Yeah. So let's say these are the 4 houses, A, B, N. Then you have the C and you have the D. Okay. So let's say B are big houses and CD are small houses, but then there are these houses, right? So now the point is that this A house connects with the owners of B, C, D, and he asks them that, hey, house number B, C, D, do you want internet capability in your house, right? So house number B and D is like, no, we don't want internet capacity, but C agrees. Okay, but C house agrees for internet capacity in his house. Right? So then what? Then what? This A village owner goes to the sarpanch and he tells him that C house owner is ready for internet capacity in his house. Correct. So then this Sarpanch again goes back to the ISP and he tells him that now instead of one house, there are few more houses. Like there are 2 houses that are interested in internet capacity. So now can you bring the internet in our house, in our village? And then when you will bring it, more number of houses can be added in the future. So ISP is like, okay, fine. So now I'll bring the internet capability in your village. Okay. So now ISP brings the internet capacity in this village. Correct. So then he sets up the circuitry, the connections in this village. So it's like, let's take up this red one here, right? So he's like, he sets up his circuit in the village, on the village boundary, guys. So let's say this is my village boundary, correct? And let's say he installs his circuitry on the village boundary, correct? So I can just call it, this is the circuit. And let's say this is what? This is the IGW, that is internet gateway, through which the internet can be brought to the village boundary. Now, guys, tell me one good thing. Tell me one good thing. So now the internet has been brought to this village. Now, who wants this internet? Who wants the internet, guys? Who wants the internet? House number A and C, correct? So now the point is that if at all, you will take what? If at all you will take one connection, one route from here, from internet gateway to your house number A or C, or to this particular connection of house number A, that is if you connect this internet gateway to this default route table. So this is what? This is your default route table, correct? So this is what? This is the default route table. Okay. So this is what? This is the default route table. So now if the connection is made from the internet gateway to this default route table, guys, so will A and C be getting the internet? Will A and C be getting the internet? Yes, of course. A and C will be getting the internet. But tell me one more thing here. Apart from A and C, will it be like B and D will also get the internet? Yes, even B and D will get the internet. But are B and D going to pay for the internet? The answer is no. Do they want internet in their houses? The answer is no. Correct. So then what should happen? No, access will not be denied like this. Correct. So they will get the internet. Correct. So that should not be given to them. So what is the option that you can use? Yeah, you can, if they are use the same default route. So with the default route, all the subnets are connected. So they'll get the internet. But that is what that should not be given to them, right? So the default net should not be given to, them. So then, yeah, you can do that. Or otherwise, what you can do is rather than connecting the default route table, default route with your internet gateway, which will give A, B, C, D, all of the houses the internet capacity, what you can do is you can create a separate route table. What you can do, guys, you can create a custom route table. What you can do is you can create a custom route table connecting only your house A and C. And on this custom route table, you can just connect what? On this custom route table, you can just connect your...
Let's have a quick quiz question, guys. And the question is, what is the primary use case for AWS Lambda? And your options are storing and retrieving large amounts of structured data, running and managing virtual servers in the cloud, or building and deploying machine learning models, or executing code in response to events without the need to provision or manage servers. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers advanced certification in DevOps and cloud computing in collaboration with IIT Pravartak, a technology innovation hub of IIT Madras. This online advanced certification in DevOps and cloud computing by IIT Pravartak will help you gain expertise in DevOps, access management, DevSecOps, Terraform, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel. The link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take your first step towards career growth in the field of cloud and DevOps.
Internet, that is connect your internet gateway. Okay. And then guys, when this custom route table is connected to the internet gateway, which is connected to house number A and C only. So now which house will get the internet? Only A and C, right? Yes or no? Yes. So only A and C will get the internet now. So this is the solution here, correct? So then the point is that this will be called as my cust route, that is custom route table. So I can say this is my cust route. And then let's say this was my default route, correct? So this is my default route table. Right. So this way I can address the issue and I can make sure that only A and C gets the internet and not B and D. Right. Right. So guys, so this is how it goes. And yeah, so some houses gets the internet, some houses doesn't get the internet. Like this in your VPC, some subnets can get the internet, some subnets cannot get the internet. So this is what you can decide. You can make sure that some subnets get the internet, some subnets doesn't get the internet. By this way, right? Yeah, so with IGW, you will just have your VPC attached, correct? Okay, Juhi, Kumari, yeah. So now the point is, guys, can you think of any real, like, this is what village example I've given you, right? So now can you think of any real use case wherein this can be a requirement that subnets in a VPC are like some subnets need internet and some subnets don't need the internet? Like to some subnets, you will provide the internet capability, and to some subnets, you won't provide the internet capacity. So can you think of any example, any real use case where this can be useful? Private and public subnet, right? Yeah, DB don't need internet, correct? Correct. So what you can do is you can actually have your database server to be running in the private subnets, correct? Because to your database, to your backend, you don't want the users to directly connect through internet. So you can run your backend servers, the databases in the backend servers in the subnets, private subnets in BND, and you can run your front end, that is your web applications, web servers in your front end servers in the in the public subnets. Okay. Fine. So yeah, and then your web servers from the public subnet can then communicate with the database servers in the private subnet, because they can communicate how? Because they all are connected with each other through a default route table. But then the internet will only be available on the public subnets, on the web servers, and not the database servers. And that's what why we need, because on database servers, you don't want to expose them directly to the internet because of security concerns, right? So that is a good ploy, guys, isn't it? Right? So this way you can achieve it, correct? Yeah. So this can be a real use case. Yeah. And this is how you can go about it. Now, every VM. So now once these subnets becomes public subnets, so every VM that is created inside this subnet A and C will be a public VM, will have the connectivity over the internet, and every VM that will create in B and D subnets, that will be a private VM that will not have internet connectivity, right? So that is how it goes. So guys, now if you're clear with this, I will just show you this in lab, and what we can do is we can just create a VPC. Then along with that, instead of 2 subnets, instead of 4 subnets, we'll just create 2 subnets. Okay. And because for the purpose of simplicity and to avoid redundancy, because if we can understand the concept with 2 subnets, why to create 4 subnets then? So we'll create a VPC with 2 subnets, and we will keep one subnet as private subnet and one as the public subnet. Like in this case, this A and C are public subnets. Okay, so A and C are public subnets and B and D are private subnets, correct? So we'll have one subnet as public subnet, and then one subnet as my private subnet. Okay, so that's what I will create. That's how I'll create 2 subnets. And how will I make that one subnet as public subnet? So tell me one good thing. When you create your custom VPC, guys, and when you create subnets in your custom VPC, so all those subnets are public subnets or private subnets initially when you create them in your custom VPC, all of them are private. Why? Because there is no internet gateway. You have not created a custom route table. You have not attached it with internet gateway, correct? So all are by default private. Okay. So then we will create, when I said we'll create a VPC and then 2 subnets in that, and I've said that I want one subnet to be public and one private. initially both subnets will be private. So how I'll make that one subnet public, that A subnet is public. So for that, I'll show you, we'll create one internet gateway. We will create one custom route table also, because there'll be default route table, but then all the subnets will be connected to the default route table. So our both subnets will be connected to the default route table. So we'll also create a custom route table. And then I'll show you that through internet gateway, I'll provide internet connectivity to that subnet, one subnet, and not to the another subnet. So that one subnet will be called my public subnet and the other is private subnet. And then to test it out, what I'll do is I'll create one VM in my public subnet and one VM in my private subnet, guys. And then I will connect to both the VMs, and then I'll show you that from the public subnets VM, I'll be able to reach to internet. I'll be able to run google.com, but from the private subnets VM, I'll not be able to reach to internet. I'll not be able to open google.com web page. Correct. So that is what I'll demonstrate it in front of you. This is what we will see as in of now, and then we will extend this practical if time permits with a NAT gateway and NAT instance. We would like to extend it. Correct. So but that I will tell you later on. But is it clear to all of you, this thing? Yeah. Till this point, as in this diagram, this story, this concept, this real application, okay, where it is useful for backend server, for the database servers, and plus the what? Plus the practical that I will be taking it up from here. Private subnets VM, correct? The private subnet VM will not be able to go to internet, so will not be able to open the Google web page also. But the public subnet VM will be able to do so. If you don't have the internet in the complete village, so maybe they can set this up based on the requirement in that village. If some good houses needs the internet, then only. If you remember, guys, or if you have came across this situation, there were some days before, like not now actually, when like the Geo fiber net and the Airtel fiber nets are in place, but then there were days before when these Geo nets fiber and then Geo fiber and stuff was not there. So at that time, these private cable operators, even now also, they have their existence in picture, and they are doing good, many of them, right? So at that time, these private cable operators, they used to have their internet, correct, the fiber optic cable, right? So let's say I had previously Orange connection, right? So then when I contacted them first time, so they were like, okay, if you have some houses or some other connections in nearby your place, then they come up with their fiber optic cable. Otherwise they say no to you, right? Because they feel like that the amount of costing that it needs to install the fiber optic cable at your house should be recovered, or they should be profitable. Otherwise, they sometimes say no also, because let's say in like 10-20 kilometers, there's just one house who is using the internet, then they may say no to that as well, right? Right. So yeah, so that's there, correct? So they think depending on their business decisions, correct? Fine. So I hope you can connect. Okay, so let's get into this problem and let's do it, right? Okay. So fine. So let's create a VPC. So let's go step by step, guys. You can do it along with me, and I would prefer you doing it along with me. Okay, so let's go and do this lab, guys. So just go to lab, guys, and then do create a VPC along with me, right? Fine. So let's go to VPC and create a VPC. So you can select. So when I go and create a VPC, yeah, correct, Vishnu and Aryan. Right. So just give it a name. So let's say I give this VPC a name, my VPC. So guys, just first select a region, let's say North Virginia, and then say the VPC name is my VPC, and then the CIDR block. Okay. So now just go and get the CIDR block here. So what's the CIDR block you can give? Let's say 192.168.0.0/16. Okay. So that's what I have taken it in my example. So I will go with that. So 192.168.0.0/16, right, guys? Okay, fine. So just give the VPC name and the CIDR block and just say create VPC tags. Don't worry about them. If you don't know, maybe I'll tell you later on, but they are optional, not required. Okay, so just say create VPC and you'll be able to create the VPC. Okay, now do I have to just create the VPC or I do also have to create two subnets in my VPC? Tell me. Of course, two subnets, correct? So I'll go and I'll create two subnets in my VPC. So we have created the VPC. Now let's go to subnets and create the two subnets. So I'll go to subnets and I'll say create subnet. What about tags? Tags are not required, right? So they they are optional. Anyways, I will tell you later on their purpose if you don't know about it, but I'll not put that purpose here because let's go with this lab right now. Okay. So I'll go to subnets. I'll go to create subnet and I will give the VPC name under which I want to create my subnet. So I'll give my VPC. Then I'll give the subnet name here. So I'll just name it as public SN. Right, guys? So I'll just give the name as public subnet. No. So it is like if you give the name as public subnet, will it become public subnet? No. IRCTC internet, something like that. No, of course not. Just giving the name as public subnet will not make it public. Okay. So for that, you will have to make it public by attaching it to an internet gateway, correct? But just for a proper naming convention, because I'll make it public. So that's why I'm creating the name as public subnet. Fine. And yeah, so I'll say, you're welcome. So subnet name is public SN and then availability zone in which I want to have the subnet. So you can put it in some easy or you can leave it as no preference. But guys, so now guys see, availability zone, you can select any and then your subnet would be placed in that availability zone. And then whichever VMs you will create inside your subnet, that will be in that availability zone only. If you don't select any preference for availability zone here, then by default, my Amazon will put your subnet in any of the availability zone, right? So that's the point. Now, guys, I am in North Virginia, so I will leave it to no preference and let my subnet be created in any availability zone. That's not a problem. But if you are, I'm just telling you, if you are in Mumbai region, guys, so in Mumbai region, there is 1A, 1B, 1C, 3 availability zones. So just go with 1A out there or 1B. Don't go with 1C. Why? Because in Mumbai in 1C, you will not be able to create a VM of T2 micro size. Okay. So that's why you just go with what? Just go with availability zone 1A or 1B if you are in Mumbai region. Otherwise, you can create that subnet, but then later on, you will not be able to create a VM of size T2 micro because that is normally not available in 1C, Mumbai region. Okay. So that's why I'm telling you this thing. Right. So here, availability zone, I'm saying no preference. And then CIDR block. So I'll just take this up. 192.168.0.0/16. No, not 16. Which one? So public subnet, I'll just assign it 192.168.0.0/24. And this is inside my VPC, correct? So the subnet should be inside your VPC. So 192.168.0.0/24. Okay, all good. And then I will say create subnet. Is it clear to you? Public subnet. And then I'll say create subnet. Or see, you have to create one more subnet. So can you create it here itself or later? I mean, you can create later also, or you can create it here also. So shall we create it here itself? So yeah, so it's a good thing. So you will say add a new subnet here, and then you can give your private subnet a name. So I will just name it as private subnet. Now you can assign any name, guys. You can give your name also, but have proper naming conventions. Why you want to assign any name? So that's why I want to give a proper naming here to make meaning. So I'll say private SN. Then again, availability zone, I will leave it with no preference. Let it be created in any availability zone. Then the CIDR block. So I'll just go with this example. So 192.168.0.1.0/24. So 192.168.1.0/24. Okay, fine. And that's it, guys. And then I will say what? Create subnet. Can you scroll up to top? Yes. Okay, fine. So first select the VPC, then in which you want to create your subnets, and then go to subnet settings. Give the name public subnet, public SN, and then the CIDR block. And then you say add another subnet, give the subnet name private SN, the CIDR block, and then you need to say create subnet. Right, so guys, we are here. The availability zone can be different, can be the same, should not be a problem. So for both of your subnets, that is public and private, you are giving the CIDR block Shashi Prakash as 192.168.0.0/20. So give 192.168.0.0/20 or 24 to 1. And then the other one should be 192.168.1.0/20 or 24. Right? So 0.0 and 1.0. And then it will not overlap. Otherwise it will, right? And that's why it will not allow you. Okay, so guys, we have created a VPC with 2 subnets. Okay, fine. So this is what we have done. I hope you have done it. So what is the CIDR block of your private subnet and the public subnet? So this is the CIDR block of your what? Private subnet, public subnet. First subnet, second subnet. What if it is for first subnet, which is for the second subnet? What is the second subnet? Verify the IP. Correct. Verify it. It will never give you the error if they are not same. Saying that if I have given my VPC the CIDR block as 192.168.0.0/16 and to my subnets, I am giving some different CIDR blocks like 10.0.0.0/24. So of course that is not inside my VPC. So how I can create that subnet inside my VPC? So the subnet CIDR block should be inside your VPC CIDR block, and then only it can be created inside your VPC. So check for the CIDR block of your subnet and see the CIDR block of your VPC. If it is something like this, so then your subnet CIDR block should be inside the VPC by see 192.168.0.0/24. Just that it is lesser than /16, correct? And then this is 1.0/24. So again, it is inside of 192.168.0.0/16 only, correct? You can always do that in any of the region. But I was explicit in saying that in Mumbai, you should do it. If you're not doing it in any other region, that is okay. But in Mumbai, you should do it, because in Mumbai, if you don't do it, and if your subnet gets created, then in 1C availability zone, so in that availability zone, you will not be able to create a VM of size T2 micro, because that is normally not available there. And that is in free TLM T2 micro. So you would like to create that. So that's why if you are in Mumbai, go with availability zone 1 or B explicitly. But if you are in any other availability zone, you can go, or you may skip it and then let that be created in any availability zone. Okay. Okay. So I said simple thing that when you create your VPC, then 3 things gets created by default. So by default, 3 things gets created when you create your VPC. Okay. And which are those 3 things, guys? I'll just put it here. Okay, fine. That's what you must have missed. So when you create your VPC, 3 things gets created by default. And I'll tell you those. So important properties of subnets in a VPC. All subnets can be able to talk to each other without you doing anything special. So that's I told you before itself that subnets of a same VPC are able to talk to each other by default. They are by default connected with each other with a default route table. Okay. So 3 by default, when you provision a VPC, 3 things gets created by default, guys. First is a default route table, because I told you that all the subnets of a VPC are by default connected to each other with the help of the default route table. Okay, so a default route table gets created. Subnets will be a part of this default route table. I'll just show it to you, that default route table that must have been created. So see, what I said is that 3 things gets created by default when you create a VPC. And what are those 3 things that gets created by default when you create your VPC, guys? So the first thing is a default route table. And by default, all the subnets are a part of this default route table. And that's why all those subnets are by default able to talk to each other in a VPC. Now, I was saying that I'll show you the default route table that has been created for your VPC by default implicitly. So if you go to the route tables, so then you can see here, there are two route tables. So basically the one told you that every VPC, every region has a default VPC. Because if you don't create your VPC, you can create the VMs in the default VPC. Yeah, so now see, I was saying that a default route table, yeah, we'll take up the break. Let me explain this and then we'll take up a break. So I was saying that a default route table gets created when you create your VPC. So here, when I come here, there are two route tables. So one is for your default VPC and one is for the custom VPC that we have created. So every region by default has a VPC, default VPC created, because if you don't create your custom VPC, then your VMs would be placed by default in the default VPC. But you can create your custom VPC, and that's what we have done here. So these two route tables that you can see here, one is for the default VPC that is automatically there in every region, and one route table has been created for my VPC that is for my custom VPC. And see guys, I didn't created this route table, but this got here automatically. So as I said, when you create your VPC, a route table, default route table gets created automatically, and all the subnets of a VPC are a part of this default route table. So this is one thing that gets created, guys. And then there are two more things that gets created. That is, which are the other two things that gets created automatically, guys, are the security group and the NACL. Are the security group and the NACL. See, I've written here the default security group and the NACL, right? These are the other two things which gets created when you create your VPC, right? And these are also created automatically when you create your VPC. So these two things, that is security group and the NACL, will allow all traffic inbound and outbound that should be allowed on your VPC. Yeah, I will. So see, I explained this more. So I said that when you create your VPC, three things gets created by default. That is a default route table. I shown you that. And then, and of course, default route table is the one by which all the subnets of a VPC are able to talk to each other by default. And then two things other gets created. That is a default security group and an NACL. That is network access control list and a security group. Okay. And they will decide that which traffic is allowed to and which traffic is allowed to go outside of your VPC. Correct. Anyways, about NACL, I will tell you later in more detail when I'll take that up. But right now you can just think that it is another thing. It will decide that which traffic is allowed to get inside your VPC and which traffic is allowed to go outside of your VPC, like your security groups, right? And security groups, anyways, I told you yesterday itself. So they allow, again, which traffic is allowed to get inside or go outside of your VPC with inbound and outbound security group rules. Correct? So, fine. Yeah. Okay. So, for this VPC, if you go to NACLs, see, one NACL is there for your VPC, which has two subnets, correct? The other one is for default VPC, but this first one is for your my VPC that gets created automatically. And even if you go to security groups, you will see one security group for your default for your my VPC. So if you go and get the ID of your my VPC, it starts with 09F and ends with 75A. Ends with 75A. Now, if you go to security groups and you see VPC ID, so see, this is the one, 09F75A. So this is the default security group got created for your my VPC, for your custom VPC. Right. Then is this clear, right? So three things gets created by default when you create your VPC. Now, NACL, I'll tell you in more detail later.
Just a quick info, guys. Intellipaat offers advanced certification in DevOps and cloud computing in collaboration with IIT Pravartak, a technology innovation hub of IIT Madras. This online advanced certification in DevOps and cloud computing by IITM Pravartak will help you gain expertise in DevOps, access management, DevSecOps, Terraform, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel. The link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take your first step towards career growth in the field of cloud and DevOps.
Later, I can show you one lab on that as well. Correct. So yeah, but then these three things gets created automatically when you create your VPC is something that I wanted to tell you. So now let's create this internet gateway. Okay. So let's create the internet gateway and then the custom route. So just go to portal and do that. So just go to internet gateway. So here itself in VPC, you will find it where it is. It's here somewhere. Yeah. Internet gateways. Just after route table. And see, this internet gateway is for the default VPC, not your VPC. Okay. So going into internet gateway, just create the internet gateway. So let's create the internet gateway. So what I'll do is I'll just say create internet gateway here. And then I'll give my internet gateway a name. I can give any name. So let's say I give it a name, my IGW. That is my internet gateway. Okay. That's it. I'll just give the name and I'll say create internet gateway. Okay. So once you create the internet gateway, then tell me one good thing. It has been created, but is it attached to your VPC? Like you have created the internet gateway, but you also need to attach it to your VPC, correct? So let's do attach it. So from actions or from directly here, you can say attach to VPC, or from actions, you can say attach to VPC. And you give your VPC name here, my VPC, you'll see it and say attach. Right, guys? I hope this is clear to you. So you need to create the internet gateway and then you need to attach it to your VPC. Then what is the next step like? What should be your next step? So you have created an internet gateway, you have attached it to your VPC. Now let's create a custom route table. Default route table already there, but we want a custom route table. Okay. So now what you do is you go to route tables, and then say what? Create a route table. Okay. So then create route table. I hope you people are doing it along with me. So say create route table and then give this route table a name. So I can say my cust route. Now see, you can give any name or you can give this name. So I'll say my cust route. And of course that custom route table should be created for which VPC? It should be inside your VPC. So you should give your VPC name here. So my VPC, right? Custom route table, attach it to your VPC and then say create custom route table. Right? So I have created the custom route table, guys. Now what's the next thing in? What should you do next? See, you have created that custom route table, you have put it in your VPC, but have you associated it with your subnet? Like it's inside your VPC, but it's not associated with your subnet. So assign it to your subnet. Correct. Right? So just go to subnet associations in this custom route table, go to subnet association and say edit subnet association. And then which subnet you want to attach? Public subnet, correct? So you'll say public subnet, save associations. So you'll say public subnet and then you'll say save associations. Okay, so you have attached it to your public subnet. Okay, guys. So see, you have attached it to your public subnet. Explicit subnet association, public subnet. Okay. Now what? Okay, I just came out of that, my cust route. Let me go inside that. Once again, please. Okay. So see, once you have created the custom route table, then you need to attach it to your what? Public subnet. So for that, go to subnet associations. And there were two subnets in subnets without explicit associations, public and private. So I just clicked on public subnet and then I said attach, and then it was attached to my public subnet, right? So I went into subnet associations. I said edit subnet association, and there I clicked on public subnet, correct? And then I said save association. So this is what I did. Yeah, we'll do that. Yeah. Okay. So this is what we did. Okay. And then what? So see, you have created this custom route table. You have associated it with what? The public subnet, correct? Now what? You need to create a route. Now you need to create a route from this custom route table to go to internet through internet gateway. Yes or no, guys? So if this custom route table, from this custom route table, if you add a route to it, wherein you will say go to internet through internet gateway, then this public subnet will be able to go to internet because that is associated with the custom route table, right? So do that. So go to routes. Don't go to route propagation, go to routes. And then what you do, say edit routes. What? Edit routes. And then guys say add a route. Add a route. And here you give the destination as what? What should be a destination like? Destination should be internet gateway or internet? Tell me. It should be internet. And internet is like 0.0.0.0.0.0/0. Okay. Be attentive, Abhinav. Okay. So I'll tell you. So go to route tables. I'm repeating it. Go to your custom route tables. And then go to routes. Go to edit routes. Go to add a route. Add a route here, correct? Now where you want to go, destination 0.0.0.0/0. That is over the internet. Why internet and not internet gateway? Because you want to go to, ultimately you want to go to internet, correct? Ultimately this public subnet needs internet. So that's why the ultimate destination is internet. But through whom you will be able to go to the internet, the target will be whom? Now Sumit, the target will be the internet gateway, correct? So that's why. So now here, the target is my internet gateway. Correct. So here is the internet gateway. I'll select that. Okay. And then I will do what? I'll save the changes. So go to internet destination 0.0.0.0/0. And then through what? Through the target as internet gateway. Correct. So just save the changes. Yeah, I hope this is clear to everybody, guys. So now your public subnet can go to internet through internet gateway. And since it's a part of custom route table, that's why. So now what? Now what is remaining? Now what is remaining? Create two EC2 instances, correct? One in the public subnet, one in private subnet. And see to it, connect to them. From public subnet EC2 instance, you'll be able to go to the internet. From private subnet EC2 instance, you'll not be able to go to the internet, correct? Okay, but before that, guys, before I go and create the two EC2 instances, before that, just go to your VPC, or no, just go to your subnets and then just go to that public subnet, and do what? Go to actions, and go to edit. What do you need to go? Go to actions and then go to edit subnet settings. And here you enable auto assign public IP address for your public subnet. Now, why you are doing this, guys? Because when you will create a VM inside this public subnet, so that VM should automatically get a public IP address. That should be automatically enabled on your VM. And this is possible if in the subnet settings. So see, you want the VM that you'll create in the public subnet to get the public IP address automatically. Okay. Automatically should be enabled on your VM of the public subnet. And for doing that, in the subnet settings of my public subnet, I should enable the auto assign public IPv4 setting. Now, if you don't do this, still you can assign your VM of the public subnet, the public IP address, but then it will not be automatically enabled. When you create that VM, you will have to enable it then. But if you auto enable enable it on your subnet settings, then all the VMs inside that subnet will automatically get the public IP address assigned to them. So now how you can do it is you need to go to your subnets. Okay, I'll show you again. Then go to public subnet, check on that, check mark on public subnet, go to actions, go to edit subnet settings. And by default, enable auto assign public IPv4 address is not enabled. So just enable it and then just save it. Just enable this, click on this and then save it. That's it, guys. And now you are all ready to create your VMs and test this out, right? So now let's go to this thing. Let's go to the EC2, right? So I'll just click on EC2 from this favorites itself and let's do that. So what I'll do is I'll go to instances. So we'll create 2 instances, guys. And since you want the Linux instances, so we'll go and create the Linux instances. Otherwise also we'd have done that, right? So I'll just go with launch instances. So I'll give this VM a name. Let's say I give it a name as what? VM1, or to give it a better name, public VM1, I'll say. Because I'll have this as my public VM because I'll create it inside my public subnet. Then I'll just go with Amazon Linux as the flavor in the AMI, Amazon in machine images. Now I can go with Amazon Linux 2023 AMI, or I can just go with Amazon Linux 2 AMI. Just below that, okay? And 64-bit is the architecture, so that is good. And then what? Then the instance type, guys. So I can go with T2 micro because that is free tier, right? So I'll go with that. Then what? Then key pair. So I can go with an existing key pair or create a new key pair. So I'll just say create new key pair. And I will say my KP, whatever, 21.5 date. Now see, what is the combination like I told you yesterday? If your base machine is Windows and your virtual machine is Linux, so to connect to that Linux virtual machine, you need a PEM key or a PPK key pair. PPK key pair, correct. So now I have the option of creating a PPK key pair directly here, or I can even create a PEM key pair and then I can use a software called as PuttyGen to convert that PEM key into a PPK key pair. If you want me to show you that, I can do that. Otherwise, I can directly create a PPK key pair. Right. Okay. So this will be public VM, correct. And how it will be a public VM? Because I'll put it inside the public subnet, right? Okay. It will not take much time. So I'll just show it to you. But you also, otherwise also just create it as a PEM key pair, not a PPK key pair. I'll tell you the reason later on why. Because I'll try to connect to my private VM through my public VM. And there at that time, it would be a Linux to Linux connectivity. So I'll need a PEM key pair. So just create a PEM key pair only here, right? And then what? Once that is done, then in network settings, you need to edit this. You need to edit this, guys, because you want your VM not to be in the default VPC, but where you want your VM to be in your custom VPC, in your my VPC. Yes or no, guys? You want that in your my VPC, correct? So you will say, select here, my VPC, and you will only be able to see your my VPC if you are creating this VM in the same region in which you have your VPC. Okay. So I'll just go with my VPC here. And then what? Subnet. So which subnet? Public or private? Which subnet I should put this VM, guys? Public VM1, the public subnet. So I'll go with public subnet. Okay, I'll change it to public subnet. That's it. And now it would be in public subnet. And see this, auto assign public IP. It is by default enabled, guys. Yeah, it is by default enabled because on the subnet settings, I did change that option to enable auto assign public IPv4 settings, if you remember. Otherwise, it was otherwise this would have been disabled by default. Yes or no, guys? Is it clear? So by default, it's enabled. If you want, you can disable it, but it is by default enabled because it is enabled on the subnet settings. But if that would have not been done, so this would have been disabled. So you can enable it from here also. Should not be a big issue. But since it was auto assigned on the subnet settings, so for every VM that you'll create in the public subnet, the auto assigned public IP will be enabled by default. And I'm good with that. Now this is security group. So which traffic I want to allow on this VM, so I can define that. So see, this is my Linux VM. I want to connect to my Linux VM, guys. So which traffic I can allow? So which traffic I'll allow? So I can just allow the SSH traffic, right? So I'll give the same name to this security group. I mean, just the default name, but I'll allow SSH from anywhere here. I want to connect to my Linux VM. That's why, which works on port 22. I told you about ephemeral port range yesterday. Okay. And then what? Then what? Then what? Then what? Then the storage, right? So storage is like hard disk storage. Since it's a Linux VM, I can be sufficient with 8 GB of storage to this VM. So I'll go with that for the US disk. This is all good. And that is it, guys. In advanced details, I don't need to give anything else. Okay. And what I can do is I can just create this VM, guys. So shall I go and create this VM? Shall I launch this instance, one public VM in my public subnet of my VPC? Please scroll up. Okay, so scroll up, scroll up, scroll up. Here is the hard disk. I didn't change this. And then SSH from anywhere I allowed in the inbound security group rules. And I just went with my VPC and the public subnet. Okay, here auto assign public IP was by default enabled. Key pair, I selected my KP 215. T2 micro I gone with. Linux 2 AMI I went with. Public VM1, the name I've given. That's it. Yeah. So just launch the instance then. Okay, now what should be my next step? Anyways, whatever I've shown in this diagram, we have already done that. So I'll create another VPC within the private subnet, correct? EC2 in private subnet, correct? So let's do that. Let's launch another EC2 instance. So I will say launch instance. Why security? What security group you allowed? The default security group only, but then there I allowed SSH traffic from everywhere. Yeah. So which security group you allowed? The same default security group. I just allowed what? SSH from anywhere, right? Created another VM using private subnet. So private VM2 or private VM2, I'll give it. Then again, the same Amazon Linux, and then AMI, go with Amazon Linux 2 AMI. Then instance type, T2 micro. Key pair, I can go with the same key pair that I had given to my first VM, or can give a different key pair also here. So guys, you can just go with the same key pair. That should not be a problem. Okay. So just go with the same key pair. Okay, same key pair for this VM as well. So what was that? My KP 215. So just give that. My KP 215. The key pair that you had given to your public VM that I'm giving to my private VM also. Now network settings, of course, we have to edit this. And we have to come out of default VPC and we need to go to our custom VPC, my VPC, right? And then what? Subnet, which subnet? Private subnet. So I am in private subnet only. So go with that. See, auto assign public IP is disabled here because we didn't enable for the private subnet. And anyways, we don't need it for the private VM. So let it be disabled. Then security group, again, I can go with that security group, or I can have this another security group with any name. And then just I'll allow what? SSH from anywhere. So that is allowed. Correct? SSH from anywhere. That's it, guys. Nothing needs to be changed. Any other thing like storage is 8 GB by default. So that is good. And all good. So just launch this instance. Ideally, it should be from the first VM. Correct. And from my laptop. But I don't know the IP of my first VM, or otherwise I'll get that and allow it from there. Correct. So ideally, it should not be allowed from everywhere. It should be from your public VM. It should be allowed. So you should give the the security group or the CIDR block of your first public VM, security group of your public VM, or IP of your first public VM. You can give it here, but it's okay. In our testing environment, we can just enable it from anywhere. Okay, Sumit, I hope that is clear. The security group is not disabled. It should be there. Security group, you should allow SSH from your public VM or from anywhere. You can do it here. Okay, guys. So now storage is 8 GB of hard disk storage. That is good. Then I'll say launch this instance. Is it clear to everyone? Shall I launch this instance? Right. So just say launch instance and it's in. Now what? Just connect to your public VM. Can you connect to your public VM, guys? So there are multiple ways to connect. I'll show you one of the ways through putty here, how you can connect to your public VM. So just go to your public VM and just get its public IP and connect to it. So guys, through putty, how you can connect. So for that, you need a putty on putty or putty, you call it, on your system, correct? So if you already have it, that's okay. Otherwise, you can download it from putty.org. Okay, so putty.org. Now you just don't get putty from here, but get putty and putty gen. Now why putty? To connect to your Linux VM, and why putty gen? To convert the PEM key to a PPK key pair. So here you can just say what? Download putty, and then you can go with this. See, putty.exe will download this, and then putty gen. That is putty gen. Also, you will find it here somewhere, maybe in the down. puttygen.exe. So you can download this as well. Right. So guys, I already have it downloaded on my system, so I'll not do it again. So what I'll do first, I've just shown you from where you need to download. And once you have it downloaded, then you can use it. So now what I'll do is I need to convert that PEM key into PPK key, right? Do you all agree with me? So I need to convert that PEM key into a PPK key pair. Yes or no? So for that, I'll use putty gen. So I'll just open up putty gen. So I'll just type putty gen. And here it is. And I'll just right click it. So I'll say right click and I'll run it as administrator. So do run it as administrator and then load that PEM key file. So say load, give that PEM key file. It's not showing up. Yeah, Mac users don't need to convert also, correct? You can directly connect to terminal. And from here, you, because Mac users, it's like from Mac to Linux, you can go with PEM key pair, correct? So now from PPK, you just say all files and you will see that PEM key file, mykp215.pem. So just upload it and say, okay, and then say private key, save private key, say this. So don't say generate, guys, load that key and then say save private key and then say yes. And you give the name. So if you want to use the same name, go to all files, get that name. Okay, and then just remove the .pem at the end. So I'm creating the PPK key pair with the same name as I had it for my PEM key pair. I can use a different name also, but just to make sense, I'm giving the same name to my PPK key pair also. And I'll give the extension as .ppk. Okay, that's it, guys. Save it and you're done. So you have converted the PEM key pair into a PPK key pair. You may be downloading the 32-bit version, so go for 64-bit version if your OS is 64-bit version. Okay, it's like too many years. So I know like normally what the error you come across and what should be the error. These files are for Windows. I am using Mac.
Let's have a quick quiz question, guys. And the question is, which AWS service is designed to protect web applications from common web exploits such as SQL injection and cross-site scripting? And your options are Amazon API Gateway, Amazon WAF, Amazon Shield, or Amazon CloudFront. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers advanced certification in DevOps and cloud computing in collaboration with IIT Pravartak, a technology innovation hub of IIT Madras. This online advanced certification in DevOps and cloud computing by IITM Pravartak will help you gain expertise in DevOps, access management, DevSecOps, Terraform, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel. The link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take your first step towards career growth in the field of cloud and DevOps.
Yeah, so I hope that is clear, guys. So now I have the PPK key pair. So now let's connect to my public EC2 instance with that PPK key pair through putty. So I'll go to putty, putty.exe. I'll just right click it and I'll say run as administrator. Run as administrator. And here, guys, just see it very attentively how I need to connect to my VM through putty. So here in the host name, I need to give the command like the username as ec2-user at the rate. So it is like ec2-user at the rate, and then give the public IP. I've given it in the chat window. So ec2-user at the rate, give the public IP of your VM. So what is the public IP of my VM? So here is my VM, and this is the VM's public IP address. So I'll say ec2-user at the rate public IP of my VM. Okay, and not just this thing, I'll also have to supply which key pair, guys? The PPK key pair, if I'm not wrong. Yes or no? Don't you need to supply the PPK key pair? Yes or no? Yeah. So just supply that. So go to SSH. From where? Go to SSH. Don't click on SSH. Click on the plus with SSH. Click on plus with SSH. And then you do what? You click on what? You click on auth. So either you click on plus with auth or you just click on auth. Okay. So see, just click on auth and then you see browse button there. So browse and give your PPK key pair here. And if you don't see a browse button here in auth, guys, because in some versions of putty, it is not there directly. So if you don't see it in the auth directly, the browse button, so then you can click on plus with auth, and below that you will see a credentials tab. Which tab? Credentials tab. So you need to click on that credentials tab and you will see the browse button there. But I don't see that credentials tab because in my auth itself, I can see the browse button. But if in your version of putty, if you click on auth and you don't see browse button, guys, okay, so please listen it carefully. If you click on auth and if you don't see the browse button, so then click on the plus in the auth and you will see a credentials button there. Click on credentials and you'll see the browse button. I'm seeing it by clicking on auth itself. That's why I'm not seeing it while clicking on plus in auth. Okay, the credentials button. So here in auth itself, I can see browse button. So I'll say browse it and give the PPK key file and then say open. That's it, guys. And then you will be opening. So say accept and you would be connecting to your public EC2 instance, guys. I will just change the settings here. And this you don't have to do. I'll just increase the font size so that it's visible to you nicely, right? So I'll just apply this. I hope this is clear. So this is my public EC2 instance. In fact, you can check it. So the IP 192.168.0.236. So that is the private IP of this EC2 instance, 192.168.0.236. So you are connected to your VM1, public VM1. So just see to it if your VM is running, and then otherwise try again and make sure that you are giving the things rightly. That is ec2-user at the rate public IP of your public EC2 instance, not the private IP, and then giving the PPK key file, not the PEM key file. So nothing would have happened till this point. If you would have directly created PPK key pair, then you would have not had to convert that PEM key to PPK key, and you would have been able to directly connect to this VM through putty. So you would have not used putty gen then. But then later on, there will be a problem. Later on, not with this, but when you try to connect to your private VM. At that time, I'll tell you, right? So now, what problem will be then? Yeah, so now you are connected to your private VM, correct? Oh, sorry, public VM. Is this syntax? Yeah, of course, it's the username at the rate public IP of your VM. That is the syntax. Yes, guys, so all good. Are you in your public VM? If you are, so just do sudo su. Maybe you can just come to super user. So give the super user privileges. So say sudo su and then try to go to google.com, guys. So say wget www.google.com. And guys, you should see a 200 OK message, response message. See, you are seeing a 200 OK response message. So I'm able to connect to google.com. Yeah. So why I'm able to do so, guys? Because the internet is allowed on this VM. So I'm able to go to internet from this VM. Is it clear or not? Because this is created in the public subnet. So this is my public VM. So your public VM is able to go to the internet with internet gateway through internet gateway. Yes or no? Is it clear to everyone, guys? Now what's remaining? So now connect to your private EC2 instance and see to it whether you are having the internet access through that or not. Yeah. So my question is that if you want to connect to your private VM from your laptop through PuTTY, will you be able to do so? No, we cannot, right? Why, guys? Why? Because on your private VM, you don't have a public IP address. See, if you go to your instances, if you go to that private VM, do you have a public IP assigned to it? No. Anyways, it is a part of your private subnet. You cannot connect to it through your what? You cannot connect through it through your laptop, right? Or the internet, right? So, because there is no public IP also assigned to it. So now, guys, but you want to connect to your private VM to test it out. So how can you do that? How can you connect to your private VM? Can you tell me? From public VM, you can. And guys, why from public VM it is allowed? From public VM, you can connect to your private VM. Why? Because your public VM and private VM, though they are in different subnets, but they are in the same VPC, and two different subnets of the same VPC are implicitly connected with each other through the what? Default route table. Yes or no, guys? Yes or no? So in fact, that will be tested that the VM from private subnet is connected to the VM of public subnet through default VPC. Correct? So yes. So now, yeah, yes, like neighbors in a village or like neighbors in your place. Okay. So now, what I will do is I will connect from my public VM to my private VM. But for that, guys, it would be a connectivity from home to home, from Linux to Linux or Linux to Windows or Windows to Linux, what it is. So it is then a connectivity from Linux public VM to Linux private VM. So you need what? A PEM key pair or a PPK key pair? So you will need a PEM key pair. And guys, if you remember, for your private VM also, you had given the same key pair. Correct? Correct. So, but tell me one good thing, that PEM key pair, fine. So now, I want to connect to my private VM from my public VM. Both are Linux VM. So I will need a PEM key pair. But tell me one good thing, guys, that PEM key pair is stored on your laptop. But is it stored? Is it available in your public VM? Is it available in your public VM? No, it is not there in your public VM. So just copy the contents of that PEM key pair in a file in your public VM and then try to connect to your private VM from that public VM with the help of that PEM key pair. Okay. So shall I go and do that then? Right. So what I will do is I will go to my public VM, which I was connected. Now the network has been timed out. It gets aborted every now and then. So I'll just duplicate this. So it would be reconnected. My public VM. And I will just say sudo su. And I'll just show you again. If you try to go to internet, www.google.com. So you get 200 OK message. It is connected to internet. Now let's create a file here and store the contents of that PEM key pair in that file. So I'll just do that. So I'll say nano. I'm creating a file. So I'll say nano. I can give any name to this file, guys. So let's say I give the name mykey.pem. So it's not necessary you should give the same name. You can give any name. So I'll say nano mykey.pem. And this will open this. Now here I will paste the contents of my PEM key pair. Is it clear? Yeah. So let's go to your downloads and get the contents of your PEM key pair, guys. So see, here are my downloads. And this is the PEM key pair. And just right click it, edit with Notepad++, and just copy the contents. Okay, tell me one good thing. By this time, you must have understood that why we downloaded the PEM key pair. Yes or no? We needed the PPK key pair to connect to my public VM, but why we got the PEM key pair? Is it clear to all of you by this time, guys? Yes, because we wanted to connect to private VM from my public VM. So for that, I needed this PEM key pair contents. Yes. So now just say Control A, Control C, copy this content and just paste it in your VM here. Right? So just paste it here. So say Control V. Okay. I'll just come here. I'll say Control V, or I'll just right click and it would be copied. Yeah. So I've just right clicked, it's copied. And then I will say what? Then I'll say Control X, Control plus X, and I will say Y to save it, and I'll enter. So copy the contents, paste it, and then say Control X, say Y to save and exit, and just come out of it. And then guys, what you need to do is, you need to change the permission of this file so that you can access it. So you'll say chmod and give 0600 and then key name mykey.pem. Okay. So this is good. Now try to connect to your private VM from this public VM with that key pair. Okay. So now do what? Do SSH to your private VM. So say SSH space EC2-user, that is EC2-user at the rate, the same one, at the rate. And now that is one way to connect. You can use that also. You can use this also. Okay. Yeah. So SSH EC2-user at the rate, and then private. Now see what you will give. You'll give the IP of your private VM. So which IP? Private IP or public IP? Tell me. Public IP you don't have. So you just have private IP. So you'll give the private IP of your private VM. And anyways, the subnets of the same VPC are connected with each other implicitly through the default route table through their private IPs. Right? So you'll give the private IP and you will come here. You'll paste it here. So SSH EC2-user at the rate private IP of my private VM space -I space your key name. That is mykey.pem. That's the name. Right? So this is what I'll give it. Right, guys? So this is what I'll give it here. Okay. What am I doing? Okay, I was trying to access it and then it's saying what? Warning, fine. It is asking, are you sure you want to continue connecting? So you'll say yes. So just say enter and say yes. And permission denied, it says. I'll just execute it again. SSH. Okay, I've given it 2 times, I think. Let me put it again. SSH. I just pasted it 2 times. EC2-user at the rate private IP of my VM. I'll copy it. I'll paste it here. And then what? Space -I space mykey.pem. And see, you are connected, right? So you're connected to a private VM 192.168.1.120. See, it is 192.168.1.120. Yes, guys. So from your public VM, you're connected to your private VM. You can check it out. This is your private VM, VM2, and this is the IP. So now you're connected to your private VM. So now what you'll do, guys, say sudo su, come to super user, try to go to internet. So say get www.google.com. Oh, sorry, the name was incorrect. There was a typo error, google.com. And guys, will you be able to go to Google? The answer is no. See, it is trying to connect, but then there is no 200 OK message, and that is not going to come because from your private VM, you cannot connect to internet. So my private VM doesn't have internet, and that's why it is not able to go to the internet. Correct. So public VM was. So this is all good. But then, so now see, the point is that guys, let's say if you have your database on your private EC2 instance, you don't have the internet. That is good from security aspect. But guys, you may want to install some updates for the database on the private EC2 instance in the private subnet. So how will you do that? You need internet, correct? But you don't want the internet directly from anywhere. So, but then you would be good if that internet can be given to you through the public subnet, correct? That is the public subnet EC2 instance or public subnet. If the internet can be given to your EC2 instance of the private subnet. Yes, guys. Then will it not solve the problem of installing the updates maybe on your databases, internet, right? So yes, can you not give the internet to your private subnet through public subnet? Yes or no? The answer is, guys, you can give it. And how you can give it? With the help of what? A NAT gateway or NAT instance, because that is then a secured way of getting the internet in my private subnet. So I can give it through a NAT gateway or a NAT instance, correct? So with that, I can just give it, correct, guys? Yeah. So that is something that can be given, right? So that is something that can be given. Okay, anyways, so this was just IGW, then it was connected to my subnet of the public subnet. It would be, that diagram was clear to you. Yeah, so this diagram, as you can see, so your public subnet is able to connect to the internet, okay, through IGW, Internet Gateway. But your private subnet is not able to connect to the internet. Now you can give the internet to your private subnet by something called as a NAT gateway or NAT instance. So you can create a NAT gateway or NAT instance, and then that NAT gateway or NAT instance, you can connect it to the internet gateway, and then it can go to the internet, correct? And then you can connect your private subnet to that NAT gateway or NAT instance, right? Okay. So now tell me one good thing. So if NAT gateway or NAT instance has to connect to internet through internet gateway, so that NAT gateway or NAT instance has to be a part of what? A public subnet or a private subnet? Tell me, guys. That has to be a part of public subnet or private subnet? Tell me. Public subnet, because your public subnet has connectivity to internet gateway, correct? So if your NAT gateway or NAT instance wants to go to internet, so it has to be a part of the public subnet. Then it will connect to the internet gateway and will go to the internet. So the easiest, now see, NAT gateway or NAT instance will work like jump servers. Okay, now what is the difference between NAT gateway or NAT instance, guys? That is, in theory, I will tell you, but lab is all set it up here. So I will just show you how you can do this with NAT gateway or NAT instance. Yeah, all good. Shall we go and do this lab? Then, I mean, in this lab only, we will create a NAT gateway. Yes or no, guys? Just like this. I've shown you in this diagram now. So let's do it. Let's create a NAT gateway. Anyways, this will not take much time. Okay, so go to NAT gateway. So what you will do is you will go to VPC itself, and there only you have NAT gateway. So guys, here, where is the NAT gateway? Where it is. Yeah, NAT gateways. So NAT gateway, you do it here and then say create NAT gateway. And then you will say what? My net, or you can give any name. So you can say my net gateway. And then the subnet type, you can select. So which subnet you want this net gateway to be in? Public subnet, of course. So you go with public subnet. Where it is, this is the one, right? Okay, and then connectivity type public, that is good. Now see, with a net gateway, an IP address will be assigned. That will be the what? The static IP address that is called as elastic IP in AWS, correct? And guys, the thumb rule is that you can allocate this elastic IP address by saying allocate, and it is allocated. But then guys, what Amazon tells you is, if you create an elastic IP address and if you don't use it, I will charge you for that. But if you create an elastic IP address and if you use it, then Amazon is not going to charge you for that. Okay. So if you create an elastic IP and you use it, then Amazon is not going to charge you for that. But if you don't use it, Amazon is going to charge you for that. Okay. And that is the thumb rule, because it has reserved that IP for you. So if you use it, you will not be charged. If you don't use it, still you have it with you, so you will be charged. So then let's say create net gateway. Okay. Create net gateway, and it is created, right? So was created successfully. So now what you need to do is, what change you need now, guys? So you have created the net gateway. Okay. So it's like you have the net gateway in place in your what? In your public subnet. Now, what is the next thing you need to do? You've created the net gateway in the public subnet. Okay. So now what? So now what you need to do is, so you need, so net gateway you have created, correct? And then see, net gateway is created and it is a part of your public subnet. So of course it is connected to your internet gateway, because the public subnet is connected to the internet gateway and going to internet. So your net gateway is able to go to the internet. Yes or no? So your net gateway is able to go to the internet, guys. But what you want your private subnet to go to the internet through the public subnet through this net gateway. So you will create a route in which you will say that private subnet should go to internet through this net gateway. And tell me one good thing, where you will create that route, wherein you will say to go to internet through net gateway. Where you will create that route, guys? In which route table? In the route table. So in which route table? Custom route table or the default route table? Custom route table or the default route table? Everybody is saying custom route table. But guys, tell me one good thing. If you will add that route in the custom route table, so tell me one good thing, your private subnet, does that has connectivity to your custom route table? Is your private subnet a part of the custom route table? No. So see, there are two options. Either you can create a different route table and let your private subnet be a part of that different route table, another custom route table. And from that route table, you go to internet with the help of the net gateway, right? Or the second option is you can just use the default route table, because your private subnet is a part of the default route table, and then create a route from your default route table to go to internet with the help of net gateway. Okay. So is it clear or not? So I'll just go to default route table and I'll add a route wherein I'll say go to internet through the net gateway. Your private subnet, is it a part of your custom route table? Is it a part of your custom route table, your private subnet? Is your custom route table attached to your private subnet? Custom route table, it is not attached to your private subnet. See, custom route table, I'll show it to you. See, custom route table that we created, we just attached our public subnet to that, right? Custom is only attached to your public, right? So if you go to route tables, if you go to that custom route table of your my VPC, see, which is where there is no in the main, that is the custom route table. And if you go inside that custom route table, if you go to subnet associations, see, public subnet is associated with your custom route table, not the private subnet. That custom route table was associated with your public subnet. And that's why my VM from public subnet was able to go to internet through internet gateway, because then the custom route table was attached to internet gateway. But now the point is, I want the internet on my private subnet through my public subnet. So I created a NAT gateway in my public subnet. So that NAT gateway is in public subnet. So is associated with your internet gateway and is associated with the internet, correct? Is getting the internet. But now you want your private subnet to get that internet through NAT gateway. And your private subnet is not a part of custom route table. Okay. So tell me one good thing. You will have to add a route in a route table to go to internet through NAT gateway. So in which table you will add that route? In a route table where your private subnet is associated. So which route table your private subnet is associated with? Default. So from your default route table, you will create a route to go to internet through NAT gateway. I hope this is clear now. So go to route tables, go to your, you're welcome. So go to your my VPCs default route table. This is the one. Okay. And then go to what? Go to routes and go to edit routes and add a route. Destination should be your internet 0.0.0.0/0 through what? Through your NAT gateway. See NAT gateway you say, and you see that NAT gateway that you have created. So go to internet through NAT gateway. That's it, guys. Save the changes and you are good. And now you go to your private VM and see the internet was unreachable before, right? It was not reachable. But now you again test it out and see it's reachable. Immediately it's reachable. Can you see this 200 okay from your private VM? It was unreachable, guys, and then it came reachable immediately. I mean, in fact, if you want to test it out, so if you delete this NAT gateway now, you will again not be able to go to internet. So if you go to NAT gateway and let's say if you go to actions and delete the NAT gateway, you say delete, yeah, and you delete this NAT gateway. And now if you try again, you'll not be able to go to internet. See, it's again hanged up, trying to connect, but unable to connect, right? And you delete, why it got disconnected? Because you deleted the NAT gateway and your VM is not able to go to the internet. So just quickly, I'll show you with NAT instance now. Right, so go to instances and then what you do is, so see that is NAT instance. So NAT instance, again, you will, that is the instance, so you'll create it in EC2, correct? And now guys, tell me one good thing. So that NAT instance, again, that has to be created where? In the public subnet or private subnet? Public subnet or private subnet? Public subnet. Public subnet, Sharmila, why? Because that has to connect to internet gateway. And through public subnet, it can and go to internet, correct? So again, so you will say launch instance and it would be like, it would be a what? NAT instance, correct? And see, I've deleted the NAT gateway, so I'm not able to go to internet now, correct? So now just say my NAT ins. So it's an instance. So I'll just give it a name as my NAT instance. So I'll say my NAT ins. And then what I'll do is in the AMI, I'll select the NAT AMI, right? Not this Linux Mac. So I'll just go with what? I'll just go with the browse more AMIs. I'll go with browse more AMIs and just search for NAT here. So guys, you can go to community AMIs and search for NAT AMI, but don't go to marketplace because you'll be heavily charged for that. Otherwise, if you take from there. So go to community AMIs and just search for NAT and you will get multiple NAT instances types. So you can just select one of them, the first one maybe, and you will see, find it there that it would be written out there that it is what? A NAT instance, correct? That you will find it there. So see, this is not the one I think, but yes, this is the one. Amazon AMI VPC NAT, right? So I can just go with this NAT one. Okay. Even this is the one also, AMI VPC NAT here also. So you can go with this also. So let's select the first one, NAT. So this is the NAT instance. So now in NAT instance, you can go with Linux or Windows. That is not an option given to you. So just select NAT and you select this and this NAT instance comes to you, correct? And yeah, that's it. And then the same thing, you just go with T2 micro. Okay. And then key pair, you can just select the same key pair also. That should not be a problem. Network, guys, edit it. And what? Go with what? Go with the my VPC. Go with my VPC and the what? And what? Private subnet or public subnet? Public subnet, correct? Public subnet, because you want your net instance to be in the public subnet, like your net gateway, to for it to connect to internet gateway and then to the internet, right? And then what next? So security group, you can have any SSH plus HTTP here. For your net instance to have the internet capability, allow HTTP as well, correct? Okay, so my net instance, net AMI you have taken, instance type T2 micro, key pair you have given the same key pair. VPC, you went with the my VPC, subnet as public subnet, then auto assign public IP enabled. Okay, was there. In security groups, you have just allow SSH and HTTP from anywhere. That's it. And then you create this net instance, you launch it. Now tell me one good thing. So you have created your net instance in the public subnet. But again, the same thing comes in that the EC2 from the EC2 instance from the private subnet, or your private subnet wants to go to internet through this net instance. So now you will modify the route in which route table for your private subnet to go to internet through net instance. Custom route table or the default route table? Tell me. When I say custom route table or default route table, just think that your private subnet is a part of, so which subnet is a part of, you will modify that route table. So which route table? The default route table, just like net gateway. Or you can create a new route table, correct? Or you can create a new route table, associate your private subnet to that, and then create a route from there to internet through that route table. But I'll go with default route table because my private subnet is a part of default route table. And then I want my private subnet to go to internet. So I'll modify default route table to go to internet through net instance, right? Yeah, correct. That is correct, Abhinav. But I'll tell you the difference later, right? So let's do that, guys. So let's go to VPC because the route table will be available there. And I'll go to default route table. This is my VPC. This is the default route table of my VPC. And I'll say edit routes. And see, there is one route to net gateway that I had added. And what is the status right now? It's a black hole. Why, guys? Can you tell me? Because that net gateway is no longer there. Do you remember that net gateway we deleted? Yes or no, right? So no reference. That's why a black hole there. So I'll just remove this and I'll add another route. I'll go to internet again. So final destination is internet only, whether it is with net gateway or net instance, you ultimately have to go to internet only, right? So final destination is internet, but now the target type is net instance instead of net gateway. So net, where is that instance? Yeah, instance you select and you will see that public VM1, VM2 and net instance. So go with net instance, right? Net instance and just save the changes. That's it, guys. And now you try to go to internet. Okay, it's still trying to connect. It's taking some time. Okay, there is one thing that I forgot to do it here. And that's why it is not able to go to internet, right? What is that thing, guys? That when I created that net instance, so just go to your net instance. Just go to your net instance, guys, and just disable the source and destination check there. So go to actions. I'll tell you why, but go to there in these actions in network settings, I think. No, not in network settings, but in networking, not in instance settings, but in networking on my net instance, and say change source destination check and just stop this. Just stop the source and destination check. Okay, why I'll tell you, but right now just stop the source destination checking for this net instance, and then now you will try it out. Okay. So it has been hanged up kind of, I'll say Control X maybe. So now it will work, but it's taking some time. In some time it will work. Control C. Yeah. So now try to go to internet again and see you are able to go to internet. Yeah. So previously you was not able to, but now you are able to. And see, I'm done here, right? But just to put it here for you, that why we deleted the source and destination check, guys. So in a VPC, any instance can act either as the source or destination, but not both, right? So an instance can act either as source or destination. Okay, not both. It cannot do both. But in case if you want an instance to do both the functionalities, that is, if you want that to act as source and destination both, then you can disable source and destination check for that instance. In case of NAT instance, guys, we have to disable source and destination check so that internet could be allowed in the private subnet instances, right? So because this NAT instance will act as source as well as destination, right? So this will act as a source as well as the destination, right? So because it wants to get the internet also, correct? And it wants to give it to your EC2 instance also, the internet, correct? So in the private subnet, right? So it will act as source and destination both, correct? So because it wants to get the internet also through internet gateway, correct? And then it wants to give it to your private subnet also. It wants to give it to your private subnet EC2 instance also, right? So I just disabled the source and destination check. So I selected my NAT instance, went to actions, networking, and then I said what? Change source destination check. I just stopped the source destination checking because NAT instance acts as both the source as well as the destination.
Just a quick info, guys. Intellipaat offers advanced certification in DevOps and cloud computing in collaboration with IIT Pravartak, a technology innovation hub of IIT Madras. This online advanced certification in DevOps and cloud computing by IIT Pravartak will help you gain expertise in DevOps, access management, DevSecOps, Terraform, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel. The link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take your first step towards career growth in the field of cloud and DevOps.
In case of NAT gateways, we don't need to do the above step. That is, we don't need to enable the source and destination check. Disable the source and destination check because that is not required with NAT gateways, because in NAT gateways it is like PaaS component, okay, platform as a service component. So we don't need to disable the source and destination checks there. So yeah, you just need to modify the route table in case of NAT gateways. Okay, and then the differentiation between NAT gateway and NAT instance. So guys, NAT instance, it's an IaaS, that is infrastructure as a service component. So it will need more management, more maintenance from your side since it's an IaaS based entity. Correct. So you'll have to manage it. And anyways, you create it as an instance, that is an EC2 instance. So NAT instance is nothing but your EC2 instance. So since it's IaaS, so you have to take care of the management and maintenance of that instance. Okay. And for high availability, you need to create multiple NAT instances in multiple availability zones. Okay. So for high availability, you need to create multiple NAT instance in multiple availability zones. Of course, then only you will get high availability for your NAT instance if you can create multiple of those in multiple different availability zones. And bandwidth is all dependent on the size of EC2 instance you use in it for the NAT instance. So of course, see, NAT instance, since it's an EC2 instance, so it has its own vCPU capacity and the RAM capacity. Like when I was going with T2 Micro, so I was getting 1 vCPU and 1 GB of RAM capacity. So then if you want more bandwidth for your NAT instance, so of course you should go for a bigger size of EC2 instance then. Okay, so bandwidth is all dependent on the size of EC2 instance you choose for your NAT instance. And so that's there. So in this case, we use security group and we allow only specific kind of traffic. And then when I created the NAT instance, so I did what? I allowed, I created a security group wherein I allowed specific kind of traffic only. Like if it was an Linux EC2 instance. So this type of EC2 and the amount of traffic will decide your cost of the NAT instance. So the cost of the NAT instance is decided by the type of EC2 instance that you create, that is whether T2 micro or any other, that will decide the size of your NAT instance. And of course, that will add to the cost of your NAT instance, and the amount of the traffic that is going or that is flowing through your NAT instance will decide the cost of your NAT instance. Size of EC2 means it's like whether you are going with T2 micro, T2 nano, which size of EC2 instance, correct? So there are different families when you create your EC2 instance, whether it is a NAT instance or normal EC2 instance. So basically, there are different family of processors that you can choose from. Like you can go with T family, M family, and so on. In T family, again, you have different flavors like T2 micro, T2 nano, T1 nano, and so on. And every different size, every different option is giving you different size of vCPU capacity and RAM capacity. Like T2 micro gives you 1 vCPU and 1 GIB of RAM capacity, correct? So that is what it is. In fact, I'd shown you in the portal. So if you go to EC2, if you go to instances, yeah, so size of EC2 means G Praveen was saying. So this was it. Correct. So I just shown you the size of EC2 instance. So see instance type T2 micro, T2 nano, T2 micro giving you 1 vCPU and 1 GIB of memory capacity. And then you have T2 nano, which gives you 1 vCPU, 0.5 GB of RAM capacity, and so on, right? So that is what is the size of EC2 means. Okay. So the type of EC2 instance that you select, whether it is T2 micro, T2 nano, and so on, and the amount of traffic, that will decide the cost of your NAT instance. Okay. Then NAT gateway, guys. So NAT gateway, it's a PaaS component, platform as a service component, and it's all managed and maintained by Amazon for us. Okay, so Amazon will manage and maintain it for you. Yeah, 5G is connected. Okay. So yeah, so it's a so NAT gateway is it's a PaaS component, platform as a service component, and it's all managed and maintained by Amazon for us. Okay, so it's all managed and maintained by Amazon for us, correct? Because it's a PaaS component, platform as a service component. And since it's all going to be managed by Amazon, we don't need to worry about the high availability, because that would be taken care of by the provider, the Amazon. And the bandwidth is also fixed here. It is 10 Gbps. There in NAT instance, you can vary the bandwidth. It can vary depending on the size of your EC2 instance, and you can increase and decrease it. But in case of NAT gateway, it is fixed. It is 10 Gbps. And we don't have an option of using any security groups with a NAT gateway, which is possible with NAT instance. So this means restricting the specific traffic cannot be done using security groups in case of NAT gateway. And therefore, the cost of NAT gateway is equal to the amount of traffic transfer happening through the NAT gateway. Okay, it has nothing to do with the size of the NAT gateway, because it is always fixed. It's 10 Gbps, the bandwidth is. So the costing is dependent on the amount of data transfer happening through the NAT gateway. And we would always prefer going with NAT gateways over NAT instance, guys, because of course, we don't have to manage here the things. It's a PaaS component, platform as a service component. This use case where we will be using. So NAT gateway, you would be using more often than not in comparison with your NAT instance. Why? Because NAT gateway is a platform as a service component, right, Niharika? And at the same time, see, when something is offered to you in a PaaS-based manner, you don't have to manage it, and you can concentrate on your core business. Let's say if you are running a financial organization, so you can actually concentrate on your core business of managing the finances, and you don't have to manage the infrastructure, because that is going to be managed by the provider for you. correct? So if you go with the PaaS component, so that's why it is PaaS components are widely used in the business use cases, correct? Because you don't have to manage the infrastructure in that case. You can just manage your core business and let the infrastructure be managed by the provider. Okay. But yes, now if you want more control of your infrastructure and you want to increase or decrease the size of your NAT instance, like you want to increase or decrease the bandwidth, so of course, and you want more control of that, so then you can go with a NAT instance, correct? But otherwise NAT gateway is the preferred option. So guys, this was about NAT gateway and NAT instance. So see, I had told you about this thing. Private public subnets, this is also good. So see, here also I've written it. When creating a NAT instance, we disable the source destination check on the instance. And NAT instance must be in a public subnet. We all saw that, correct? So we created our NAT instance in a public subnet only because we wanted the internet on a NAT instance. And that was available in the public subnet with the internet gateway, through the internet gateway. So that's why we created the NAT instance in public subnet only. And then through that, we provided the internet through our private subnet. So NAT instance must be in a public subnet, and there must be a route out to the private subnet to the NAT instance in order for this to work. That's what we saw. Then the amount of traffic that NAT instances supports depends on the instance size. If you are bottlenecking, increase the instance size, correct? So depending on your instance size, you will get the bandwidth for your NAT instance. And if you are bottlenecking, if you want more bandwidth, then you increase the size of the instance, NAT instance. Go from T2 micro to maybe any large size, T2 large, or any other size that is larger than T2 micro. So you can create high availability using auto scaling groups also in your NAT instance by creating NAT instances, multiple of them in different availability zones. So you can create high availability using auto scaling groups, multiple subnets in different availability zones, and a script to automate the failover as well behind a security group. Then NAT gateway, I told you, it's not very new now. Previously it was. So now it can be in the exams also. And it is preferred by the enterprise. As I said, enterprise normally prefer NAT gateway over NAT instance because they don't have to worry about the infrastructure then. And scale automatically up to 10 Gbps. It can. There's no need to patch it because it's a PaaS component, not associated with security groups. Automatically assigned to a public IP address, that is elastic IP you assign to it, static IP address. And you remember one thing about elastic IP address, that if you create an elastic IP and you use it, Amazon will not charge you for that. But if you create an elastic IP address and you're not using it, then Amazon is going to charge you for that. And remember to update your route tables, okay, with NAT gateway. Okay, so that's there. So no need to disable source destination checks here. But of course, route table needs to be updated. Like in the default route table, we had allowed what? The internet through NAT gateway, correct? Because our private subnet was a part of default route table. Now I'll come to NACL. I won't say there will be security issues. Why? Because it's not that it is not being managed. It is, I mean, it is not like if you are not managing the security groups, then nobody else is doing that. It is being managed, but it is managed by the provider, not by you. So there will not be security issues, of course, Aryan. Yeah, so see, source and destination check means what? Now this NAT instance, it is not just having one job. Ideally, any instance can act as either source or a destination. That is, it can either act as a source or destination, but here the NAT instance is acting as both. It is acting as a source as well as the destination, correct? So NAT instance is acting as a source as well as destination because it is getting the internet from where? From where? It is getting the internet from internet gateway, correct? And then it has to give that internet to the private subnets EC2 instance. Okay, so see, it is acting like, see, it is getting the request to go to the internet from your private subnets EC2 instance, correct? And then through the internet gateway, it is getting the internet, and then it has to give it to your EC2 instance again, right? So it has to, so EC2 instance will connect with the NAT instance for getting the internet, correct? And NAT instance, when getting the internet from internet gateway, again will give it to your EC2 instance, correct? So it is acting as source as well as destination both. But for your private EC2 instance, not the public EC2 instance, because the public EC2 instance is anyways getting the internet directly through internet gateway, correct? But then this NAT instance is acting as source and destination both, because the private EC2 instance is giving its request for the internet. So when I am logging into my private EC2 instance and I am saying wget www.google.com. So when I'm raising a request to go to google.com to go to internet, so first that request is going into where into my NAT instance, and then from there it goes through the internet gateway and then to the internet, and then the NAT internet is coming to my EC2 instance through that internet gateway, through the NAT instance, and to my private EC2 instance, correct? So this NAT instance is accepting the request from your private EC2 instance, and then it is giving the reply also to your private EC2 instance. So it is acting as source and destination both, correct? This is one more service, AWS Launch Transit Gateway. What is it? There is one more service, AWS Launch Transit Gateway. Transit Gateway can help you to connect your two networks. Now those two networks so like you can connect your two networks in AWS using VPC Peering. You can also connect them using Transit Gateway, right? So to connect your two VPCs, two networks in AWS, you can make use of Transit Gateway. That's what I'll tell you as of now, Pichendra, right? So then let's get ahead and let's talk about NACLs and security groups. So NACL and security groups, guys. So what does it mean? So see, NACL, Network Access Control List. Okay, it is nothing but stateless in nature. So stateless means what? Stateless means you have to specially allow inbound and outbound traffic both to allow a particular type of connection. Okay, so when you create your NACL, so no inbound, no outbound traffic is allowed by default, guys. It is stateless in nature. So that means you have to specially allow inbound and outbound traffic both to allow a particular type of connection. By default, it is not allowed. Any traffic is neither allowed to come in, neither allowed to go out by default in your custom NACL, guys. And that's why it is stateless in nature and can only be associated to subnets. So you can associate NACL only to your subnets and not to your EC2 instances. And this is where it specifically differentiates it from the security groups, right? Because the NACL, you can only associate it with your subnets and not to your EC2 instances directly. Whereas the security groups, you can associate it with your subnets as well as your instances, correct? That are the instances in the subnets. So security groups are all stateful, which means you only need to allow inbound rules as outbound rules are allowed by default. So whenever you create a security group, guys, so all the traffic is allowed to go out by default, but no traffic is allowed to come inside by default. Whereas with NACL, no traffic is allowed to go out, no traffic is allowed to come in by default for your custom NACL. With custom security group, all traffic is allowed to go out, but no traffic is allowed to come inside. And that's why security groups are stateful in nature. And it can be associated to subnets as well as the instances. So security groups can be associated to your subnets, can be associated to your EC2 instances as well directly. Whereas that is not the case with NACL. So NACLs can only be associated with your subnets and not the EC2 instances. And then another thing, now see, default NACL by default allows all inbound and outbound traffic. So now you will say I'm contradicting the things, isn't it? It's like just some minutes before, like just now I told you that in NACL, no traffic is allowed to come in and no traffic is allowed to go outside, correct? In case of NACL. And that's why it is stateless. But then I'm saying default NACL by default allows all inbound and outbound traffic. So guys, that rule that I told you that all traffic, no traffic is allowed to come inside and no traffic is allowed to go outside of an NACL is for what? Is for the custom NACL. That rule applies for your custom NACL that you create. But by default, when you create your VPC, one default NACL gets created, and in that default NACL, all traffic is allowed to go out and come inside. So default NACL by default allows all inbound and outbound traffic. So default NACL gets automatically created when you create your VPC that I shown you. Okay. And in that, all traffic is allowed to go out and all traffic is allowed to come inside. So all inbound and outbound traffic is allowed. Okay. Whereas your custom NACL, so if you create your custom NACL, then what will happen is it would block all inbound and outbound traffic by default. No traffic will be allowed to come inside. No traffic will be allowed to go outside of your custom NACL by default. Okay. Fine. So this I already told you. NACL is stateless. Stateless means when you have to specifically allow all inbound and outbound traffic, both to a particular type of connection. Okay, can only be associated with subnet security group. So this is what is repetitive statements. Okay, so they should not be pasted again. This already told to you. Fine. So that is what is NACL and security groups for you guys. So see, network NACL, network ACL, network access control list. So your VPC automatically comes with a default network NACL, default network ACL, guys, as I told you. So your VPC automatically comes up with a default network ACL. And by default, it allows all outbound and inbound traffic. So when I created my VPC, a default network NACL was created and it allows all inbound and outbound traffic by default. And you can create a custom network ACL also. And by default, each custom network ACL denies all outbound and inbound traffic until you add the rules to allow some traffic. Okay, I hope this makes sense. Then each subnet in your VPC must be associated with the network ACL. If you don't explicitly associate a subnet with a network ACL, the subnet is automatically associated with the default network ACL. Okay, so each subnet in your VPC must be associated with a network ACL, guys. Okay, so whichever subnets you create in your VPC, that should be associated with a network ACL, NACL. And like till this point, we have not associated any subnets to NACL. Have we associated any subnets to any NACL, guys? Have we done that till this point? No, of course not. Correct. So, but still, if you don't explicitly associate a subnet with a network ACL, still it is associated, still it is automatically associated with the default NACL. So we didn't associated our subnets with any NACL, but they were by default associated with the default network NACL, network ACL, which was created by default when we created a VPC. Correct. So that is there. And you can associate a network ACL with multiple subnets. Now, one network ACL, you can associate it with multiple subnets. Okay. So one NACL, You can associate it with, let's say, all the subnets of your VPC. Let's say you have a VPC with 5 subnets. So one NACL can be associated with all the 5 subnets of your VPC. So if you have created a VPC with 5 subnets and if you have not created any custom NACL, so all those 5 subnets will be a part of the default NACL. Correct. So you can associate a network ACL, NACL with multiple subnets. However, a subnet can be associated with only one network ACL at a time. Okay. So if I have associated my subnet 1 with my default network ACL, then I cannot associate that subnet with any other NACL. If I associate that subnet with another custom NACL, so it will be removed from my default NACL. Correct. So one subnet can only be associated with one NACL. So when you associate a network NACL with a subnet, the previous association is removed. So let's say if your subnet is associated with a default network ACL, and now you have created a custom NACL, and you associate your subnet with custom NACL, and you don't remove it from the default NACL, so then also by default, its association will be removed from the default NACL. So it's like one subnet can only be associated with one NACL and not more than one. So NACL is one to many. One NACL can associate to multiple subnets, but subnet is one to one. That is, one subnet can only be associated with one NACL. Correct, Manish Pandey? Yeah. Okay, so that is there. And this point is going to be very important because I'm going to ask you this thing while I'll be doing the lab, right? So do remember this and you will have the answer to my question at that time. So a network ACL, contains a numbered list of rules that is evaluated in order starting with the lowest numbered rules. So it has a number of rules that are starting from 100, lower the number, higher the priority. Okay. And a network ACL has separate inbound and outbound rules also, like your security group. And each rule can either allow or deny the traffic. So network ACLs are stateless. Responses to allowed inbound traffic are subject to the rules for outbound traffic and vice versa, right? So that is how it goes. Because in your custom NACL, no traffic is allowed to come in or go out. So then you can allow some traffic to come in and then you can allow some traffic to go out by creating the rules. Okay, so that is what is network ACL for you. And you normally block IP addresses using network ACLs, not the security groups. Right, guys. So this was about the NACL. So if you are all good till this point, guys, then shall we go and do a lab on NACL? Yes or no? This anyways was discussed. Yeah, anyways, we will. So NACL normally, see, you allow it on the subnets, correct? So which traffic is allowed to get inside or go outside of your subnets. And then security group, normally you allow it on the instance level. But security groups, you can allow the traffic through your security group on subnet level also, and even on your instance level also. But with NACL, you can only allow or restrict the traffic on subnet level itself, not on the instance level. So both are, you can consider both as a firewall mechanism to allow or deny some traffic, wherein the NACL has the capability to only operate on the subnet level and not on the VM level or the instance level, whereas the security groups, you can enable it on subnet as well as the instance level. Correct. And by default, all the traffic is allowed to go out from your security groups, whether you are creating a custom security group or the default security group, whereas in NACL, no traffic is allowed to go out or come inside. By default, with your custom NACL, with default NACL, all traffic is allowed to go out and come inside. Correct? So yeah, so that's there. Yeah, so if you connect one subnet with custom NACL, but if you don't connect the other 4 subnets with any NACL, then they are by default connected to your default NACL. In a normal working environments which is recommended, NACL or security group, see, both are having their own purposes. So normally on the subnet levels, you can allow the NACLs correct? And on the instance level, you normally work with security groups. Correct. Yeah. So NACL takes precedence in case of conflicts with security groups. Uh, if you will talk about like security group on the instance level and NACL on the subnet level, then yes, it takes precedence, because it's like if you are allowing or disallowing some traffic on the subnet level. So let's say if you don't allow some traffic on the subnet level, then do you really need to disallow that traffic on the instance level? You don't need it, because it's like if somebody is not allowed to get inside your house, that is your subnet, then he of course will not be able to get inside the rooms in your house, correct? That is the instances also. So if you block some traffic with NACL on the subnet level, so then you don't need to block it on the instance level explicitly using maybe the security groups, correct? So yeah, that is how it is. Default NACL means within public network, vice versa. So it is not with public network, it is with any VPC that you create. The default NACL gets created by default, right? So we can do this lab wherein we can quickly create a VPC with a subnet, and maybe we can create one instance in it. And then we will allow the internet on this subnet of the VPC by creating an internet gateway on this VPC and attaching it to my VPC, and then creating what? A route in my default route table itself. I can create a route to go to internet through internet gateway, correct? And then I will create an NACL in that. So is it clear? And I'll show you the things with NACL then. And then I'll show you this one for NACL. First, let's go with this. 1 second, this was discussed already. I'm just going through my diagrams if I have to show you anything else. No, this was also discussed anyways. Not required, this one. Subnet. This was also discussed. NAT gateway was also discussed. Yeah, this I will discuss it out. This was done. This was, yeah, this was also done for NET, correct? Okay, so this is the one. So let's go and do this thing then. Okay, so let's log in into the portal. I'm already logged in, and I'll go by this diagram basically. So what I will be doing in here is what I'll be doing is I'll be creating a VPC with a subnet initially. So let's do it first, guys. So let's create a VPC with a subnet. You can do it along with me, guys. That will give you a good feel of the things. So just go to VPC. Yeah, so diagram. Okay. So see, what I'll be doing is we'll be creating a VPC, a subnet. Okay. And then we will be providing. So since we'll be creating our custom VPC with a custom subnet. So tell me one good thing.
Let's have a quick quiz question, guys. And the question is, which AWS service provides a fully managed, highly scalable, and serverless data warehouse for analytics? And your options are Amazon RDS, Amazon Redshift, Amazon DynamoDB, or Amazon Elasticsearch Service. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers advanced certification in DevOps and cloud computing in collaboration with IIT Pravartak, a technology innovation hub of IIT Madras. This online advanced certification in DevOps and cloud computing by IIT Pravartak will help you gain expertise in DevOps, access management, DevSecOps, Terraform, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel. The link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take your first step towards career growth in the field of cloud and DevOps.
Will it be having the internet by default allowed onto that subnet? Will we be having the internet by default onto this subnet one then? Since this will be my custom VPC? No. So what I'll be doing is I'll be creating an internet gateway, and then I will be attaching it to my VPC. And then there'll be a default route table, of course, which will be created for my VPC. So what I'll be doing is I'll be creating a route in the default route table, wherein I'll say go to internet through internet gateway. And that is how I will bring in internet into my subnet 1. And then I will create a VM1. I will install the IIS functionality on that VM1. I'll make it work as a web server. Okay. Or maybe I will create a Linux VM or Windows VM, whatever. And then having the IIS function, a web server functionality on that VM1, I will show you that it will be able to go to internet, correct? So, I mean, and there'll be internet on VM1. Okay, correct. And then what I'll do is I will create a custom NACL. So by default, it would be associated with the default NACL. And then I'll create custom NACL, and I'll show you some good things with custom NACL, what I have told you. Okay, so let's go and do this till this point, and then we will see with NACL what happens. So let's first create the VPC and subnet, and then move ahead. So I'm in my VPC, create VPC, and I'll give my VPC name. So I'll say my VPC1. Okay. My VPC1, and then the CIDR block. So I'll just give the CIDR block here. I'll say 192.168.0.0/16. So any CIDR block I can give. 192.168.0.0/16. That's it. And I'll say create VPC. So I'm giving this CIDR block 192.168.0.0/16. And I'll say create VPC. So that is created. Now let's create the subnet in this VPC. So I'll create one of the subnets. So I'll say subnets here, and I'll go and create a subnet. I'll select my VPC. So this is my VPC1. And then I'll give the subnet name, let's say SN1, subnet 1. Then availability zone is no preference. Okay, or I can give some preference. If you are in Mumbai region, do give the preference as AP South 1A or 1B. Don't go for 1C, because otherwise you will not get T2 micro instance out there. But I am in North Virginia, so I can go with no preference. That's it. And so this is my subnet 1. Okay. And I'll just, okay, but I have to provide the CIDR block. So it should be inside of my VPC. So my VPC CIDR block is 192.168.0.0/16. So subnet CIDR block is 192.168.0.0/24. And let's create this subnet. But tomorrow, if you would like to create another subnet in this VPC, you will not be able to do so, because all the address space 65536 IPs of your VPC you have given to your subnet 1 only then. So you'll not be able to create any other subnet then inside this VPC. But since you want just one subnet here, so you can give /16 for your subnet as well. Fine. But ideally, that is not how you do it, because you don't want only one subnet in your VPC normally in your real use cases. Okay, so one subnet with one VPC is what I have created. See, you can use 24 for VPC, but you cannot use 32 for subnet, because how can you use 32 for subnet? Because with 32, how many IPs you are going to get? No IPs, isn't it? So you cannot go beyond 29. This is what I have taken for my VPC. 192.168.0.0/16 for the VPC, and for the subnet 1, it is like 192.168.0.0/24, right? You can give 192.168.0.0/22 for your VPC also, and for your subnet also you can give same if you want. But then you will not be able to create more than one subnets in that VPC, with if you use the same subnet mask for your VPC and for your subnet. If you are, I'll tell you, just let me go to this paint and I'll tell you. So it's like what you are trying to say me is if this is my VPC with the CIDR block as 192.168.0.0/16, right? Okay. Then inside this VPC, if I am having two subnets, so these two subnets have to be like having the CIDR block that should be inside of my VPC CIDR block. So if my subnet 1 is having 192.168.0.0/24, then this is acceptable. But then if you're saying my subnet 1 will have a CIDR block as 10.0.0.0/24, then this is not possible. Okay. And if you, so this is not possible. And if you're saying that my subnet 1 will have like two CIDR blocks as 192.168.0.0/24 and 192.168.1.0/24. So again, you will not be able to do this. You will not have two CIDR blocks in your same subnet. And then, so you'll be having one CIDR block and that should be inside of your VPC CIDR block. And you cannot have a CIDR block that doesn't belongs to your VPC CIDR block. So this is not correct. Okay, so this is not correct. Right. And even out of these two, you can have one CIDR block. Yes. So see, you can add this. You can always add this. So previously they didn't had the option to do this, but now they are having this option that you can always add it. Okay. But then why you would need it? So tomorrow, let's say if you exhaust on your first CIDR range, then you can use the another CIDR range. So if you have not prepared for the future and if you have exhausted with your one CIDR range, then you can use the another CIDR range. So this is an arrangement that they have got in now. So this is possible with to add in even with your VPC and VNet also in Azure in network. So this is possible now, but previously it doesn't used to be like that. IGW, correct? So let's create an internet gateway. So go to internet gateways and create an IGW. Okay, so let's create an IGW. So I'll just give it a name. I'll name it as my IGW 1. And then you can create this internet gateway. And then see this is detached, right? Okay, and so I'll connect it to my VPC. So I'll go to actions and I'll say attach it to my VPC, and we will attach it to our VPC that we created. Okay, so this is done. So we have created an internet gateway and then we have attached it to our VPC. Now, what should be my next step, guys? Can you tell me? See, when I created my VPC with the subnet, three things got created automatically: a default route table, an NACL, and a security group. So one default route table has been created, correct? So I will edit the routes of my default route table and I will add a route to go to internet through the internet gateway, correct? So that's what I will do next thing. Okay, so what I'll do is I will go to internet gateway. I'll go to route tables and I'll go to the default route table of my VPC. And what I'll do is I'll say edit the routes and I'll add a route. I'll say destination as internet 0.0.0.0/0. Target is what? My internet gateway. Through internet gateway, I want to go. So destination is internet through internet gateway, and I'll say save changes. That's it. This is also done. So now the internet is available on my on my VPC and my subnet. Just one thing is remaining. Go to your subnets and auto assign public IPv4 settings. Just enable that. Select your subnet Fine, I'll be slow. So go to route tables and then go to your custom route table. I mean, the default route table of your custom VPC. This is my VPC one. This is the route table for that. Go inside that and then go into routes, where the routes, and then say edit routes, And then you do what? You say add a route. You say add a route. Destination where you want to go is internet. So just select 0.0.0.0/0, that is internet. And then through whom you want to go. So target, you can just specify as your internet gateway. Correct? And then select your internet gateway then. Correct? 0.0.0.0/0, and then the target is internet gateway. Say save changes. That's it. Is it clear? Why 0.0.0.0/0? Because that points out to anywhere, like, right? So internet also, right? So that is like go to anywhere, go to internet with that. Is that clear, guys? How you add the route in default route table to go to internet through internet gateway. So this is good. So see, now the point is that I have created a VPC with one subnet, and then I have created an internet gateway, attached it to my VPC. Then the default route table that is attached to the subnet of my VPC, Prem Kaur saying no, can you repeat once more? I'm saying, okay, fine. Route tables, correct? So go to route tables, pay attention, and go to my VPC1 route table. Go inside that. Go to routes. Say edit routes. Say add a route. Destination is internet anywhere. So go to 0.0.0.0/0. Target through whom you want to go to internet, through internet gateway. So you'll select internet gateway, and you will see your internet gateway that you have created and attached with your VPC. Select that and say save changes. Now got it? And it's saying, what about Aryan and Prem Kaur? Is that clear to you now? So then you just need to save the changes. So what we have done till this point is we have created a VPC with a subnet. Then we have created internet gateway. We have attached it to our VPC. Then we went to the default route table of our VPC of the subnet. In that route table, we added a route to go to internet through internet gateway. Correct? We had two subnets, and we didn't want both the subnets to get the internet, but we want only one of the subnet to get the internet. Correct? And the default route table is the one where all the subnets were connected with each other through default route table. So if we would have modified the default route table route, so all subnets would have got the internet, but we wanted only few subnets to get the internet. So that's why we created a custom route table, attached it to our subnets to that custom route table, and then we modified the routes to go to internet through our custom route table only. Correct? We just edited the routes. It's not, I mean, we didn't do route right click. I mean, we went to routes, and then we said edit routes, and then we said add route, and we went to what destination as internet target through internet gateway, and we saw our internet gateway, and that's how we got about it. It's showing only created default internet gateway to me as and target to modify the routes. So yeah, so internet gateway that you had created, you need to attach it to your VPC. So we created the internet gateway, we attached it with our VPC. Okay, we created the internet gateway, and then we went to actions. We said attach it to our VPC. We gave the name of our VPC, my VPC, and it was attached. And then when we went to the route tables, and then inside that route table, when we went to edit routes, and we said add route. So there we said destination as 0.0.0.0/0. And then when we selected internet gateway, you should see that internet gateway that you had created. Okay. And And there is no default internet gateway that gets created. It is the internet gateway that we created and that you'll see here and that you need to attach it. Okay, fine. So now guys, see, I have done all these things like created the internet gateway and then attached it to my VPC and then modified the default route table of my VPC and added a route to go to internet through internet gateway. So internet is available on my subnet now. Now I'll go and create a VM inside my subnet 1. Okay, so I'll go and create a VM inside my subnet 1. But before that, I want public IP address on my VM 1. So I can create a VM and assign a public IP address on my VM 1, or I can say auto assign public IPv4 address on subnet 1, so that when VM 1 will be created, automatically it would be assigned a public IP address. Okay, so let's go and do that. So I'll just go to my subnets and I will go to my subnet 1 and I'll go to actions and I'll say what? Say what? Added subnet settings. And I will say enable auto assign public IPv4 address. Okay. I'll check mark that thing and I will save it. Okay. So in case if we want only intranet, how it will connect. So if you just want intranet and not the internet, so don't go to internet. Okay. So don't go anywhere through your internet gateway. Correct. Don't go to 0.0.0.0/0. That is, don't go to destination as internet through your target as internet gateway. Correct. And then it would be a private subnet then, Swati. Okay. And then public IPv4 settings, what I did, I went to my subnet. I'll repeat it once more. I clicked on this subnet 1 and then I went to actions and then I said what? Edit subnet settings. I just enabled auto assign public IPv4 address. This was disabled. I just enabled it and then I saved it. That's it. I did it. In the diagram, I've created the routes. This is the route table route. Okay. Route table is associated with my subnet. Like my subnet is a part of the route table. And this is what is the route from internet gateway to the subnet. Okay. And then from there, from internet gateway to the internet. So internet gateway is attached to internet directly. And then from subnet 1 to IGW, I've created a route to go to internet through internet gateway. So destination is 0.0.0.0, target is internet gateway. And this is like destination is 192.168.0.0/16. This was by default there. So this is the CIDR block of your VPC only, and local. That means from your system, you are able to connect, correct? So local, like it's like all the subnets will be able to connect to each other, correct? Okay, there is a route between all the subnets of your VPC, correct? That are there. So you don't need to play with that. You just need to add this route. See, internet gateway doesn't get created by default. Okay, you need to create it. You need to attach it to your VPC and then only you'll be able to see that internet gateway here. Okay. And how you need to create and attach it, you need to go to internet gateways, you need to create an internet gateway, and once created, you need to select that and you need to go to actions and you need to say attach it to your VPC and just give the name of your VPC. You'll see it there. And that is how you will have it with your VPC, and then you will be able to see it in your route that you will in the destination in your route, correct? The route table. So we have done like VPC, internet gateway, routes, internet, destination, and target. So guys, all good. Let's create a VM then. So go to EC2. Okay. And let's create a VM then. So I'll go to instances. Let's create an instance. So I'll say launch an instance. So I'll give my VM a name. Let's say VM1. Okay. Let me go with any version. So let's go with Linux version. Correct, Amazon Linux, and I can go with Amazon Linux 2023 or Amazon Linux 2 AMI. Then instance type, let's go with T2 micro. Key pair, you can select an existing key pair or create a new one. So let me create a new one. So I'll say my K PP 27, and let me create a PPK key pair. That's okay. The network settings, edit it, guys. let me go in again. So see, just go to launch an instance and then say, give the VM name. Okay, VM1 I'm saying, I'm reducing my space. Okay. Not the space I have good, right? So space, yeah, VM1, and then the OS image. So I'll go with Amazon Linux. AMI, I'll go with that. Amazon Linux 2 AMI. Okay, you can go with Amazon Linux 2023 AMI or an Amazon Linux 2 AMI. Anyone. Then instance type, go with T2 micro. Then key pair, go with, create a new key pair or use an existing key pair. So I just said create a new key pair. I gave any name to it, and then I just went with ppk key pair .ppk format because it's a Linux machine and my laptop is Windows. And anyways, I don't want to connect to this Linux machine, but if I would like to connect it through PuTTY, then I'll need it, this ppk key pair. But I don't want to connect to this VM, but I can always have this ppk key pair created. Okay, so this is good. I hope it's clear. Then in the network settings, I just am going to go. So is it clear till this point? Right. And then after that, just go to network settings and maybe edit it. Right. And then out here in the VPC, you can, we'll just go with what? Our custom VPC. So go with my VPC one, not the default VPC. Select the custom VPC that you created, right? Okay, and then the subnet as your subnet one in that. And of course, auto assign public IP is enabled on the subnet. So it is enabled here and we want it to be enabled. Then in the firewall security groups, I can just go with whatever the name of the security group is. But I'll just allow two traffics in the inbound port rule, that is SSH traffic from anywhere and the HTTP traffic from anywhere. Why HTTP, guys? Because I want internet. Because I want what's not the internet, but I want to promote this VM to work as a web server, correct? So I'll enable HTTP also from anywhere. So two rules I've allowed: SSH from anywhere and HTTP from anywhere. That's it, guys. And yeah. Hard disk 8 GB of storage. It's by default there for the root volume. So we'll go with that. Will not change it. And then in the advanced details, I will just add a script wherein I'll add a script to promote this VM to a web server, correct? So either I can create this VM, then connect this VM and install the web server functionality on this VM, or I can directly add the script here and make this VM to work as a web server. Okay. And that script, I can give it to you in the chat window here. I am giving you a document in the chat window that that contains that script, okay, to install Apache server functionality on this VM. So this is the script. So I'm writing it in Shebang format, #bin-bash, okay. And then I am saying what? Yum update Y. So this will update the Apache server. And then I'm saying yum install HTTP device. So HTTPD means Apache server. So I'm saying install Apache server. Then I'm saying service HTTPD start. So I'm starting the Apache service. Then I'm saying check configuration HTTPD on. So if my server, if my EC2 machine restarts, so my Apache server should also restart, correct? It should be running. So I'm saying check config HTTPD on. Then I'm going in the default location of Apache, which is cd/where/www/html. So I'm going into the default location of Apache where www.html. Okay. And then in that default location of the Apache, I am creating an index.html file and I'm writing in hello world there and I'm just echoing it on my screen. So this will become my home page, hello world. And then I'm also creating another file out there, healthy.html, and I'm writing out there, I am healthy, correct? So I'll just copy this and then I will put it in the user data section here. Okay, fine. So this is there. And then I will launch my instance. Okay, then I'll launch my instance. So number of instances, I'm creating is 1. And let's say launch this instance, guys. So it's all good. It has been created, guys. How do I add the script after creation of the instance? So connect to your instance. You can connect it directly through the portal or through PuTTY, and then say sudo su, and then you can add the script on your instance. Okay. Then you can just copy paste this script when you connect to your instance, correct? Out there. Just run it out there. Come to super user, sudo su, and just run it out there. Okay, fine. So created the VM with the script. Now just go to that instance. Go to the instance, guys. And then just copy the public IP address of your instance or the DNS name of your instance and put it in your browser. And then you just put it here. And can you see hello world? Yeah. Is our VM working as a web server? Yes or no? We allowed internet on our VM, and we also promoted it to web server functionality. We installed the Apache script, and we also did what? We allowed HTTP traffic from anywhere. So it's working as a web server. Correct, right? Now what? Now what? So it's working as a web server, and we are able to see hello world page. Okay, so now all good. Fine, guys. So now let's go and let's create a custom NACL and let's attach it to our VPC. See my diagram?
Just a quick info, guys. Intellipaat offers advanced certification in DevOps and cloud computing in collaboration with IIT Pravartak, a technology innovation hub of IIT Madras. This online advanced certification in DevOps and cloud computing by IIT Pravartak will help you gain expertise in DevOps, access management, DevSecOps, Terraform, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel. The link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take your first step towards career growth in the field of cloud and DevOps.
So we are till this point, our VM1 is working as a web server. Now let's create an NACL. Let's create a custom NACL and attach it to my subnet. Shall we go and do that? And you will see one good thing out there. So shall I just create a custom NACL and attach it to my subnet? And then maybe if you want, I can go in for the break or complete this and go in for the break. So just go to your VPC and go to your NACL. Go to your network ACL and then do what? Then just create an NACL. Just create a network ACL. Okay. Just create a network ACL. You give it a name. Let's say my NACL1. And I'll attach it to my VPC. So I'll give my VPC1 name here. That's it. And what I'll do is I'll say create network ACL. Okay, so this is my NACL1. Now get inside this NACL. Get inside this network ACL. And tell me one good thing. Have you attached your subnet to this NACL? See, you have created this NACL. And you have attached it to your VPC. But then have you associated your subnet to this NACL? Yes or no? Not yet. Okay. So I do want to associate my subnet to this NACL. Correct? Correct or not? Yes or no? I want to associate my subnet to this NACL. So I'll do that. So I'll go to actions and I will say what? Edit subnet associations, and I will associate my subnet 1 to this NACL. That's the point. Manish saying it's already attached to my default NACL. Still, I will try to attach it to my custom NACL. Just go and try to attach it and you will succeed. See, it's saying you have successfully updated your subnet associations for my NACL. So see, now it is associated with my custom NACL, my subnet, correct? So now Manish was saying, but it is associated to my default NACL. But as soon as I attach it to my custom NACL, will it be associated to my default NACL anymore? Will it be associated to my default NACL anymore? The answer is no. See, it has been removed. It has been removed from my default NACL. It was associated with my default NACL, but as soon as I associated with my custom NACL, it is removed from my default NACL because one subnet can only be associated with one NACL. So by default, it was attached to my default NACL, and as soon as I attached it to my custom NACL, it was removed from my default NACL. But now, guys, that's okay. Fine. I have associated my subnet to my custom NACL. But now you do one thing. This IP address of your VM that I had given you, just refresh it. Or just take this IP again and put it in another browser and tell me one good thing. Are you able to access your VM's homepage? Is it still running as a web server? Are you able to access your web server? Are you seeing Hello World page now? Yes or no? It's trying. It's just loading. No. Yeah. So it is not accessible. So it is not accessible, guys. And can you tell me the reason why? So see, what I did is I went to my VPC. I went to my NACL. And then I created a network ACL, a custom NACL. I gave it a name. I selected my VPC. I attached it to my VPC. I created that. And once created that NACL, then I selected that my NACL and I said actions and I said edit subnet associations. And I associated my subnet 1 to this NACL. I checked that mark and I said save changes. Correct. So this is how I created and attached my custom NA, my subnet 1 to my custom NACL. Yeah, and it was attached, my subnet 1 was attached to my default NACL, but as soon as I attached it with my custom NACL, my subnet 1, so it was removed from my default NACL. Correct? Got it? Correct. But then the point is now my subnet 1 is associated with my custom NACL and my VM was able to go to internet, but now it is not able to. So I'm not able to access my web server. Now, can you tell me the reason why? Yeah, so that is the reason, right? So the reason is what? Inbound and outbound are denied, correct? Yeah, so see, by default, your default NACL allows all inbound and outbound traffic, but your custom NACL denies all inbound and outbound traffic. And that is why you are not able to access this web page. Okay, in fact, you can see this. See, this was your default NACL. If you go to your default NACL, if you see the inbound port rules of your default NACL, what it says, at the star rule number, it says deny all traffic, but at 100 rule number, it says source means in the inbound port rules. That means allow from anywhere. What? Allow any traffic from anywhere, correct? From anywhere. That is 0.0.0.0/0. So that means from anywhere, allow any traffic, correct? So rule number is 100, correct, guys? Yeah, so you was allowing all inbound traffic. Now you are saying when star it is denied, but then lower the number, higher the priority, and rule number 100 is the lowest number. It starts from 100. So 100 rule number means the highest priority. So on rule number 100, you are allowing all traffic to come inside. So that's why it is allowed in the inbound rules. In outbound rules, again on rule number 100, you are saying allow all traffic to go out. Correct? Destination is 0.0.0.0/0. So all traffic allowed to go out again. Correct. So here in the default NACL, you was allowing all inbound and outbound traffic. Correct. But then just see your custom NACL. So this is your custom NACL. Okay, wherein subnet 1 is associated with. In this, if you go to inbound port rule, see, it's all deny, all traffic is denied. And in the outbound port rules, again, all traffic is denied. All traffic is denied in inbound and outbound port rules, guys, right? Okay, so now what? Now what? Now what we should be doing? Should we be allowing HTTP traffic to come in and go out? Should we be allowing HTTP traffic to come in and go out and then our web page, web server will start working? Yeah? Okay, let's do that. So go to inbound port rules, edit the inbound port rule and just add a rule, What am I doing? Yeah. Add a rule, say the rule number, let's say 100. because 100 the highest priority. Then what traffic you want to allow? Let's say HTTP traffic. Which traffic? HTTP traffic, which works on port 80. Source means from where? From anywhere, correct? So 0.0.0.0/0. And then allow or deny, allow, correct? And I'll save it, right? So this is my inbound port rules. Yeah, should be allowed. Both should be allowed, right? Correct. So I'm allowing in both the ways. First inbound port rules I'm allowing. Rule number 100, HTTP port 80, 0.0.0.0/0. Allow this traffic, and I am saying this allow, save changes. Fine. I've allowed the inbound traffic. Port 80 traffic in the inbound port rule on rule number 100. Now go to outbound port rules. And here also just allow all traffic to go out. So, I mean, the HTTP traffic to go out rather. So I'll say add a rule. I'll say what? Rule number again 100. Lower the number, higher the priority. The number starts from 100. So 100 is the highest priority. Okay, then all traffic which traffic? Which traffic, guys? HTTP traffic, correct? So allow HTTP traffic to go out on port 80. Destination, go anywhere. That is 0.0.0.0/0. That is internet. Allow. All good, right? Save the changes. Yes or no? Is it all good? So just say save changes. And now, guys, still it will not, or it will work. Tell me, will it work now? Will I be able to access my homepage? No, you will not be able to. That is the twist. Okay. So just try to access it and still you will not be able to access it. And now can you tell me the reason why? Is there any setting we need to change in the subnet? Need to allow outbound also. Outbound also we have allowed HTTP traffic, isn't it? So see, this is what happens basically. So when you as a client is sending a request to the server, correct? That is when you are typing the IP address of the server of my VM in your browser, when I am typing it in my browser. So what is happening is the request is going from the client to the server, correct? On port 80, that is HTTP, correct? So the request is received by the VM on port 80, that is HTTP port. But then the acknowledgement of that request has to be sent to the client to see it in the, to see the homepage on the client's web browser. So that acknowledgement, guys, the acknowledgement also, we are trying to send it through port 80 only. So in the inbound port rules, I'm saying that receive the traffic from port 80. So the traffic is being received, HTTP traffic, from the client, from the user on port 80 on the server, correct? Because in HTTP, in the inbound port rule, I'm saying that receive the traffic from port 80 HTTP. But then when the server is trying to give the acknowledgement, so it would be given through the outbound port rules, correct? So in the outbound port rule, I'm saying that give the acknowledgement again on port 80. So the response to the HTTP request, that is port 80 request, should also be given on port 80. That is acknowledgement should also be given through port 80. That is what I'm saying here. But then, guys, the point is that acknowledgement may not always go through port 80. It may go through any random port number. So then the response, the acknowledgement, it is not necessary that the acknowledgement to HTTP request will always go through port 80, that is HTTP port. So the acknowledgement can go on any port number, guys. And there is something called as ephemeral port range that ranges from 0 to 65535. So whatever the port numbers are there, whatever the protocols that are there, whether it is HTTP, RDP, SSH, they work on the port numbers that lie in this port range only. That is called as ephemeral port range. That is 0 to 65535. In fact, the usable range, I think, starts from 127 or 128 onwards only. So, but then whichever the protocol is, whether it is HTTP or RDP, the port numbers for that will be lying in this port range only. That is between 0 to 65535 only, guys. Correct. So that is called as the ephemeral port range. Okay. So that is what is ephemeral port range is, correct? That is 0 to 65535. Okay, so now the point is that response to the HTTP request can go on port 80 or it can go on any other port as well. But I am just sending the traffic from port 80 only. And that is the problem. So if the response is not going through port 80, then it will drop there itself, correct? So if the response will not go through port 80, then it will drop there itself and it will not reach to the destination and the client will not see the home page of the website, correct? Or the home page of the web server. So that is the point, guys. So now to overcome this issue, what we need to do is, do we need to modify the inbound port rules or do we need to modify the outbound port rules? Tell me. The outbound port rules we need to modify. And in the outbound port rules, instead of saying allow HTTP traffic, allow port 80 traffic to go out, what we will do is we will say allow all traffic to go out. What we will say? Allow all traffic to go out. That is the traffic that can range from 0 to 65535. All traffic to go out. May it be any port traffic, correct? So just say that thing. Just modify that or create another rule which says allow all traffic to go out and you should be good then. Okay, so just go to outbound port rules of this NACL, my NACL one, and then do what? Then say edit outbound rules. So now you can just modify this rule itself, or you can add another rule also. That's not a problem. So you can say add another rule. And here you can give the rule number. Let's say 101. So 100 rule will be first seen, and there it will say allow HTTP traffic to go out. But if it's not HTTP traffic, then rule number 101 will come into picture. And there you can say allow all traffic to go out, correct? Okay, so you can say allow all traffic to go out, or you can say here custom. So either you can say all traffic or you can say custom TCP as well. And here you can specify the port range as 0 to 65535. So it's like all traffic, correct? So either you can say directly all traffic or you say custom TCP and give the port range as 0 to 65535. And then the destination is anywhere that is on the internet, 0.0.0.0/0 action allow. Okay, and then just allow it. So what I have said here, again, I'll repeat it. So rule number 101, custom TCP, port range 0 to 65535, correct? Destination 0.0.0.0/0 internet and allow as here. And I'll say save changes. And this will be all good, guys. Right? So this is all good. And now you try to access it. Okay. And it should start working. See, it starts working. See, it starts working, guys. Correct? Okay, so now working. Yeah. So is it clear? Yes, even though it is same, 80 is also in range of ephemeral range, right? If so, why is it not allowing? No, see, 80 is just one port number in that range, correct? But the ephemeral range goes from 0 to 65535. So it's not always that through port 80 only the acknowledgement will go out. It can go out through port 100, through port, it can go out through port 3389, it can go out through port 22, it can go out through any other port as well. Correct. So if you're just allowing port 80 out there, and if through port 80, if the traffic is not going out, then it will not go out. Simple as that. And when you are saying allow it from any port, then whether it is going through 3389 or 22 or 80, 443, whatever, so it will be allowed to go out. And that's why, Sharmila. Yeah, it was due to outbound only. It was not allowing because I was saying the traffic to go out through port 80 only. But then it's not always that for the HTTP traffic also, the acknowledgement also to go out, that port 80 will only be used in the outbound rule, right? I mean, it can be any other port number also. And if it is any other port number, then it was not working because I had allowed the traffic to go out through port 80 only. That's why now I've allowed the traffic to go out from any port, and that's why it is now being sent. So it is not specific range we decide to allow to go out. Yeah, correct. So it is not specific range, but we allow all the ports here. That is what is ephemeral port range we allow. So is it clear to all of you guys? In fact, now if you remove in the outbound rules, now if you even remove this HTTP port 80 also, still it will work. Why it will work? Because that port 80 is anyways included in all traffic also. Correct. So if you remove HTTP, it will still work because in all TCP 0 to in all port ranges, that port 80 is also included. Correct. So you can remove this also and still it will work. If you save this changes, still it will keep on working. See, it works. See, it works. Correct. Right. Okay. So that's how it goes. Not a lot practice, but a little practice will do, Ranjit. Right. Okay. So now you can just remove this. I mean, see, right now this NACL, this subnet is connected. And if I just delete this NACL, so this subnet will be associated then with the default subnet. Yes or no? Correct? Right. So you can, I mean, I can show you that as well. So right now you can see the default NACL, there is no subnet associated. But when you remove this custom NACL, so if you say delete network ACLs, okay, but they are associated, the subnet is associated with that. So you first need to remove the subnet association. So if you go to actions and say edit subnet associations, and if you remove this subnet from this custom NACL, okay. So see, as soon as you remove it from the custom NACL, it got associated with your default NACL, the subnet, correct? So that's how it goes, guys, right? So as soon as you remove it from your custom NACL, it got associated with your default NACL, that subnet. Okay, and then also this traffic will work because anyways in the default NACL, all inbound and outbound traffic is allowed. Okay, so this is all good. Right, so this was about the network ACL. Okay, now let me give you the introduction to VPC peering to you guys. Yeah, right, the VPC peering stuff, because the point is very clear, guys. Fine. Okay, so see, this I have anyways discussed, but let me go through it again. So Amazon VPC lets you provision a logically isolated section of the Amazon Web Services, AWS Cloud, where you can launch AWS resources in a virtual network that you define, correct? And you have the complete control over your virtual networking environment, including selection of your own IP address range, creation of the subnets, and configuration of route tables and network gateways. We have seen that, guys. You can easily customize the network configuration for your Amazon VPC, virtual private cloud. Okay. For example, you can create a public facing subnet for your web servers that has access to the internet and place your backend systems such as database or application servers in a private facing subnets with no internet access. That's what we did it in the last week. That is, we created our application servers in the public subnet, and the database servers I told you can be created in the private subnet with no internet access. And then you can leverage multiple layers of security also, including security groups and network ACLs, network access control list we saw today, to help control access to Amazon EC2 instances in each subnet, correct? Additionally, you can create a VPN also, hardware virtual private network connection between your corporate data center, that is your on-premises, and your VPC. And you can leverage the AWS cloud as an extension of your corporate data center as well, correct? That you can do. Okay, and this is the network diagram. Anyways, we had done this, right? So, yeah, that is their public subnet. You can have instances controlling the security group, network ACLs, route tables, correct? All these things. Yes, so what you can do with VPC, you can launch instances into a subnet of your choosing. Okay, you can launch the instances into a subnet of your choice, correct? And you can assign custom IP address ranges in each subnet. Yeah, you create your own, you design your network. We have created our own network, right? The CIDR blocks we have assigned of our own choice. Then you can configure route tables between the subnets. Okay, we have done that. Create internet gateway and attach it to our VPC. We did that. Then it has much better security control over your AWS resources. Uh, Now it makes sense to go through these points now after we have done it, because if before I would have done it, it's like, okay, we can do it, but how? But now when you're reading, it's okay, you can do it and how you can do it, correct? Then instance security groups, you can create it, subnet, network, NACLs, network ACLs, right? Access control list, you can create and attach, I've shown you. So default VPC versus custom VPC. So default VPC is user-friendly, guys, and allows you to deploy instances immediately. So till the point I've not shown you how to create your VPC, you were still creating your instances, your virtual machines, but you were creating them in your default VPC, correct? So it was user-friendly and it allows you to deploy the instances, the VMs immediately. And all subnets in the default VPC have a route to the internet. So all the subnets in the default VPC have the route over to the internet, correct? And each EC2 instance has public and private IP both associated with it. So see, by default, see, it is, have you noted this point? So when you create your custom VPC, okay, tell me this thing. So when I've created my custom VPC, so by default, any subnet of your custom VPC, is it connected to internet? Is it a public subnet or a private subnet? Any instance of your custom VPC, guys, tell me. Sorry, any subnet of your custom VPC, is it a public subnet or a private subnet by default? When you create your custom VPC with the subnets, is it a private VPC? Is it a VPC with private subnets only or public subnets? It's all, they are all with private subnets, correct? And then whichever you wanted it to be public, right, Ashish? So or by default, they were all private. And then whichever you wanted them to be public, you created internet gateway, attached it, and then you modified the route table to go to internet through that internet gateway. So that's how you made those subnets public, whichever you wanted to be. But by default, all the subnets of your custom VPC are private subnets. Okay, guys. And then you had the option of making some subnets public also. Okay, by connecting them over to the internet through internet gateway. But default VPC is always public, right? So default VPC, Ashish, is always public. Default VPC means the VPC that you have in every region by default created for you. Like if you have noted, in every region, there is one default VPC that is already there. Like in North Virginia also, if you go to your VPCs, there is one default VPC that's already there. So in every region, there is one VPC. And in that VPC, there are how many subnets? So depending on the availability zones that you have in that region, you have the number of subnets. Like North Virginia has 6 availability zones. So the default VPC of North Virginia has 6 subnets. And guys, let me tell you, all the subnets of your default VPC are public in nature by default. So all the subnets of default VPC are public in nature by default, correct? So all the subnets of default VPC are public in nature implicitly, because all of those subnets of the default VPC through the default route table are connected over the internet through the internet gateway. So see, this is the internet gateway of your default VPC that is attached to your default VPC. Okay. And then there is a route table for the default VPC. Okay. And then all the subnets of the default VPC through the route table of the default VPC are what? Connected to the internet through an internet gateway. Okay, right? So that is what you have it. And this is there in every region, guys. So by default, all the subnets of your default VPC are public in nature by default, guys. Correct? So that's the point again that you can see here. So default VPC versus custom VPC. So default VPC is user-friendly and allows you to deploy instances immediately because you don't have to create the VPC there. And all subnets in default VPC have route out to the internet by default. And each EC2 instance has public and private IP. So in your default VPC, in the subnet of your default VPC, whenever you create any instance, okay, so that is always having a public and private IP both associated with it, because that will be a public EC2 instance. And if you okay, so if you delete the default VPC, the only way to get it back is to contact AWS support. Correct. If you deleted the internet gateway of your default VPC, so then you will not get internet on the EC2 instances which you create in the default VPC subnet. Okay, and now to get that, correct, right? Yeah, you're not getting the internet. I know that. And now if you want to get that internet, you need that internet gateway, and you cannot do that, right? So you need to contact the AWS support, or otherwise, for the time being, you can operate in another region then. Right. So guys, that's why don't delete the default VPC or the components of that. If you create a new instance in custom VPC, it has only private IP only when you create that instance in the private subnet of your custom VPC. But if you create a EC2 instance in the public subnet of your custom VPC, then it will have a public IP address. You can auto assign as well. I'd shown you that, Rohit, previously. Okay, so now VPC peering, guys. So what do you mean by peering? What do you mean by peering? If you have studied maybe Azure before, VNet peering, you should be knowing this, that peering means what? To connect two networks together, correct? Right? So linking two networks that are in AWS here, correct? So it allows you to connect one VPC to another VPC through a direct network route using the private IP addresses, guys, right? Tell me one good thing. Okay, I'll come to the use case of this, but then tell me one good thing. I'll show you through the diagram maybe. If I have that diagram available with me right now, or otherwise, I will have to see to it where I have it.
Let's have a quick quiz question, guys. And the question is, which AWS service provides a fully managed file system that is accessible from on-premises servers and AWS resources? And your options are Amazon S3, Amazon EFS, Amazon Glacier, or Amazon Storage Gateway. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers advanced certification in DevOps and cloud computing in collaboration with IIT Pravartak, a technology innovation hub of IIT Madras. This online advanced certification in DevOps and cloud computing by IIT Pravartak will help you gain expertise in DevOps, access management, DevSecOps, Terraform, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel. The link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take your first step towards career growth in the field of cloud and DevOps.
So as you can see in this diagram, there are two VPCs, correct? VPC 1 and VPC 2 with two subnets. That is subnet 1 in VPC 1, subnet 01 in VPC 2, correct? And then this subnet 1 is having VM 1 and this subnet 01 is having VM 2, correct? Fine, all good. Now the point is that, guys, tell me one good thing. If these two VPCs are not connected with each other through this VPC peering, so tell me one good thing. Can this VM1 from this subnet 1, can this VM1 talk to VM2 in subnet 01 in another VPC? Can the VMs of two different subnets, or can two different subnets talk to each other from two different VPCs without the two VPCs connected with each other? The answer is no. But still, the VM1 from subnet 1 can talk to VM2 from subnet 01 on the public IP address. That can happen, correct? But I'm saying that can these two subnets talk to each other by default if the two subnets are in different VPCs? The answer is no. Or can the VMs from these two subnets, which are in different VPCs, can talk to each other on their private IP address? So the answer is no, they cannot. Like the guys, subnets of same VPC can talk to each other by default, like neighbors in a locality can talk to each other by default, because there is one bit that is reserved for the router bit. But then if the subnets are in different VPCs, then they cannot talk to each other implicitly by default. Correct? Yeah. So with public IP address, yeah, internet gateway, that is a different thing then. Yeah, but I'm saying the subnets having VMs with private IPs only, can they talk to each other, like the VMs from two different subnets of two different VPCs on their private IP address? Can they talk to each other? The answer is what? No, correct? So two different VMs of two different VPCs and subnets cannot talk to each other on their private IP addresses, guys, if the two VPCs are not connected with each other. But then the point is that you can connect these two VPCs with each other with something called as VPC peering. So you can connect the two VPCs with each other with something called as VPC peering. So you can connect two networks in AWS using VPC peering. Now, these two networks can be in the same region in AWS or can be in different regions also in AWS. Okay. And you can connect them with each other using VPC peering. Okay. Now the question comes in, what if I have one VPC in AWS and one network in my on-premises? Or let's say if I have one network in AWS, that is VPC, and one in Azure. So can I connect my AWS network with my Azure network using VPC peering? Can I do that? Or can I connect my AWS VPC with my on-premises network using VPC peering? Can I connect those with VPC peering? The answer is no, guys. It's not yes, but it is no. So for VPC peering to work, the two networks should be in AWS only. If one network is in AWS and one is in on-premises, or one in AWS and one in any other third-party cloud like Azure or GCP, so you cannot connect them with each other using VPC peering. You can connect them with each other, but then you can do it with VPN gateway, not with VPC peering. Okay. Correct. So with VPC peering, the limitation is that you can, limitation or whatever the property is, that you can connect two networks of AWS only with VPC peering. And those two networks that are there in AWS, they can be in the same region in AWS or they can be in different regions in AWS. Correct. So these two networks can be in the same region in AWS or can be in different regions in AWS, but they have to be there in AWS only. Then only you can connect them with each other using VPC peering. I'm not saying you cannot connect the AWS network with Azure network. You can connect, but not through VPC peering. Through VPN gateways, you can do it. In fact, with your AWS network, you can connect with on-premises using VPN gateways, but not through VPC peering. With VPC peering, you can connect the networks in AWS only. And those networks in AWS can be in same region or can be in different regions as well. Irrespective of availability zone, irrespective of regions also. Correct? You can connect them with each other, but provided they are in AWS only. Okay. Yeah. So not same region, Abhinav. It can be different region also, or same region or different region, but then in AWS only. Okay. So two VMs, two VPCs, two subnets in different VPCs cannot talk to each other on private subnets irrespective of availability zones. See, two VMs, two VPCs, two subnets in different VPCs cannot talk to each other on private subnets irrespective of availability zone. Of course, yes, they cannot talk to each other. Two different VPCs, even if they are in the same availability zone, they cannot talk to each other, the VMs inside those two VPCs on their private IPs, correct? Because they are the part of different VPCs, different subnets. But yes, if those two VPCs are connected with each other using peering, then those two VMs can talk to each other on their private IPs. Interoperability not standard in AWS, right? So yeah, so that is VPC peering. So if you have connected your two VPCs with each other using VPC peering, so then of course the VM inside those two VPCs can talk to each other on their private IP addresses. And these two VPCs can be in the same region, in same availability zone, or can be in different availability zones in the same region, or can be in different regions also. But then they have to be in AWS only. And once you connect them using VPC peering, then of course the VMs in their subnets in those two VPCs can talk to each other on their private IP. Okay. And now the point is that that why you would want the VMs to talk to each other on their private IPs. Because even if the two networks are not connected with each other using peering, still the VMs can afford to talk to each other on their public IPs, maybe with the internet gateway in picture. Then why you want the VMs to talk to each other on their private IPs, guys? So a very good use case, like it is quite used in your organizations, guys, because in your organizations, normally public IPs are not allowed on your resources. So normally in your company environment, public IPs are not allowed on the internal resources. Correct? On your internal VMs, public IPs are not allowed, guys. And now if you have two VMs in your organizations in different network and public IPs are not allowed on them, and still if you want those VMs to communicate with each other, so how can you do that? What is the option you have? So you need to communicate them with each other on their private IPs. So how you can communicate them on their private IPs? So you can only make them communicate with each other if the two networks are connected with each other with something called as VPC peering here. Correct? So that is where it can be really, really useful. Okay. So this is the, you can say the need of peering, or you can say why it would be really useful to connect the two AWS networks using VPC peering. Correct? So that you can allow the VMs to talk to each other on their private IPs. And why it is required to talk to on the private IPs? Because normally in the company environments, public IPs are not allowed on your VMs on your internal resources for the reasons of security. And still, if you want the VMs, the resources to communicate with each other, so you can do so if the two networks are connected with each other using something called as peering in AWS, correct? So that is where it can be really, really useful. So of course, VPC peering has a lot of advantages, or it is really useful, you can say, correct? So as I have mentioned it here, so it allows you to connect one VPC to another VPC through a direct network route using private IP addresses. So allows you to connect one VPC to another VPC through a direct network route using private IP addresses, correct? So that's what you can do it in peering. And instances behave as if they were on the same private network. So it is like the instances of the two different VPCs with the two different subnets will behave as if they were on the same private network, guys. It's like they were on the same network. They belong to the same VPC. They will behave like that because they'll be able to talk to each other on their private IP addresses. Simple as that. And it allows you to connect one VPC to another VPC through a direct network route using private IP addresses. So in fact, the connection between the two VPCs will happen through the Amazon's internal private network. And that's why it would be very secured, and you don't need to even encrypt the traffic also, because the connection will happen over the internal network of Amazon and not over the internet. Okay. And you can peer VPCs with other AWS accounts as well as with other VPCs in the same account. As I told you, you can peer one VPC with another VPC that can be in the same region, or that can be in different region. Plus, it can be in another AWS account. Like my AWS account VPC can peer with your AWS account VPC also. And my AWS account VPC from, let's say, North Virginia region can peer with your AWS account VPC that can be, let's say, North Virginia or in Mumbai region also. So that is also possible. So you can peer VPCs with other AWS accounts as well as with other VPCs in the same account as well. Okay. And peering is in a star configuration, guys. That is, one central VPC peers with 4 others, that is, there is no transitive peering. I'll just show you that diagram. So guys, normally VPC peering happens like this. So let's say VPC A can be paired with VPC B, C, D, E, something like in a star configuration. Now, if you're thinking that maybe if my VPC A is connected with VPC B and VPC A is connected with VPC C, so then my VPC B and C can talk to each other by default by the rule of transitivity. That is, if A is to B and A is to C, then B is to C implies by the rule of transitivity, correct? So A to B, B to C, then A to C, right? But let me tell you guys, VPC peering is non-transitive in nature. Now, those who know Azure now, maybe you can relate it like in Azure also, you have VNet peering, but that is non-transitive in nature. But so here also, VPC peering is non-transitive in nature, correct? So if A is to B and A is to C, that doesn't mean that B is to C implies, okay? Because VPC peering is non-transitive in nature. Okay, fine. So A to B and A to C doesn't mean that B to C implies. So VPC peering is non-transitive in nature. Okay. So if you have to have a connect from B to C, so you'll have to establish a direct peering connection from VPC B to C. If you want to have a connect from B to C. Okay, so peering is in a star configuration, that is one central VPC peers with 4 others. There is no transitive peering out here. So that is how it goes. Correct, guys? Okay, so yeah, so that is how the VPC peering works, guys, right? So yeah, that is there, that is there, that is there. And maybe am I missing on any point here? Just a second. 1 second. Okay, yeah. And there is a limit, like, so, yeah, so like, yeah, and there is a limit on the number of VPC peerings, direct VPC peerings that you can have from one VPC to another VPCs. Okay, so one in Azure, guys, is what we can relate. So one VPC, one VNet can peer with 500 other virtual networks directly. In AWS, you have the limit of 125, I think, right? So maximum limit is 125 peering connections per VPC. So one VPC can peer with 125 other VPCs directly, right? So that is a limit that you have in Azure. Oh, sorry, in AWS, right? In Azure, it is 500, the limit. So one VNet can peer with 500 other virtual networks directly in Azure, whereas in AWS, one VPC can peer, I think, with 125 other VPCs directly, correct? So that is again out there, right? And I've told you the need or the use case or why the peering is so useful, correct? So for the VMs in different networks to talk to each other on their private IPs, because in the organizations, normally public IPs are not allowed on your virtual machines, correct? So that's again a point, correct? So that is about what you call it as the VPC peering, guys, correct? Okay, so now, of course, the next thing remaining is to do the lab on peering, correct? Plus, before I do the lab on peering, but let me tell you, see, in fact, this transit gateway. So if you want to connect a VPC from AWS to your on-premises network, so you can do a site-to-site connectivity with the help of a transit gateway and VPN gateway. You can achieve that, correct? Plus, you can connect 2 VPCs in AWS again through transit gateway also. And you can do it with VPC peering also. So in fact, you can, with VPC peering, you can connect 2 transit gateways also. And then that transit gateways can be connected to your 2 networks or VPCs in AWS also. Because like VPC peering is supports cross-region also. Like you can connect 2 networks from different regions also through VPC peering in AWS. But with Transit Gateway, you cannot connect 2 VPCs from different regions. With Transit Gateway, you can connect 2 VPCs in the same region like this. VPC1, VPC2 connected through Transit Gateway in the same region. or you can even connect your VPC1 from AWS with your on-premises network with the help of transit gateway and VPN gateway. So that is also possible. Correct. And as I told you, you can connect two VPCs in AWS also through transit gateway, but in the same region only. But if you want to connect across the regions VPCs, then you cannot do so with transit gateway. Then you can use peering, VPC peering, and you can do VPC peering between your two transit gateways also. Like you can have one transit gateway connecting VPC1, VPC2 in the same region, and another transit gateway connecting VPC3 and 4 in another region. And then these two transit gateways you can connect using VPC peering. And that is how your VPC 1, 2, 3, 4 can all be connected with each other as well. Correct? Okay, so that is what you can do again here. Okay, so yeah. So yes, guys, so this was it. And then if you want to do peering maybe, so I'm not going to do peering today, but you can just go to peering connections and then you can create the peering connection. You can select your VPC requester and then acceptor VPC you can give from another region, and then you send the request from one region, and the other region VPC will accept that request. Yeah, guys. So that's how you can go about it, right? So, okay. So anyways, the setup would need the same thing. Like you will go and you will create what you go and create two VPCs with two subnets, and then allow internet in both the VPCs, and the two VPCs can be in two different regions. Like the diagram anyways is here, right? Yeah, so create one VPC with one subnet, one VM, another VPC with another subnet, another VM in two different regions, or can be in same region also. If they are in two different regions and you peer them with each other, so they will be called as global VPC peering. If they are in the same region and then you peer them with each other, so that will be called as local VPC peering. These steps will remain the same for both. So you can create two different VPCs in same or different regions with two different subnets and two VMs in them. And of course, then you can again create an internet gateway the way we had done with this lab. That is, you can create an internet gateway, attach it to your VPC, and then from the default route table of your VPC, you can allow to go to internet through internet gateway. Okay, create a route to go to internet through internet gateway, target as internet gateway, and destination as internet. So just do that in both the VPCs. Okay, and that is how your both the VPCs will be able to go to internet also. Correct. And now that is not required for this lab, but then to test it out, it is required to let them go to internet gateway and then to the internet. And then what? Then just try to do VPC peering. So make a request from one VPC and accept it from another VPC, and then go to this VM. Do RDP or SSH to this VM. If it's a Windows VM, do RDP and do RDP on this VM as well. And then what you do, you just try to ping from the command prompt, go to this VM or command prompt of this VM and try to ping the other VM through that. And from the other VM also try to ping the first VM. If the networks are connected using VPC peering, and then you try to ping the two VMs on their private IPs, you'll be able to do so. Without peering, you will not be able to do so. So that is how you got to do it. So just try it out, guys. Yeah. So do it by yourself. Topics covered here are NAT Instance, NAT Gateway, NACL versus security groups, and VPC peering. Okay, right? Interoperability. What is interoperability? So interoperability means operating interoperably, right? So Abhinav, I mean, what is the literal meaning I can give you? So, I mean, I can say the literal meaning, the ability of computer systems or software to exchange and make use of the information, right? So interoperability is possible with the public IPs directly. Okay, but with the private IPs, it's possible if the two VPCs are connected with each other using VPC peering, right, Vinayak? Right, Abhinav? Is that clear, right? So interoperability means what? The ability to exchange and make use of information, correct? Exchange the information and make use of it. Now you have to peer it. May not be all the things in how you need to peer, but then you find it out and to peer it then, right? Because guys, it's simple now. I mean, see, so you can peer more than 2 VPCs, but VPC peering is non-transitive in nature, right? So yeah, so you can peer more than 2 VPCs also. But then transitivity is not allowed. So one VPC you can peer with 125 other VPCs directly. That is the multi-cloud, and normally that is what is the preferred scenario now. Like companies are not operating on just single cloud, but different services, different resources from different cloud platforms, right? So yes, AWS and Azure and GCP can be used in single organization and are quite used also. Right, today is the era of multi-cloud platform, and that's why people are learning multiple clouds, correct? So guys, that is not, and in fact, to tell you, not in the scope, but then maybe if some good time I can show you Azure and AWS connectivity also, correct? Azure AWS peering, like VPC from AWS, how it can connect to VNets in Azure, correct? And then the VMs of AWS can talk to VMs of Azure on their private IPs directly, correct? Without the public IPs in picture. Because public IPs are not allowed due to security compliances in companies. These were the topics that were covered. That is NAT Instance, NAT Gateway, NACL versus security group, VPC peering, not the lab part, but yes, the concept part was covered, right? Lab part, because of time, I couldn't cover, and I have told you to do it, try to do it, right? Okay. NACL, VPC peering, okay. Like create instances and VPCs before the class begins, you can right away give emphasis on peering concepts alone. That would save your time. Correct. So you need to create 2 VPCs with 2 subnets with 2 VMs in them and try to do the peering as well. So in the same way, can TGs for different regions connections be requested through any external support by sending requests? So see, with transit gateways, you cannot connect the 2 VPCs in different regions. That is not possible. So transit gateways limitation is that it can allow the 2 VPCs to connect with each other if they are in the same region, but not in different regions, correct? So that is the limitation of transit gateway, that it can make your 2 VPCs of the same region to connect with each other, but not of different regions. Okay. So if you want the different region VPCs to connect with each other, you need peering, or otherwise you can connect the 2 transit gateway also from different regions through VPC peering. And then those 2 transit gateways in different regions can connect to 2 different VPCs of their region. When you're saying we need multiple VPCs. Okay, so basically it's like it's there to refresh the server instance, right? Automated deployment to refresh the server instance, right? So if you want to rehydrate, let's say ping directory replicated server instances in AWS without having any downtime, right? So you want to rehydrate your ping directory replicated server instances in AWS without having any downtime. So do have a best practice document, which you can refer, and it is more of automated deployment to refresh the server instance, right? So you can automatically refresh, it's like you can do automated deployment to refresh the server instance, and you can do it without what you call it as the downtime also, correct? So basically, rehydration is the process of spinning up new servers with the latest patches already installed on them and decommissioning or destroying the old servers that you do not want or that you do not need. So it is possible to rehydrate tens, hundreds, and even thousands of servers at the same time in the public cloud, correct? And you can do that. With auto scaling also, with horizontal scaling that you can do in an auto scaled manner also, right? So because it's the process of spinning up new servers with the latest patches already installed on them and decommissioning or destroying the old servers that do not need. So deleting the old servers can be done later on, but then you can always create new servers with the latest patches already installed on them using horizontal scaling also, that you can achieve with vertical scaling as well, right? Yeah, but there can be a lot of things that can be said about, but it's not in the scope.
Just a quick info, guys. Intellipaat offers advanced certification in DevOps and cloud computing in collaboration with IIT Pravartak, a technology innovation hub of IIT Madras. This online advanced certification in DevOps and cloud computing by IIT Pravartak will help you gain expertise in DevOps, access management, DevSecOps, Terraform, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel. The link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take your first step towards career growth in the field of cloud and DevOps.
As I already told you, in this session we'll be looking at a hands-on. So before moving on with the session, let me briefly show you what is going to be the output of our hands-on. So this is our local host and this is our Elastic Beanstalk. So first in localhost, what I'm going to do is I'm going to upload this doc1.pdf and I upload it. So the file has been uploaded successfully. So now let me open Amazon Web Services account and I'll open my S3 bucket. So first I'll open the S3 service and inside that there are already buckets which I've already created for this demo. So first let me go to from the bucket, because in this bucket I'm going to store all the files which have been uploaded. So first, so you can see already there was a doc1 and right now another file has been uploaded, and also because it is the same name, the file will be overwritten with another name of the current time and the file name. So we have uploaded one more file. Let me show how it works in Elastic Beanstalk too. So it is the same operation, the same code in Elastic Beanstalk. So let me upload another file. So I'm uploading this photo here. So I upload it and the file has been uploaded successfully. So in S3 now, if I reload it, and you can see that file has been uploaded. So the final output is going to be, so we go to the bucket image. So you can see I already had two images and now there is another image which we uploaded already in the bucket, from the bucket. So here you can see to the bucket PDF, and if you go inside you can see the doc1, and this one was uploaded from this local host. So you can see here that it has the same name as this one. So it is exactly the same file which was uploaded here and it was copied to that bucket. So how did we do that using AWS Lambda? That we'll see in this session. So first let us learn the theory concepts of this session and then we'll move on to the hands-on part. So come on, let us go. Okay guys, now let us begin with the session. So typically an application comprises of three components: the front end, the back end, and the database server. Before the cloud technologies emerged, when a company wanted to host their application, what they did was they used to host all the software components, that is the front end, the back end, and the database service on an individual server. So what happens here is, whenever you want to do an operation, like consider this website is for storing photos like Google Photos. So you upload a photo and then press the button upload in the website. So what happens now is the website does not process. It goes to the backend service. So whenever you click something here, so the process goes to the backend code. Some code is triggered. So what happens is that code runs, and after that, if you wanted to upload the photo, it will store somewhere. It will use the backend's help and it will store somewhere and it will show the response in your website. Also, there needs to be information stored in the database because there is a name for the photo, there is a link where the photo is stored, and also there will be other properties like size and something else. So they will be stored in the database service. So what happens here is all the software components are hosted in an individual server. Whenever you wanted to do an operation, you click some button or do some operation on the website, which will trigger a service in the backend. So that will happen, and if there needs to be any data stored, it will be stored in the database and the output will be shown on the website. But what is the problem with hosting all the software components on a single server? The main problem is it has limited resources. So let me explain this. So consider your website is getting a lot of traffic and it is using 80% of CPU's resources. And at the same time, the backend service needs 50% of the CPU's resources to run operations in the backend. So what happens here is
Front-end service uses 80%, but the back-end service only gets 20% of CPU's resources to work on. And if a database service wants to use some resources, there are none left for it to use. So right now, the system falls under a deadlock, and the whole server will be in a problem. So what happens is they cannot be scaled, and also this is the reason why the websites get crashed. Hosting all the software components on a single server is quite easy, but it comes with all these possible drawbacks and demerits. So what is the solution for this? Let me provide you the solution with an example. Let us see that. So the solution to this is using a distributed application architecture. So what is a distributed application architecture? It is basically using dedicated servers for each of the software components. The front-end software component is hosted on its own dedicated server, so does the backend and the database. So the front-end server only hosts the website, the backend server only does the backend operations, and the database server only is used when there is a need for the database service. But how does this improve the situation? So let me explain that. Consider the backend service under a lot of traffic or workload. So what happens now? Basically, in an individual server, when all software components was hosted, so what happened there was backend server will consume most of the CPU resources, and the other services will not have enough CPU resources, which leads to a crash. But what happens here is only the backend server will be having workload on that. The other two servers will be left unharmed. So considering the backend server has used all of its resources and has crashed, the other two servers will not have any harm on them. The front-end server will still be hosting the website, and the website will be still visible to the users. Even though the backend services won't be running at the current time, the users will not be able to use the services provided by the website, but the website will still be visible on the browser. So how does this solve the scaling problem? In this particular architecture, you just have to scale the particular servers which you want to scale. Actually, so here we consider that the backend server is using all of its resources, and you only want to scale that particular server. So you can just do that. You can just scale your backend server instead of scaling all the three components. Obviously, this is going to reduce a lot of cost and time. And for example, if you want to only increase the space for your database service and you want to scale your database service, you can just scale that. So to understand this better, let me give you a real life example. Let us consider Google Photos as the example. So here you can see the website. So this is the front-end server, and the images which are being retrieved are using the backend service to do that. And also the links for these images, the data, that is the name of this image, the size of the images, are all stored in the database service. And whenever to retrieve this particular image, the database service provides the link, and the backend service will use that link to show the image to us. So let us consider this, and let me explain how all these services work together. So whenever you search anything on the search bar, so I have two images named hello and hello yes. So I'm searching hello over here. You can see there is photo ID over here 1 and 2. So the names are hello and hello yes, and the site links are this. So this is the site link for the first image, this is the site link for the second image, and the backend service retrieves these information and it will produce it over here. So this is how the front end, the backend and the database services club together. So now we have learned what is a distributed application architecture and how the front end, the backend and the database works together. So now let us move on and see what is AWS Lambda. So AWS Lambda is a serverless compute service, which means you don't need to worry about servers while building and running applications. You will just have to code as per your needs, save it in Lambda and relax. It will take care of everything else like provisioning servers. We will learn more in depth as we move along. So now, what distinguishes Lambda from EC2 and Elastic Beanstalk? They all are compute services, right? But there is a difference. Let me give an idea about that. First, let us compare Lambda and EC2. Later we will move on comparing it with Elastic Beanstalk. Let me start with the first difference. Lambda is a platform as a service, while EC2 is an infrastructure as a service. In Lambda, it provides you a platform to run and execute your backend code, but in EC2, it provides you virtual computing resources. The second difference is that Lambda restricts to a few languages like Python, Java, C#, and a few more. No restrictions in EC2. You can install any software you want in the platform given to you. And then you can choose the environment like Node.js or .NET and push your code into it in Lambda, but not in EC2. In EC2, you have to decide the operating system and then install all the required softwares, and then you have to upload your code or code internally and then execute. And then moving on, Lambda does not provide you the luxury of choosing OS and runtimes, but in EC2 you can configure every single aspect like different instance types and security preferences. So this is what makes them different. I hope you understood the difference between these two services. Now let us discuss what distinguishes Lambda and Elastic Beanstalk. Let me start off with the first point. Lambda can only run your backend code, while Beanstalk can run your entire application without you worry about the infrastructure which it runs on. Secondly, Lambda provides resources based on your workload, but in Beanstalk you have the flexibility to choose the instance type and other configurations. In Lambda you don't need to worry about any configurations or instance types. So the last difference is Lambda is stateless system and Elastic Beanstalk is a stateful system. So what is the difference between them? A stateless system is when the output is based only on the current inputs, not using any other inputs which were stored before. But in a stateful system, it may provide different values for the same inputs by comparing the older inputs. Being stateless provides Lambda the ability to create millions of process threads and execute them all with different inputs simultaneously. Okay guys, now we understood how does EC2 and Elastic Beanstalk services differ from AWS Lambda. Moving on, we'll first take a look at benefits Lambda provides and the limitations of Lambda. First, let us look at the benefits provided by Lambda. Later, we'll move on to the limitations of Lambda. The first benefit is that it provides a serverless architecture. So you don't need to worry about provisioning and managing servers. You'll just have to concentrate on building and running the application. So to be very simple, you will be given a console. You choose the language, write your code and hit run. It chooses an EC2 instance according to the required processing power. The next point is code freely. There are multiple programming runtimes and editors, so you can just choose it freely and code it in like how you do it in an offline editor like in Visual Studio or an Eclipse. The next point is no virtual machines needs to be created. You don't need to create and configure any EC2 virtual machines. As I already told, they are provided by Lambda according to the processing power needed for your function. The next point is pay as you go. Pay as you go is a feature provided for all services in AWS, and what is here is in Lambda you will be only charged for the number of seconds your Lambda function runs on for the particular seconds how many services have run, and that's it. You won't be charged anything more. The fifth point is monitor your performance. You have a default monitoring option in Lambda which is connected with CloudWatch and this particular Lambda function which generates multiple logs and metrics for you to visually and textually understand what is going on in your Lambda function. So whatever advantages a service provides, there will always be some limits to it. So now let us take a look at the limitations of AWS Lambda. The first limitation of AWS Lambda is the maximum disk space provided is 512 MB for the runtime environment. This means the /tmp directory storage can only store 512 MB at the same time. Why do we need /tmp directory storage in Lambda is that because we need a temporary storage for storing the current Lambda function's inputs and outputs, because the same Lambda function, there is no guarantee that it will execute 2 or more times. The next limitation is that the amount of memory available for Lambda during execution is 128 to 3008 MB. So this is the amount of RAM you can choose between either 128 or 3008, and between that it is a 64 MB increment like 128 plus 64, and it keeps on adding. The third limitation is that the function timeout is set only to 900 seconds. So the maximum amount a Lambda function can execute is 15 minutes and the minimum is 3 seconds. So if you want your Lambda function to execute more than 15 minutes, that is not possible. It can only execute to 15 minutes and the default is 3 seconds. So maybe your Lambda function's execution completes in 1 second, but it has to run at least 3 seconds to stop. The fourth limitation is that the only available languages in Lambda editor can be used for writing the code. The languages are like Python, C#, Java, Node.js, Go and Ruby. Okay, alright guys, we've seen the pros and cons of AWS Lambda, so now let me give you a brief idea on how Lambda actually works. Okay guys, now let us move on. So first, what you do is you write your code on the Lambda editor or upload it in a supported programming language in a zip file. So it is not that you have to create only one Lambda function. You can create any number of Lambda functions your application needs. And after that, the Lambda executes the function or the code in your behalf. You don't need to run it. So, but to run the code, you need to trigger the Lambda function, right? So how do you trigger it? It doesn't run automatically. You need an external AWS service which can trigger and invoke the Lambda function. So for example, it can be an S3 bucket or a database. So what happens is whenever a write operation occurs in the database, your function should be triggered. So you set that as a trigger, and whenever a new record has been uploaded or inserted in the database, the Lambda function will be automatically triggered and retrieve the information which you need from that. So after that, we know that the Lambda code is running, but where does it run? It needs a server or a computer to run, right? So what it does is it provisions servers and also monitors and manages it. So how does it provision servers? So Lambda functions have various types of code. So if your code requires a lot of processing power, it will choose an instant type which has more processing power and RAM. Or else if your Lambda code only executes for 2 seconds, it will choose the lowest possible instance. This will save you money and time. Okay guys, now we understood how Lambda actually works. So what are the various concepts in Lambda? Let us look into it. So now we are going to see various concepts in Lambda, and the 4 concepts you are going to see is functions, runtimes, layers and log streams. So what is a function? A function is a script or a program that runs in AWS Lambda. So the Lambda, whenever it is invoked, this function runs. So you can see here, this is the function name, and here you write the code. So the function processes the event and returns a response. So let us see some function settings. So here you can see the code. The code is the logic you use in the Lambda function, which you write over here. And then runtime. Lambda runtime executes your function. So whatever runtime you choose, that particular code it will be written here. So that will be executed by the Lambda's runtime. And then the handler. The handler is where you mention the function's name with the file's name. So whenever the Lambda function is invoked, this particular function is executed. And then tags. Tags are key value pairs which you can mention for any AWS service just to track their cost or track their metrics. And then description. Description is describing a function which you can give while creating a function in Lambda. And then timeout. You have to set the timeout between after 3 seconds to 900 seconds, because that is the capacity or that is a timeout period for a function which I've already discussed in this session. So let us move on with runtimes. So what is a runtime? A runtime allows functions to run in different languages in the same base execution environment. That means in the same environment you can run a Python file, a Java file and a Node.js file. And this runtime sits in between the Lambda service and your function code. So it is in between. So whatever code you send, there are multiple runtimes, and it will choose the correct runtime for your file. If it is Python, it chooses Python runtime. If it is Java, it chooses the Java runtime, and it runs and gives you the executed response. So also see, you can take a look at multiple various runtimes. So these are the latest supported runtimes, and these were already announced. So first it's .NET Core 2.0 C#, so and then Go programming language, and then Java, Node.js, Python 3.7 and Ruby 2.5. And the other supported languages are Node.js, but an old version 8.10, and Python an old version of 2.7 and 3.6. Okay, now let us see what are layers. Okay, so Lambda layers are a distribution mechanism for libraries, custom runtimes and other dependencies. So instead of downloading using the code which you write in your Lambda function, you can create layers and store those particular libraries or custom runtimes which you want to run your program in, and you can store it in multiple layers and you can create only 5 layers for a particular Lambda function, and you can upload it so that there is no confusions while the code is choosing a particular library or a custom runtime. For example, if your code needs to run a particular library which it needs for uploading information to an Excel sheet for a CSV file, so what you do is you upload that particular library to a layer, keep it in order so that your code chooses the appropriate layer and gets out the libraries. So after that, also your layers lets you manage the in development function code independently from unchanged. Like, you don't need to change your code or resources that uses. You can just upload the information in a zip file as layers and take information out of that, and you can create multiple layers. The maximum number of layers is 5 per function, and you can use layers which is provided by AWS customers or already available layers, or you can create your own layer. And then comes the log streams. This is the part where you monitor the Lambda function. So normally, Lambda automatically monitors your function invocations and reports metrics to CloudWatch. If you don't want to just watch metrics, you can write the code in your Lambda function so that you can get logging statements for each and every step your function goes through, and you can look at the execution flow and how your Lambda function is performing and whether it's working properly or not. So moving on, now let us see how AWS Lambda works with S3. So here we're going to see how exactly an operation in the S3 bucket can trigger the AWS Lambda function. So consider a user is trying to access a website which you can use to upload photos. So if you upload a photo here, it will be stored in the AWS S3 bucket which it is connected to. Also, whenever a put operation occurs, that is, when file is uploaded to the S3 bucket, the Lambda function will be triggered. So for example, you can use it as a put operation or a get operation. So consider it is a put operation for now. So whenever the user is uploading a photo here, so it gets uploaded to the S3 bucket, and when it's uploaded, the Lambda function is triggered. So the Lambda function's code can be anything. You can make any microservice out of it. So if you want to store the file's name and the location, you can store it in the database using the Lambda's code, or you can watch the CloudWatch metrics, and you can also look at the logs which you have coded in the context of your program. So after that, you can also copy this particular file into another S3 bucket using your Lambda code. Also, if it was a get function, like if it was a get operation, if the user is trying to download a photo, again the photo will be downloaded, which is from the S3 bucket which is stored there. So you can use that also as a trigger in the Lambda function, and you can make any microservice out of it. So this is how S3 is used as a trigger with Lambda functions. So now we understood how this works theoretically. So now it is time to move on for practicals. So now let us do an hands-on on creating an S3 bucket and then using a Lambda function to copy it to various multiple S3 buckets. So why does it go to various multiple S3 buckets is because we have mentioned a different type of file extension. So if it is an image, it goes to a different bucket. If it's a PDF, it goes to a different bucket. So whatever the file extension is, it goes to a different bucket. So let me explain that part now. Okay guys, now we are going to do a hands-on using multiple AWS services. So let me show you what we are going to do exactly before moving on with the hands-on part. So what we are going to do is, I already told you how Amazon S3 works with AWS Lambda. So what we are going to do is, we are going to create a simple website which can upload a file to the S3 bucket, and whenever a file is uploaded to the S3 bucket, the Lambda function is invoked. So what happens is, we are going to upload 3 types of files. One is a .jpg file, a .pdf file, and a .txt file. So whenever an image file is uploaded, it goes to the image bucket. Whenever a PDF file is uploaded, it goes to the PDF bucket. And whenever a text file is uploaded, it goes to the text bucket. And we are going to do this all with a simple Lambda code. And what we are going to do is, we are going to use the S3 buckets uploading, that is put as or post as a trigger. And whenever an object is uploaded to the S3 bucket, the Lambda function will be triggered. Okay guys, now let us see this on the AWS Management Console and how to do this practically. Okay guys, at the beginning of the video I told you that I'm running this file both on the local host and the Elastic Beanstalk. So to understand it better, first let me explain the local host part. So Let me show you the code first. So this is the code. There are two files. One is index.php and the other is filelogic.php. So let me briefly explain this. This is a simple form which has an input and a button. So input is you click on a file, and button, whenever you press the button, it uses filelogic.php to execute the uploading to the S3 part. So here I'm mentioning the bucket which I'm going to upload to, and here you can see my credentials. So this is my region and version I've given latest, and these are my secret keys and the key which I have, so that it can access my AWS account and that particular bucket in my AWS account and upload it over there. So here you can see if that particular object with the same name exists, what it does is it adds $time in front of it. So if that same file exists, what it does is normally if it does not exist, $key will be just $key. But if a file exists in the same name, if doc1.pdf and I'm again uploading doc1.pdf, so it takes the current time and adds it in front of the file name. So this is why we saw in the beginning of the video there was one doc1 and it had another doc1 file with a time duration in front of that. So now we have seen this code. Now let me show you the Python code which is used for the Lambda function. So in the Lambda function, using that, we are going to send this particular objects from one bucket to various buckets using their extensions. So let me explain that also briefly, and let us move on to how to do this using the AWS infrastructure. So this is the Python code, and first I'm importing some things which I need actually. So I'm importing JSON, I'm importing os.path. This is for getting the extension, and I'm importing Boto3. This is mainly important because Boto3 is the AWS SDK for Python. This allows Python developers to build and run applications on AWS using this. So you can write Python applications using Python programming language when you include this particular Boto3. So, and I'll explain this briefly. So this is the source bucket. I'm getting the name here. This is the file name. I'm getting it here. And copy source, I'm giving bucket, source bucket and key. So this is why I imported JSON. So I'm recording the copy source as the bucket which I'm going to upload it from, and this is the object which is going to be uploaded, and this is CloudWatch info. So if I print it over here, it will be available in the CloudWatch streams. Like you can go to that log streams and check out these things when the function has started. So when the function started, this will be there, and after that this information will be given. So, and then here comes the logic. The logic is pretty simple. You first check whether the object exists. If it doesn't yet, check whether extension. First you get the extension or the last 4 characters, that is either .jpg, .pdf or .txt. So even if it is a file with a different extension, if it is a .png, the file will only be available in that particular bucket. It won't be copied to any other bucket. If it is .jpg, it will go to the bucket image. If it is PDF, to the bucket PDF. If it is txt, it will go to the bucket txt. So s3.copy object, bucket, this is the destination bucket, this is the file name, and this is the copy source, that is the file which you're going to upload from the bucket. That is, from the bucket is the name of that particular bucket. So also if it does not exist, so this will be printed in the CloudWatch log stream. Okay guys, now we've seen the code. Let us move on to the AWS implementation part. Okay guys, let us start from the beginning. So first you have to go to the IAM management console because you have to create a role. So first thing you have to do is you create a role. I've already created a role test. So I'm going into that, and you have to attach a policy. And I've created a policy already, which is s3_move. So you have to create a policy and use this particular JSON code inside it. So I'll explain what this means. So I'm giving effect allow, and also over here. So here I'm giving the actions logs, create log group, log stream, and events. So I'm allowing all these events to happen in the CloudWatch whenever I'm using this particular policy. So in S3 I'm allowing all operations like post, get, put, whatever operation it is, I'm allowing it to happen. So I'm giving effect as allow. Also they should have a unique resource name, so I'm providing that. So without this particular policy and role, you can't do this. So you can't basically do what I'm going to do right now. So we cannot copy S3 buckets objects into multiple S3 buckets. So you have to create this role and policy and use it in the Lambda function. So the first thing we are going to do now is we are going to create 4 different S3 buckets. One is from the bucket, which is the main source bucket, and we are going to create 3 more buckets which are for image, PDF and text. So let us do that. Before moving on with the S3 part, let me tell you how to do this without copying and pasting this JSON code over here. First, you have to create a role which lets Lambda call other AWS services. So here, after clicking on create role, you have to choose Lambda so that it can be calling other AWS services. And next, you have to give it permissions. You can see here there are a lot of permissions, that is, there are policies available. So before we created a policy S3_move, and we pasted that JSON to allow access to CloudWatch logs and S3. So what I'm going to do now is I'm going to give full access for S3 from searching here. So I searched S3 full, so I got full access for S3, and I'm searching CloudWatch full. So here you can see I got CloudWatch full access too. So I gave both. So next I'm going to tag, so I don't need any tag. So I'm reviewing. I have to provide a role name. So I'm going to give this as practice because I'm not going to attach this. I'm just explaining you how this is going, how to create a role and how to attach policies to it. So you can see here there are 2 policies attached: Amazon S3 full access and CloudWatch full access. So what I'm going to do now is I'm going to create this role. So I've provided create this role, and now the role has been created. And as I showed you before, here you can see this, and also I can go into the policy and show you the JSON part. This allows all the actions for S3, and the other policy allows all CloudWatch actions. See, you can see in the JSON. So you can see here it allows everything. So it allows all CloudWatch actions. So that is what I wanted to show you. Now let us move on with the S3 part. So I'm opening the S3 management console. So I already have a bucket. This is for a beanstalk I created earlier. So now let's create 4 more buckets as I told you already. So first bucket is from the bucket. So this is what, so you don't need to configure anything. You don't need to give any tags. So you just click next and it already sets permissions. So block all public access, and also if you want you can review it once and then create bucket. So this is how you create a bucket. It's actually pretty simple. So then I'm creating to the bucket image.
Let's have a quick quiz question, guys. And the question is, what is AWS CloudWatch used for? And your options are monitoring and logging of AWS resources and applications, securing access to AWS accounts and resources, managing and scheduling containerized application, managing and scheduling containerized applications, or analyzing big data and running complex queries. Please mention your answers in the comment section below.
Just a quick info, guys. Intellipaat offers advanced certification in DevOps and cloud computing in collaboration with IIT Pravartak, a technology innovation hub of IIT Madras. This online advanced certification in DevOps and cloud computing by IIT Pravartak will help you gain expertise in DevOps, access management, DevSecOps, Terraform, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel. The link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take your first step towards career growth in the field of cloud and DevOps.
And I've created that. Okay. Next thing is I'm creating to the bucket PDF, and I'm giving next, and create bucket. And finally I'm creating to bucket text. So I'm giving next, and I've created buckets. So right now we have created 4 buckets, the 4 buckets which we need, which is in the code for us. So what I'm going to do now is I'm going to move on to create a function in the Lambda. So first what we'll do now is we'll go to the Lambda management console and create a new function. So you can see here I already have a function. So let me create a new one. So author from scratch, use a blueprint and browse serverless apparatus or repository. So using a blueprint is that there are already many things. So here S3 get object Python, config rule change triggered. There are many things. So what we are going to do is we are going to author it from scratch because we are using our own code. So I'm giving the function name as AWS Lambda, AWS Lambda demo, and I'm writing my code in Python, so I'm giving Python 3.7 as my runtime. And another thing, so what I told you, we have created a role and attached a policy to it. So we have to use an existing role here. So the existing role which I told you was test. So I'm using that particular role here. I'm creating the function. So the function has been created successfully. So what we have to do now is I'll first explain the dashboard. So here is the configuration and here is the monitoring. So you can see CloudWatch metrics and CloudWatch logs insights. So right now it is loading. So let us see. So it will be empty right now. After the function starts executing, then we can see some data over here. Also we can see the logs in CloudWatch. Let me show that later. So first we'll configure it. So first I'm adding a trigger. Our trigger is going to be S3. So also what I'm going to do is the bucket is actually from the bucket. So whenever an object is uploaded to from the bucket, it has to be triggered. So our bucket is from the bucket, and here I'm put post or copy. So however it may be, if an object is uploaded to from the bucket, it triggers and the function starts executing. So it is all object create events. And here I don't need to give anything. If you just want to copy one particular suffix, like if you want to copy only JPG files, then you can mention it over here. So right now I'm implementing that in the code, so you don't need to give that. Also give enable trigger here and add it. So this trigger will be added. So you can see here trigger has been successfully added. Okay, so the next thing is now we have to use the code here. So you can already see there is a code written, a simple code. So let us consider this as our runtime right now. So the runtime is Python 3.7. This is the editor to edit the code. This is the handler which I showed you. So lambda function underscore lambda function dot lambda handler. So even my definition, even my function's name is lambda handler. So I don't need to actually change anything over here. So let me copy that code and paste it over here, and let us save this particular lambda function. So I'm going here, I'm copying this code, I'm pasting it over here. So the code has been copied. So you can see the imported function, imported libraries, and here is the print function, and here is the CloudWatch info, and here is the logic to copy from S3 to another S3 bucket. So now let us save this. So once we save it, it is saved. So now whenever a object is uploaded to the S3 bucket from the bucket, then this process will start happening. First, let me show whether it happens or not. So you can see here from the bucket is empty, and to the bucket image is empty, and even these two will be empty because we just created them. So right now I'll manually upload a file to from the bucket. So I'm adding files, I'm adding this image, I'm providing next, and upload. I'm uploading this file to from the bucket S3. So you can see here that the file has been uploaded. Now let us cross check with to the bucket image. So it has to be uploaded to the bucket image because our lambda will be triggered right now, and that function will be running, and this process would have happened. So I refreshed it, and you can see panda.jpg file has been uploaded here. So right now it manually works. So what I have done is I've created a simple web page which can upload files to S3, and then the process happens automatically. So what we are going to do now is we are going to create the same web page which was running in the local host. Now we are going to make it run in the Elastic Beanstalk using a URL. So anyone can upload a file right now, and it gets segregated according to the extension, and it gets copied. So I told you after execution of the function, you can see the CloudWatch metrics. So let me go to monitoring. So here you can see CloudWatch metrics, and here you can see some data. So this is invocations 1. So the function has run one time, and the duration was The duration is given here, and also the success rate was 100%. There was no errors, so you can see that here. Also, let me show you the logs. So a log has been created. I'm opening that, so you can clear. So function start CloudWatch. So let me open the code first. Okay, so here function start CloudWatch, and you can see the details being delivered there. So log stream name, log group name, request ID. So log stream name, log group name, and request ID has been. So after the request ended, it is ending the report, and the report has been sent. And you can see here it took 566.10 milliseconds, and duration was 600 milliseconds. So it is rounded. So memory size, the maximum memory size was 128 MB. So there was no more memory needed for this function. So now let us move on with Elastic Beanstalk, and we'll create and deploy a Elastic Beanstalk application over there. So let us get started. So let me click on get started. So first thing I have to do is I have to create an application. So my application is going to be AWS Lambda demo, and I have to choose the platform. So my code was in PHP. If your code was in any language, like if it was in Java or Go or Python, you can choose that. So right now I'm choosing PHP. What I'm going to do is right now I'm going to create the application. Later I'll upload the code to make it more clear. So the application is creating right now. So it would take some time. So let us wait and start the processor. Okay guys, now you can see it has been created successfully. So let me show you what actually is there before we do this. So there is a default PHP page over there. So this is a default PHP page, and what we're going to do is now we are going to upload and deploy our application here. Before that, let me explain what actually there is a little change in the code, because okay guys, before uploading our application and deploying it, let me show you and explain you the simple change which I made in the code. So this is the code. So here you can see index.php. So there is no change in this, but in filelogic.php you have to change the path, because you're going to upload it to an Amazon Linux environment and the path changes there. So it is /var/app/current/your file. So index.php and filelogics.php will be in this directory, and whatever file you upload to Elastic Beanstalk will be in this directory. So what I'm going to do is you have to click on all the files and choose over here, and you have to archive it into a zip file. So if you ask why should we zip it rather than make the file a rar file or a tar file, because Elastic Beanstalk environment only accepts .zip files. So you can just do it in a normal way. Instead of using WinZip, you can just click on them and you can just send them to a compressed file, which will automatically create a zip file. So I've already done that. So now let us upload this file to the Elastic Beanstalk. So let us upload now. So I click on this button. So I have to choose a file. So what I have to do is I have to go back. I go to AWS demo. So this is the file which I have to upload. So AWS uploads file logic and index files are within this particular zip file. You should not create a file on top of this and give that. You have to create a zip file just clicking on these files. So I'm opening it and I'm naming it as AWS Lambda demo. So it is AWS Lambda demo. So I'm going to deploy this. So deploying it takes time. So let us wait until then and we'll check out how our application works. Okay guys, now our file has been uploaded. You can see the running version is AWS Lambda demo. This was the name which I gave for this particular application. So now let me open the URL and show you the website which is running. So here you can see our website is running fine. So what I'm going to do now is I'm going to upload few files to this and check whether it gets uploaded in our S3 bucket and it is moved to the respective S3 buckets for image, PDF and text. But before uploading, let us check whether the S3 buckets are empty or not, so that to make sure that there were no files before and only the uploaded files are getting uploaded right now. So I'm going to, from the bucket, it's empty, and I'm checking all the other buckets just to make sure. Okay, now all the buckets are empty. Now let us upload few files. So I'm going to upload 3 different types of files and check whether each of the file goes to its respective bucket. So first I'm going to upload a PDF. It is successful. And then I'm going to upload an image and it is successful too. And then I'm going to upload a text file. So first let us check whether all these files have been uploaded here. So now we can confirm that the doc1 PDF, doc.jpg and text1.txt have been uploaded to the S3 bucket. So now let us check whether each of the respective files with different extensions get uploaded to their dedicated S3 bucket. So first let me go to the bucket image. Let me refresh it and you can see the .jpg file over here. So next to the PDF bucket and you can see the PDF file over here. And then finally to the text bucket and I'm refreshing it and you can see the text1.txt file over here. So right now our Lambda function is working and it corresponds with whenever we are uploading a file through the Elastic Beanstalk. So Elastic Beanstalk is successfully running our application and it gave us an instance to run it on. So whenever you upload a file using that, our files are getting uploaded from the bucket and Lambda function is triggered, and using this particular logic, if it is to the bucket image, it goes to the bucket image and then PDF and then text. So this is what happening in our hands-on. So before finishing this hands-on, first let me explain the complete process which we did to make this happen. So first we created a policy and first we created a role and we attached a policy to allow all the functions which we wanted to do in the S3 bucket. So and then we created 4 different S3 buckets, 1 for source, 3 for destination. And then we created a Lambda function and we uploaded a code which basically copies from one particular S3 bucket to a S3 bucket which we give the destination name. And we also created a trigger for S3 which is whenever an object is created. So from S3, from the bucket, whenever an object is created, this particular trigger happens and this function code runs. So this function code runs. So whenever this function code runs, what happens is a file from the particular source S3 bucket is copied to the destination S3 bucket. And then what we did, we launched our application, we uploaded our local application into Elastic Beanstalk and we deployed it, and we right now have an URL to run our application. So then now we are going to see CloudWatch. So let me refresh it once more. So we've uploaded multiple files after that and you can see there are multiple logs over here. So this was the first time, and then you can see whenever the next time the function is coming as function start, and that is the next function. So the function will be keep on running. So you can see log stream name, log group name, request ID. This is one particular function execution and this is one particular function execution. This is one. So the function has been executed this many times and the function was started at the first time. So this is how we have to use CloudWatch. Also, you can see the CloudWatch metrics over here in the monitoring tab. So here in the monitoring tab in CloudWatch metrics, now you can see there are totally 5 invocations. So the CloudWatch has been invocated 5 times. That means the function has been run 5 times. And here you can see the success rate. The success rate has been 100% and there are no errors because all the files which we were uploading got uploaded and the function never got any errors and it ran successfully. So right now I hope you guys know how to use Lambda to write a code and use that and use other services like S3 as a trigger to run your particular application. So right now we've learned multiple services. We learned IAM so that we have to create a policy first and then we know how to create S3 bucket. We know how to write code in a Lambda editor and then we know how to use CloudWatch, log streams and also metrics, and also we learned how to upload your local application into Elastic Beanstalk so that you will get your own URL. You can access it from anywhere in the world.
So use cases of Lambda. There are various use cases of Lambda, but right now we'll discuss 3 of them. So the first one is the serverless websites. The second one is the automated backups, and the third one is filtering and transform data. So let us see serverless website. So I already told you what is a serverless architecture. A serverless architecture is where you just have to code and it automatically takes care of provisioning and managing servers and its infrastructure completely. So what you can do here is you can host your static website on S3. Your static website is basically HTML, CSS, JavaScript or TypeScript files. It cannot run server-side scripts. You can only run client-side scripts. So in server-side scripts like PHP and ASP.NET cannot be hosted on S3 as a static website. And using S3 for static hosting is very cheap. And you can write Lambda functions and connect them with the S3 to correlate it. You can make your static website available using AWS Lambda by writing some code so that the users can keep track of any resources which is being used on the website. So next is automated backups. So the word says you everything. The sentence, the automated backups, you can automatically create backups. You can create Lambda events and schedule them at a particular time on a particular day and create backups automatically in your AWS accounts. So to create backups, you can check whether there are resources idle and take those content and just back it up and delete it from that particular place. And also you can generate reports using Lambda in no time using code or just connecting it with CloudWatch. So you can generate every report and you can see how much of data has been backed up, how much of data has been deleted, and you can manage it very easily and schedule it on time. So the third use case is filter and transform data. So you can connect Lambda with other Amazon services like S3, Kinesis, Redshift, and database services like RDS, DynamoDB, or Amazon Aurora. So you can filter the data before sending the data to any Amazon storage service or database service. You can filter them using the code, and you can easily transform the code and load the data from between Lambda and to all these services. Now let us discuss Lambda pricing. First, let me explain what is free tier. Free tier is provided by AWS for a 12-month period, and in that period you can use free services which are provided by AWS. You can use free tier eligible services. You can use services like EC2, S3 and even Lambda for free, but they have their own limitations. For example, in Lambda, you can use 1 million requests per month or 400,000 GB seconds of compute time per month for free, and anything exceeding that will cost you. Also, you might be guessing what is GB seconds and 1 million requests. 1 million requests is when the Lambda function is triggered 1 million times, and GB seconds is gigabits, that is 1000 megabits per second, that is the transfer rate. So 400,000 GB seconds of compute time per month is allowed. 400,000 GB seconds of transfer time is allowed per month for any given Lambda function. And then requests, as I told, 1 million requests are free, and then after that each 1 million requests costs you $0.2. And after that duration, I already told you what is GB seconds, so 400,000 GB seconds per month is free, and after that every GB second you use will cost you the number which is given there, that is $0.000166667. So that is all about Lambda pricing.
Just a quick info, guys. Intellipaat offers advanced certification in DevOps and cloud computing in collaboration with IIT Pravartak, a technology innovation hub of IIT Madras. This online advanced certification in DevOps and cloud computing by IIT Pravartak will help you gain expertise in DevOps, access management, DevSecOps, Terraform, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel. The link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take your first step towards career growth in the field of cloud and DevOps.
Hello everyone, welcome to this session on deploying an end-to-end website on AWS. Today in this session, I will be taking you through how you can basically deploy a website which will be also interacting with databases and a service called S3 on AWS. Okay, so without any further ado, guys, let's go ahead and get started with this session. So let me first tell you what we are basically going to deploy today. So guys, we are basically going to set up something like this today. So we as a user, we will try to go to a URL like this, www.awsproject.tk, and this domain should basically route us to our website. Okay, now what will our website be able to do? Let me quickly show you. Right, so I have a website on my local host, right? So let me see if I can show you that website. So 1 second, let me go ahead and launch this website once. Okay, now in order to launch this website, what I'll have to do is I will have to install some packages. So let me go ahead and install them. So I will have to install PyMySQL. Let me see if this makes it running. And okay, so what we have to do is we have to deploy this website, and the way we are going to architect our website is going to be something like this. Okay, so first of all, we will configure this domain to connect to our virtual server that we are going to launch, right? And the way to do that would be using the Route 53 service on AWS. Okay, now our website will be able to upload objects onto Amazon onto a storage service called S3, right? So our website, whatever images that we are going to upload using our website, it will be uploaded to an object store called S3, from where you will also be able to see that the objects are getting uploaded. And at the same time, the entry for this will also be stored inside a MySQL database, which is going to be inside Amazon RDS. Okay, so guys, this is what we are going to deploy today, and we are going to go ahead step by step. So first, let's go ahead and start by setting up our website. So first, let's deploy a database, a MySQL database on AWS. Now, the way to do that is by making use of a service called Amazon RDS, right? So let me first go ahead and switch to my AWS Management Console. Okay, so guys, this is what my AWS Management Console looks like. And now what I'm going to do is I'm going to go ahead and click on EC2. So we are going to deploy our database first. So let me go ahead and select RDS. Okay, so you just have to type in RDS over here, and it will basically make you go to the RDS service. Now, once you are over here, this is how the RDS dashboard looks like. Once you are over here, you will have to click on something called as Create Database. Just click over here. And now what you will have to do is you will have to click on, so this is standard create. This is going to be automatically selected for you. In the engine options, you will have to select MySQL. So let's select that. And now with MySQL selected, just scroll down and you can select the MySQL version. Okay, now you can select any version that you want. I'm going to leave it at default, which is 8.0, and scroll down to select the template in which we want to deploy. Right now, since we are practicing on our AWS account, what I recommend is for you to basically deploy everything in the free tier. So just select free tier over here, right, and then scroll down. And once you have reached here, what you'll have to do is you will have to go ahead and specify your database. How will you basically identify this database server? Okay, so let's say we give this name to be employee database, because our website is basically going to be an employee website about how we can basically upload data of an employee onto our website. This will be about that. So let's name our database also employee, right? And now let's go ahead and specify the username and the password. Okay, so let me specify the username as Intellipaat, and let me specify a password as well. So let me go ahead and specify the password. Okay, so I've given a password, and now what I can do is I don't have to choose this, because this is basically which kind of machine do you want to launch. So the machine that we want to launch is going to be t2.micro itself, so we are not going to touch this, right? Because this falls under the free tier, and this is automatically selected for me when I choose the template as free tier above. Okay, now the next thing that I might have to see is auto scaling. So auto scaling basically means if you get a lot of load on your website, should your server become 2 or 3 instead of just 1. So we do not require that as of now, and I think it is a little advanced for you as well for this class, so we are not going to select this option. Okay, then which network do you want to deploy it in? So we are basically going to deploy it in the default network for now, so we are not going to touch this. And it is going to be a password authentication, which is fine for us. Is it publicly accessible? So yes, it will be publicly accessible, which means it will be available on the internet for us to work with. Okay, so we have selected yes over here, and next we will have to change nothing else. We can just now click on create database, and my MySQL is now basically getting automatically created. Now, if you would have noticed, if you were to do this on your own, and by that what I mean is if you were to not use any cloud provider, and if you were to deploy a database server, you would have to do a lot of things. So first of all, you would have to launch a server, then you would have to install MySQL manually on it, right? And then configure it to basically allow internet connections from outside. But that is not something that you have done for now, right? What you have done is you have just gone through a dashboard where you have selected the right options, and then you have just clicked on create database. Now whatever is going to happen now is automatically going to be managed by AWS, and that is why this service, the service which we are using, which is Amazon RDS, is a managed database service, which basically means everything from deployment, everything from installation of the database, everything is taken care of by AWS, and we don't have to do anything in it. Okay, so now this is getting set up, so let's wait for some time and let's hope this gets set up soon. If we come back to our slides, what we need to next figure out is our S3 bucket, where our data is going to be uploaded. And now what we are going to do is we are basically going to create a bucket for us where all our data will be uploaded. So coming back to my AWS Management Console, what I can do is I can just search for the S3 service over here, click on it, and now I'll be taken to a S3 Management Console. Okay, now on the S3 Management Console, what I'll be doing is I'll be creating a bucket. So let's create a bucket and let's call it employee. Let's call it add employee. Okay, and this will be in the Ohio region, US East 2, which is great, right? Nothing else we are changing. We're just clicking on create bucket. Now it's very important to take note of where your bucket is being deployed. So our bucket has been deployed in the Ohio region, and if you talk about our RDS, that will also be deployed in the Ohio region itself. So we can check that quickly. If you go to RDS again, how can you check which region you have basically deployed your resource in? You can check it in the URL. It says US East 2. Or what you can also do is you can just check the region over here at this section of your AWS console. It says Ohio over here as well. All right, great. So now we have created a bucket. We have created a database, right? And now what is left is to deploy our server, which is going to hold our website basically. Okay, so let's create a server as well. So let me type in EC2 over here, click over it. And let's click on running instances. So here what I'll be doing is I will be creating a server, and the way I'll be creating it is I'll be creating launch instance. And what I want to do is I want to basically deploy an Ubuntu server. So I'll be selecting Ubuntu over here, right? Now in Ubuntu, what is the processor that I want to choose for my server? It will always be free tier eligible. So I'm going to choose that, click on next. Then how many instances do we want to launch? We just want to launch one instance because I want to show you how you can set up a website. Okay, so we're not going to change anything over here. And rest everything also, you will not change anything, just click on next. This is how much hard drive will be given to your system. So we will leave it at default, it will be 8 GB. We'll click on next. Now let's click on configure security groups. Now here you will have to select the default security group. It should already be there when you first create your account. Just select this and click on review and launch. Okay, now you can review all the settings that you want to basically check. And if everything looks good, just click on launch. And over here, you can either create a new key pair or you can choose an already existing one. So how to create a key pair, how to do, how to convert it, how to set the right permissions, everything has been taught to you in the previous session, which was at 5:30. So that was deploying virtual servers on AWS, right? You can just refer that as well to see how you can do it. Over here, I'm going to use, a key pair which I've already defined, which is basically going to be Mac Ohio. Okay, so I'm going to select this key pair, acknowledge that I have it, and click on launch instances. So now my EC2 is getting launched, so it will take some time. Meanwhile, let me see if you have any questions. So Prashant is saying you have shown the example of deploying a website. Is it possible to deploy components and compile my process in cloud itself? So Prashant, I think what you mean by this is deploying microservices in cloud. So yes, Prashant, that is possible to deploy too, right? The way to do that, there are multiple ways you can do that. I mean, if you're deploying a microservice, I don't think you should deploy it on one server. There are a lot of other services in AWS as well, which you can make use of. For example, you have something called as Elastic Container Service. So if you are a little more advanced in AWS and understand the services, you can actually deploy it over there as too. Okay. So now what I'm doing is I have just launched, my instance, and let's check the status for this instance. So first of all, let me name this instance something. So let me put it as Hemant-project. Okay. So my instance is now in the running state, which basically means it is all good. I can just refresh. And now we can try connecting to our machine. Okay, so let's select the machine. Let's select the IP address of this machine, and now let's try to connect to it. Now, how you can connect to it? You can basically connect to it using a terminal. So what I'm going to make use of is my terminal over here. Okay, and let me go to the place where I have saved the key for this server. Right. So the command is ssh-i./mike-ohio.pem. The username for my server is Ubuntu, and this is the IP address. So now I'm connecting to my EC2 server. It's going to ask me whether I trust this server. So yes, I do. And now it will allow me to connect to the server. Great. So I've connected to the server. Next thing that I'm going to do is I'm going to go ahead and connect to my RDS first to see if everything is working fine or not from the network point of view. Okay, so how can we connect to our RDS? First, we need to deploy a MySQL client on this machine, which will help us to connect to our RDS machine. So how can I install the MySQL client? So let me go ahead and update this machine first. So the command would be sudo apt get update. This will update the machine. Okay, so machine got updated. And now what I'm going to do is I'm going to install MySQL client. So sudo apt get install MySQL -client. Okay, this is going to take a while to install. Meanwhile, I'll just take up questions. So Nagamani is saying how to do this with Windows. So Nagamani, if you want to SSH into an instance, you will have to download a software called Putty, right? So I showed that in my previous session, which was at 5:30. You can just refer that after this session as to how to connect from Windows to a server that you can connect to, or you can just search online as to how to connect with a software called Putty to a Linux instance that you have deployed on AWS. Okay, so I hope that answers your question. All right, so now MySQL client has been installed on my machine, on my AWS machine, and now what I'm going to do is I'm going to try connecting to my RDS. Now for connecting, since I've installed MySQL client, the command would be MySQL -h, h being the host name of my database that I want to connect to. And for connecting to it, I will just go to my browser and go to the RDS service again. So what I need is the RDS URL. So let's go there. Okay, and now we can just select the database instance that we basically want to connect to. So I can just click on the database that I deployed earlier, and this is the URL that I'm looking for to connect to my instance. Okay, so I'll just select this, and let me see if any other information is required from my side. Okay, everything else looks good. So now what I'll do is I'll just enter the URL over here. So MySQL -h, the URL, then the username, which is Intellipaat, and then the password. So let me enter the password as well. And as you can see, I have successfully connected to my RDS and I am on the MySQL shell now. Okay, so before I move on, let me see if there are any other questions. So Nagamani is saying, other than using Putty for Windows, what are the other options? Nagamani, with various options, all you have to do is just search for how to use Linux machines from Windows. Other than Putty, you can also use Git Bash. Other than Putty, you also have something called a Super Putty, which you can also, it's a premium tool, which you can also use to SSH into machines. So Suresh is saying, can we configure this on Linux system instead of Ubuntu? So Suresh, the commands that I'm writing right now are for Ubuntu. If you want to do it for Linux, I think you will have to Google the commands. So what I've done is I've installed All right, so now that I'm inside the MySQL shell, guys, what I'm going to do is that I will go ahead and see if the database is actually initialized on this server. So I'll just type in show databases. and there's no database as of now deployed in this server. So what I'll do is I'll type in the command create database employee. So database is now created, and now I will have to create a table inside employee where basically my information is going to be stored. Okay, now what all information do I need to store in this table? That will be clear from our website, right? So what we can do is we can just check the code of our website and understand what all is required to enter in our website. So okay, in our database, so we need a column called employee ID, first name, last name, primary skills, location, and employee image file. Okay, so these are the things that we need to enter. I think this is not required because this is the SQL query, and here I just have 5 things that I'm inserting in SQL. So what I'll do is I'll just select these 5 options, and this is what I'm going to insert in my database. So I can just go ahead, I can create a table employee, and now I can just specify the column. So first column is EMP ID. Let's give the data type to be as varchar and the value to be as 20. After EMP ID, the next is first name. So let's give F name over here, and the value would be varchar 20. Then we can give last name. So last name again would be varchar 20. I'm just giving the default value as 20 characters. You can modify it if you want. Primary skill. So we'll give the primary skill to be varchar again, and the range would be 20 characters too. And then the location. So this would be the last column for our table, and here also we'll give 20 characters. Okay, it says no database selected, so I'll just select use employee. This will change our database, and now I can just copy the same syntax. Okay, it says I have an error, so let me just check what the error is. Okay, so I guess there are arrows which are causing the problem, so let me just copy it one by one. Employee, then EMP ID with the comma, then F name, then last name, then primary skills, which is this, and then the location. Okay, so my database is now created successfully. So if I type in show tables, it's showing you that the employee table has been created. Great. So now that my employee table has been created, I can actually go ahead and start configuring my website to work. Okay. Meanwhile, I'll just check if I have any questions. Okay. No more questions. Let's go ahead. So now what I'll be doing is I will be configuring my code. So let me just exit from MySQL shell, and let me exit from the EC2 server also. Okay. So I'm back to my local, and in my local, let me go to the code where basically I have my website. Now first, let's try to run the website on our local system, and then we will try to deploy it on the AWS management console. Okay, so let me open it in Sublime Text, our code. Here it is, and here I will have to first configure my website. So here I will be putting the host name of RDS. So let me get that. Host name is nothing but the endpoint. So let me copy it. So this is the host name. Next thing that I'll be doing is I will be copying the username. So username is nothing but Intellipaat. Then I'll be specifying the database. So the database would be employee, and the bucket name is emp-add, if I'm not wrong. So let me just go ahead and verify that. The bucket name has to be the same as what you have created in S3 service. So it's called add employee. So let me specify the same in my code as well. The bucket is called add employee, right? And then we will be specifying the region. So region is US East -2. Okay. So guys, this is the configuration that we have to do. Now I also have to specify the password over here. So password would be Intellipaat123, and don't worry, I will be deleting this database later. So you guys can be rest assured that this is not going to be causing us a problem. Okay, so now what I can do is I can go back to my code and let's see if we can deploy this website on a local. Okay, so website is on a local now, right? So let's see how the website looks like. So if I go to localhost, okay, so this is how my website is going to look like, guys. Okay, and when I enter the information over here, it has to go and now be stored in my MySQL database. Whatever information I'll be specifying over here, that information will be going ahead and be stored in my database. Okay, now what I can also do over here is now I will be making it available not on localhost but actually on my EC2, that is my web server. So let's see how we can do that. So first things first, I will actually have to go ahead and close this application, right? And now let's save everything. So I will be pushing it to GitHub. So let me stage everything on my local, commit it, right? And now let's just go ahead and push it. So what I'll have to do is I'll have to create a remote repository. So let me go to github.com. Now on github.com, let me create a new repository, and let's call this repository as AWS-live. Okay, it'll be a public repository. Let's click on create. Okay, so repository has got created. Let me add this in the origin. Added. And now let me push it to my website, to my Git. All right, so my website has now been pushed onto GitHub, so I can verify that by refreshing over here. And I can see that I have everything uploaded on this. Okay, so let me check config.py as well. Yes, this also has all the values. Great. Now what I'll be doing is I will be going ahead and pulling this code on my EC2 server. So let's see how we can do that. So let me SSH into my EC2 again. Okay, so I'm inside my EC2 now, and let me clone the code that I have pushed onto my GitHub. So now I have basically gone in. I have copied the code onto my EC2 machine, and now I can go ahead and deploy the code over here. Okay, so I'll just go into AWS-Live, and now I will first install Python 3. So what I'll have to do is, if you can, so I'll be sharing this GitHub with you. I think a lot of people of you might ask this question. So Suresh is saying outside network can connect automatically, or we have to do manually. So Suresh, right now I have configured everyone to connect. You don't have to worry, right? And what I'll do is I will just put this GitHub link on the chat so that every one of you can have a look at the code. Okay, so I've done that. And people on YouTube, you can actually just go to this link, which you can see over here, and then you'll be able to see the code as well. Okay, now that we have the code with us on our server, yeah, I was showing you the README. So according to README, we will have to install all these things. So we have already installed MySQL client. You can find all the commands over here, which have to be executed on your server. Right now, we will have to install Python 3. We'll have to install Flask. We'll have to install PyMySQL, and we'll have to install Boto 3. So what are these commands? So basically, Python 3 is the language that we have coded our website in. So this is the language that it has been coded in. So we'll have to ensure that it is existing on the system where we are basically running the website. Flask is a web framework which basically helps Python to go ahead and publish a website onto that server. And PyMySQL is basically a library which helps the website to connect to a MySQL server. Then you have something called as Boto 3. So Boto 3 are the AWS SDKs that are development kits, which basically help you to connect to your S3 service where you will be uploading your files. Okay, so these are the things that need to be installed. So let's go ahead and install it. And for that, what you'll have to do is just go to your server, and first let's install Python 3. So sudo apt get install Python 3. So Python 3 has already been installed. Next thing is that you need to install pip3. So sudo apt get install pip3. Pip3. Okay, so it has to be Python 3-pip. Okay, so now it is being installed on this server as well. So it will take some time. Let me see if you have any questions. Okay, no questions so far. Okay, I believe everyone is following along in that case, if there are no questions. All right, so now let's wait for this installation to get finished. So what we're installing right now is pip. So pip is nothing but a package manager for Python, which helps you install any libraries that your code might need. So it's got installed. And now what we can do is install the packages that are required. So pip3 installed by MySQL, and we need Boto 3. That will automatically be downloaded now for the code. And we also need to install Flask. So pip3 install Flask. Okay, so that also has been installed. Now, what if we try to connect to the website? The website will get launched successfully, but we will get an error. Let me show you how to solve that error. Okay, so now my website got deployed. So now what we were seeing on the local host, if you go to the EC2, that we deployed, which is this. And if I try to go to this IP address, you can see on this IP address, I am now able to see this website. But let me show you a problem that you might get. So let me enter my information. Primary skills, let's say it's AWS. Location, let's say it's India. Now we choose a file which we want to upload to S3. Let's choose an image which we can basically upload. Let's click on update database. So as you can see, you got an error which says unable to locate credentials. Okay, and if you go to your S3 management console and inside your bucket, that is add employee, you will not see any object or any file uploaded over here too. Now, how you can solve this particular problem? Now, in order to solve this problem, what you'll have to do is you will have to basically give your EC2 instance or your server access to basically upload data to S3. Now, how you can give access to your AWS instance? First of all, your question should be, why does your server need access to upload data to S3? So on this server, we are running some code, and that code is trying to interact with the AWS S3 service. Okay. Now, in terms of when you're connecting with RDS, you have passed in a username password. So it's all good. It has got the authorization, and now it's able to basically enter information inside the database. But let's now assume that instead of let's now assume that what is the authentication that we are giving for connecting to our S3 service? So there's no authentication, right? So for giving the authentication to your S3 service, what you have to give is an IAM role to your instance. And how can you do that? So there is a service in AWS which is called IAM. Just select this service. And in the service now, I'm going to go to users, not users, sorry, I'm going to go to roles. And I'm now going to create an admin role for my AWS account. Okay. So when I click on create role, it'll ask me which service is this role for, right? So this is a role for my EC2 service. So I'll select that. Okay. So once you have selected EC2, next it'll ask for permissions. So what kind of permissions do you want your EC2 to get? So when you say permissions, now you're giving access to different services in AWS. Okay. Now for this demo's sake, what I do is I just select administrator access. That is, this EC2 can actually interact with any service in AWS. Okay. We'll give it admin access. We'll click on next and we'll click on review, and let's give this role a name. Let's call it as AWS Live. Okay. And now let's click on create role. So now the role got created, and now if I go to my EC2 dashboard, now I will have to select my server. This is my server Heyman project. I will click on actions, and now I'll go to instance settings. Okay, and in instance settings, I will go to attach or replace IAM role. I'll click there. It's right now is not having any role. Now I'll give it a role which is basically AWS Live, which is over here. I'll select it, click on apply, and the EC2 now has the correct role to basically upload data to S3. Now let's see how we can do that. So right now I'm getting this error that is unable to locate credentials. So what I'll do is I'll just try to connect to the website again, enter the same information. So now let's change the employee ID. Let's enter John Doe. Primary skills AWS. Location, let's say it's India. Image, let's choose an image that we want to upload. This is the image that I want to select. Let's click on update database now. So now my image is getting uploaded, and as you can see, it says following image has been added to the database. Right now, if I go to S3 and if I hit on refresh over here, you can see a file has been added over here, and this is the exact file that I chose, which needed to be uploaded to S3. At the same time, if I try to connect to my MySQL, so let me connect to MySQL from my local host. So let me just check one simple thing, guys. Give me 1 second. Okay, now let's try to connect to our RDS. So my RDS has this URL. Let me pass this URL. This is the username. Let me pass in the password. Okay, let me use the employee database, and let me select star from employee now. So as you can see, earlier I entered Hemant Sharma AWS India, but at that time my image did not get uploaded because the credentials were not there. This information got inserted, and similarly my John Doe data has also been inserted successfully. Now let me do one thing, guys. I'll just give this IP address to you, and all of you can try entering your information here, and this information will then be reflected in my database. So I'll just give this IP on the chat on my GoToWebinar, and you can go ahead, connect to this website and enter information over there, and then you will be able to see your data on the MySQL also. Okay, so once you've done that, just type in yes in the questions, and then I will just go ahead and show you guys that your image also has been uploaded to S3 and your data is also being reflected on MySQL. Okay, while you do that, now let's move on to the next step. So this part of my architecture is done. My EC2 is now connected to RDS. My EC2 is now connected to S3. We have our website deployed over here. Now let's see how we can basically route a domain like this to my EC2 server. So right now we are trying to connect using an IP address, right? But I do not want to connect using an IP address. What I want is I should have a domain. I should have a proper domain which can be used to connect to my website. Now, how can I do that? So for doing this, what I'll be doing is I will be going to a service called Route 53 in AWS. So let me just type it out. This is the Route 53 service. Okay, so and here we will have to create a hosted zone. Okay, let's create a hosted zone. Click on hosted zone, type in the domain name. Now this domain name, guys, has to be purchased by you guys. Okay, so if you want, you can actually purchase a domain over here, right? It says a .com account is $12. You can just check all the things over here, and any domain that you want, just enter the name here. It will check if it is available or not, and you can purchase it straight from the AWS management console. Or for demo purposes, what you can also do is you can create a free domain. So I have created a free domain from a website called Freenom. So let me show you how that website looks like. So just go to freenom.com, sign up yourself over there. And then what you can do is you can create your own domain name, right? All you have to do is once you're signed in, click on services, click on register a new domain. Okay, so when you click on register on a new domain, it'll basically just ask you the domain name that you want to you know basically avail for free. So let's say I want to avail hello world Intellipaat. Let's say this is the domain that I want to select. So I'll just click on check availability, and if this domain is available, it will tell me that it is free and it is available right now. I'll just click on get it now. It'll say it's selected. I'll check out. Again, it will be valid only for 3 months, guys. Remember this. If you're buying it for free, it will be valid only for 3 months. Click on continue and click on complete order once you have agreed to the terms and conditions. So now once you get to this order confirmation page, it basically tells you that you have bought this domain successfully. Now go to services, click on my domains, and you will be able to see your domain over here. This is how you basically subscribe to a domain on Freenom. Now what you'll have to do is you will have to select AWS. Okay, so now I already had a domain which I had followed the same process for. Right, it is exactly the same in the same state. I have not configured this domain to do anything. I'll be showing you the configuration now. Okay, so I'll be going ahead with this particular domain, aws-project.tk. Let me click on manage domain. And from here in manage domains, I will have to go to management tools and I will have to go to name servers. Once I am on name servers, I'll have to select use custom name servers, and then we'll have to fill out this information. I'll show you how to fill out this information in a minute. Let me see if you have any questions. Okay, Nagamani says he has entered some information. Okay, Nagamani, let's check if your information is there. So let me see in the S3 service first. If you have uploaded any files, so yes, there are some files being reflected over here, right? And now let me check in my database if I have any values. So select star from employee. And yes, there has been an entry for the name Bhumika, and there's also an entry for Arjun. So I can see 2 guys have updated their information. Great, guys. So you can see your information on the screen now. All right. Moving forward, now let's go ahead to and let me show you now how to enter this information. Okay, so now what I'll be doing is I will be going ahead on my Route 53 management console, and I will be creating a hosted zone. So I click on create hosted zone, and you have to specify the domain name over here. Now this domain name will exactly be the same as what you have specified in your free norm. So I have my domain name as aws-project.tk. Okay, we'll be selecting this, click on create.
Let's have a quick quiz question, guys. And the question is, which AWS service is used for real-time messaging and communication between microservices? And your options are Amazon MQ, Amazon SNS, AWS Step Functions, or Amazon Simple Queue Services. Please mention your answers in the comment section below.
And then you will reach this screen on Route 53. Now these are your name servers, guys, that you see over here, and these have to be filled out over here in Freenom. Okay, so let's fill these out. So what I'll be doing is let's select these and select these name servers one by one. So let's select the first name server, copy it, paste it here. Let's go ahead and select the second name server now, copy it and paste it here. Select the third name server, copy it, paste it here. Similarly, the fourth name server, which is this. So there are in all 4 name servers that AWS gives you, and you have to copy all the 4 in your Freenom dashboard. Okay, once done, click on change name servers, and your changes have been saved successfully. Now your Freenom domain can connect to your Route 53 service correctly. Great. Now you have to connect your Route 53 service to your EC2 server that you have deployed. Let's see how you can do that. So now you will have to click on create record set. Right, specify an IP address over here, and that IP address will go basically here in the value. So let's select our EC2 IP address, which is this. Let's select it, and let's paste it in our Route 53. So here is the IP address. We will not enter anything in this field, right? And let's click on create. So your record has been created. Similarly, create one more record set, enter www, and enter the IP address, same IP address over here, and click on create again. So you're entering 2 informations over here. One is with www and one is without www. Okay, and you have basically forwarded this to your EC2 instance IP address. Now if you go ahead and type in AWS-project.tk on your browser, it should take you to your website. So all of you now, you can go ahead and type in this URL, and you will be be able to access the website that we have just launched. So just go ahead and type in AWS-project.tk on your machine. So let me also put it on chat. Just type in on your browser, and you should see this page that is visible over here. Just confirm me in the chat, guys, once, all those who are there in the webinar. On YouTube also, guys, just type in AWS-project.tk, and then you should be able to see the website. Please confirm us in the chat so that we know that it is working correctly. Okay, it is working for Nagamani. Others, guys, please try it out. Ramesh says it's not working for him. Okay, Ramesh, just type in www also in front of it. I think it should work out. Okay, so with this, guys, we have successfully configured a website. Let me also try it in incognito once, so that we know this is not something which is being picked up from my cache. So aws-project.tk, and then we'll type in www. Okay, so on YouTube, I also see that Jerry King is saying it's working. Great, Jerry King. Thank you for the confirmation. And yes, it is working in incognito as well. Okay, so Madhu says it's working. Ramesh says working with www. Great, guys. Ramesh, in some time you can also access it on without www also, because since it's DNS, sometimes the settings, it takes time to be implemented across all the DNS servers which are there. The 4 DNS servers that we defined. Every time each user does not connect to the same name server. Everyone is connected to different name servers based on the load which is there on the server. After some time, even AWS project.tk will work. Okay, so with this, guys, we have come to an end to our AWS session, right? So I just showed you today how you can go ahead and deploy your own website end to end on AWS without worrying about how you have to deploy servers, what settings you have to do. So I've showed you each and every step in this video. I have also showed shared the GitHub on the webinar, right? So we can actually go ahead and pull the code by yourself and try this on your own too.
Just a quick info, guys. Intellipaat offers advanced certification in DevOps and cloud computing in collaboration with IIT Pravartak, a technology innovation hub of IIT Madras. This online advanced certification in DevOps and cloud computing by IITM Pravartak will help you gain expertise in DevOps, access management, DevSecOps, Terraform, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel. The link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take your first step towards career growth in the field of cloud and DevOps.
So let us begin with AWS beginner interview questions. First we have, what is AWS? AWS stands for Amazon Web Services. It is an Amazon service that uses distributed IT infrastructure to provide various IT resources on demand. It offers a variety of services including infrastructure as a service, platform as a service, and software as a service. Next, what is EC2? EC2 is a cloud-based virtual machine over which you can have OS level control. You can use this cloud server whenever you want and when you need to deploy your own servers in the cloud, similar to your on-premise servers, and when you want complete control over the machine's hardware and updates. Third question, what is VPC? VPC is an abbreviation for Virtual Private Cloud. It enables you to personalize your network configuration. A virtual private cloud network is logically isolated from other networks in the cloud. It provides you with your own private IP address range, internet gateways, subnets, and security groups. Fourth question, what are key pairs? Amazon EC2 employs public key cryptography to encrypt and decrypt login information. In public key cryptography, the public key is used to encrypt the information while the private key is used to decrypt the information at the receiver's end. Key pairs are the combination of public and private key. Key pairs allow you to securely access the instances. Then, what is AWS Lambda? AWS Lambda is a compute service that allows you to run your code without having to manage servers. The Lambda function executes your code whenever it is required. You only have to pay when your code is running. Sixth question, what role does buffer play in Amazon Web Services? An elastic load balancer ensures that incoming traffic is distributed as evenly as possible across multiple AWS instances. A buffer will synchronize various components and make the arrangement more adaptable to a burst of load or traffic. The components are prone to receiving and processing requests in an unstable manner. The buffer creates an equilibrium between various devices and trains them to work at the same rate in order to provide faster services. Seventh question, why do we make subnets? Subnetting is the process of dividing a large network into smaller ones. These subnets can be formed for a variety of reasons. Subnets, for example, can help reduce congestion by ensuring that the traffic destined for a subnet stays in that subnet. This aids the efficient routing of traffic entering the network, which reduces the network load. Eighth question, what is the maximum number of S3 buckets you can create? There is a limit of 100 S3 buckets that can be created. Ninth question, what are the characteristics of Amazon Cloud Search? Amazon Cloud Search features autocomplete advice, Boolean searches, entire text search, faceting term boosting, highlighting, prefix searches, and finally range searches. 10th question, what is a hypervisor? A hypervisor is a piece of software that allows you to create and manage virtual machines. It combines physical hardware resources into a platform and distributes them virtually to each user. Oracle VirtualBox, VMware Fusion, VMware Workstation, and Solaris Zones are examples of hypervisors. Let's move on to AWS intermediate interview questions. First, will your standby RDS be launched in the same availability zone as your primary? No. Standby instances are launched in different availability zones than the primary, resulting in physically separate infrastructures. This is due to the fact that the entire purpose of standby instances is to prevent infrastructure failure. As a result, if the primary instance fails, the standby instance will assist in recovering all of the data.
Let's move on to the second question. Your company wishes to send and receive compliance emails from its customers using its own email address and domain. What service would you recommend for accomplishing the same goal in a simple and cost-effective manner? So for this purpose, Amazon Simple Email Service, which is also known as Amazon SES, a cloud-based email sending service, can be used. Third question. You unintentionally terminated an EC2 instance in a VPC with an associated elastic IP. What will be the outcome if you restart the instance? So elastic IP will be disconnected from the instance only if it is terminated. There will be no change to the instance and no data will be lost if it is stopped and restarted. Fourth question. Can I vertically scale an Amazon instance? How do you do it? The answer is yes. Start a new larger instance than the one you're running, then pause it to detach and discard the root. EBS volume from this server then stops the live instance and disconnects its root volume. Take note of the unique device ID, then attach that root volume to the new server and restart. You will have scaled vertically this way. Fifth question. How can you send a request to Amazon S3? You can send requests by using the REST API or the AWS SDK wrapper libraries that wrap the underlying Amazon S3 REST API. And for the sixth question, what are the various types of load balancers available in EC2? In EC2, there are three types of load balancers. First, application load balancers. They are designed to make routing decisions at the application layer. Then we have network load balancer. A network load balancer handles millions of requests per second and aids in transport layer routing decisions. Then we have classic load balancer. The classic load balancer is primarily used for applications developed on the EC2 classic network. It provides basic load balancing across multiple Amazon EC2 instances. And for the seventh question, define Amazon EC2 regions and availability zones. The availability zones are geographically distant areas. As a result, EC2 instances in other zones are unaffected if one zone fails. Regions may have one or more availability zones. This configuration also aids in latency and cost reduction. Eighth question. Explain Amazon EC2 root device volume. The root device drive contains the image that will be used to boot an EC2 instance. When an Amazon AMI launches the new EC2 instance, this happens. An EBS or an instance store can support this root device volume. In general, the lifespan of an EC2 instance has no effect on the root device data on Amazon EBS. Ninth question. What is an elastic transcoder? To support multiple devices with different resolutions such as laptops, tablets, and smartphones, we must change the video's resolution and format. This is easily accomplished using an Amazon Web Services tool called the Elastic Transcoder, which is a media transcoding in the cloud that precisely allows us to do the necessary. It is simple to use, affordable, and highly scalable for businesses and developers. Can S3 be used with EC2 instances? And if yes, how? Amazon S3 can be used for instances with root devices that are backed up by local instance storage. Developers will have access to the same highly scalable, reliable, fast, and low-cost data storage infrastructure that Amazon uses to run its own global network of websites. Developers load Amazon machine images into Amazon S3 and then move them between Amazon S3 and Amazon EC2 to run systems in the Amazon EC2 environment. And finally, we have AWS advanced interview questions. Let us look at the first question. What exactly is the distinction between a spot instance, an on-demand instance, and a reserved instance? Spot instances are unused EC2 instances that can be used at a reduced cost by users. When using on-demand instances, you must pay for computing resources without committing to a long-term contract. In contrast, reserved instances allow you to specify attributes such as instant type, platform, tenancy, region, and availability zone. When instances in specific availability zones are used, Reserved instances provide significant cost savings and capacity reservations. Second question. Your company wants you to propose a solution for connecting the company's data center to the Amazon cloud network. What is your suggestion? By establishing a virtual private network between the VPC and the data center can be connected to the Amazon cloud network. A virtual private network allows you to create a secure path or tunnel from your premises or device to the AWS global network. Third question. Define snapshots in Amazon Lightsail. Snapshots are point-in-time backups of EC2 instances, block storage drives, and databases. They can be manufactured manually or automatically at any time. Even after they have been created, your resources can always be restored using snapshots. These resources will also carry out the same functions as the originals from which the snapshots were created. Fourth question. What happens if the content in CloudFront is not present at an edge location and a request is made for it? The content will be delivered directly from the origin server by CloudFront. It will also keep the content in the cache of the edge location where it was missing. Fifth question. Can you change the private IP address of an EC2 instance while it is in running or in a stopped state? The answer to that is, it cannot be altered. When an EC2 instance is launched, it is assigned a private IP address at boot time. This private IP address is assigned to the instance for the duration of its existence and cannot be changed. Then, what are the native AWS security logging capabilities? AWS CloudTrail, AWS Config, AWS Detailed Billing Reports, Amazon S3 Access Logs, Elastic Load Balancing Access Logs, Amazon CloudFront Access Logs, Amazon VPC Flow Logs, and other native AWS security logging capabilities are available. 7th question. How can you recover or log in to an EC2 instance for which you have lost the key? So if you have lost the key, follow the steps below to recover an EC2 instance. First, check that the EC2 config service is up and running. Then, remove the instance's root volume. Then, connect the volume to a temporary instance. And then, change the configuration file. And finally, relaunch the original instance. 8th question. Which of Snowball, SnowEdge, and Snowmobile is best option for transferring large amounts of data? AWS Snowball is essentially a data transport solution for moving large amounts of data in and out of an AWS region. AWS Snowball Edge, on the other hand, adds additional computing functions in addition to providing a data transport solution. The Snowmobile is an exabyte-scale migration service that can transfer up to 100 PB of data. And for the 9th question, what happens when one of the resources in a stack cannot be created successfully? If a resource in the stack cannot be created, CloudFormation automatically rolls back and terminates all resources created using the CloudFormation template. This is a useful feature if you accidentally exceed your elastic IP address limit or do not have access to an EC2 AMI. And the last question, what are some of the best security practices for Amazon EC2? Amazon EC2 security best practices include using identity and access management to control access to AWS resources, restricting access by only allowing trusted hosts or networks to access ports on an instance, only opening up those permissions you need, and disabling password-based logins for your instances launched from your AMI.
Just a quick info, guys. Intellipaat offers advanced certification in DevOps and cloud computing in collaboration with IIT Pravartak, a technology innovation hub of IIT Madras. This online advanced certification in DevOps and cloud computing by IIT Pravartak will help you gain expertise in DevOps, access management, DevSecOps, Terraform, and more. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel. The link is given in the description below. Without a doubt, this course can set your career to new heights. So visit the course page link given in the description below and take your first step towards career growth in the field of cloud and DevOps.